Faster. Stand up and squeeze towards the middle so we can have more people on the ends as they wake up and come in. Thank you. Okay. We'll be back in 1 minute. No, it's flaky. I was just thinking that same thing. It's been going through, but maybe just our website. I can get on. Is Proximus a local telco company? Yeah, I'm actually on data there, so the Wi-Fi. There's Toshi AP. You want me to send a patch to update the schedule? No, I mean, once.
Let's change. Oh no, let's change. Yeah, let's change.
I didn't realize. Yeah, you're right. It's pretty tough. Is this still? This is when it's supposed to crash, right? It's your call. Oh, you're looking at something. You said if you're good to go.
Hey Tosh and Adam. Nice to meet you.
Mr. Sponsor. What about it?
nice to see you not skiing. Oh,
Good morning, everyone. Sorry again. Good morning, Ghent. Thank you. So I'm the hype man this year because I figured we all know that Chris and Toshan, as well as the other organizers, but these two especially, have been really working it to make this conference a crazy success. Toshan has not slept in about 3 weeks, and Chris has also been super busy organizing. So instead of them coming up here and giving the intro, I thought I'd come up here, get the crowd hyped, and please give a huge warm round of applause for Chris and Toshan.
Thank you, Jay. Did you? Oh, yeah. Okay, this is gonna be 5 minutes of awkward. This is way too low for me. Welcome back.
Grab it.
Okay, so next to my advice about James, don't let him babysit your kids. There's people in the audience who know why. Now there's also the advice, don't let him fool around with microphones. So yeah, welcome back. It's been a while. We have a full room again. There's an overflow room. We have hashtags on, now it's not only Twitter, but also Mastodon. For those who are not on the wireless yet, it's the same as last time, so your laptop might just have reconnected. My phone did. There's one slight change for logistics for today. Typically, we have the overflow room and the second track in the B building. Today only, it's going to be in the C building. So you're basically going to have to go outside and go all the way up to C1, 155. There's already people there. The first talk after the break in that room is going to be Michael Code.
It's a 5-minute walk.
It's a 5-minute walk there.
And there should be signage.
There is signage. I checked the signage. The evolving door on the front of the building is broken, so you need to take the small side door. But that's about the only annoyance. Yeah. This is Config Management Camp. This is, for some of you, day 4 or day 5 of conferences after FOSDEM. Day 7? Okay, Toshan is day 7. As usual, the reason why we started this conference ages ago is because we wanted different communities to talk to each other and to learn from each other and to figure out how they had fixed problems before, so other people don't need to reinvent the wheel. And I think this picture is still striking. This is an MGMT contributing who was tweeting about the Vox Populi contributor talking at Puppet Contributors Summit with a Habitat t-shirt. And yeah, DevOps Days Ghent organizer ruined the picture. So there's like a lot of communities mingling. A bunch of tools have changed, a bunch of tools have evolved, some have disappeared, some are still here and still going strong. But I think what brings us all together is we want to do infrastructure automation with open source tools, and whatever new tools are going to pop up and we're going to learn about today and tomorrow, that's why we are here. You've had coffee, you've had some croissants and stuff. The resto is open. Toshan, there's discounts if you have wristbands, and the wristbands...
Or if you have your entrance ticket, just show it and you get a menu at a discounted price. It's €8 for a menu then. So that means you get soup, main dish, and a drink.
And obviously, speakers come and see us because we have vouchers for you. There is a third day, the fringe of the fringe of the fringe. please register for the workshops you want to go to, so we can actually reshuffle rooms if we see that there's more people interested in certain topic than others. Then we make sure that we don't give MGMT a room that seats 3, but we actually give it the size it deserves, which is 5. This morning was a bit of a... We weren't sure what the order was going to be. But right now, we're quite sure. Adam is sitting right there. He made it in time. So Adam is going to open. Then we're going to have Lee breaks. Then there's going to be a break. And then we're actually going to split out. Jerry is going to be in this room. Code is going to be in the other room. And after that, we have Ignites. There's at least 2 people who still need to send me their slides, but I don't see Lander and I. Well, slides for the Ignite for today. So David, you're still fine. I don't see Philip and I don't see Lander. So if you bump into any of them, they still need to send me your slides. I prepared this slide, and for now it's no changes, which is a miracle. And I'm actually going to give the word to Toshan now, because he's going to talk about the people that, besides a bunch of us and Bert, make this happen.
So yeah, we have sponsors. Ansible is our titanium sponsor. You know them from the tool. They're owned by Red Hat, by IBM, whoever you want to talk about. So they help us. They have a booth. If you go visit the booths of all the sponsors that have booths, you can get your wristbands. They give you discounted lunch, but they also give you free drinks on the social event. Then we have GitLab. They actually have a fringe day. So tomorrow and Wednesday, they have their hack day. You have AT Computing, Axis, Betadots, Isinga, Puppet, and Freelance. They all have booths in the main hall. Again, if you visit them, you get swag. You can get to talk to them, and you can get wristbands from them. The next one is Inuit, Firefly, Kangaroot, SIGHUB, ATIX, Pulumi, and Red Hat. In this case, it's Red Hat with Foreman and Pulp. Again, they always have a booth there. You can visit them. They'll explain you all the sales stuff. And then we have the silver ones. So Synatoso, HashiCorp, CF Engine, Skyscrapers, and Synchromind. They do not have booths, but they are still very good sponsors. You might know HashiCorp from their tools or CF Engine. A few of the other ones are different type of solutions. Then you have the core sponsor, so HoGent. So Bert there, he wasn't thanked in the introduction, but he's the one who gives us the venue. So thank him at least. Then you have Inuits again, so that's Chris's company. And then you have Fantosh, my company. We have Han from CityTV. And in the other room, we have Mark from SIG.io. They help us with all the video and media stuff. We have Compass, so that's the company that actually does the catering for the university. They were friendly enough to do discounted prices for the menu, but they're also helping us out actually with the coffee and the breakfast, which means that we have more time to do other stuff. And then we have a bunch of bronze ones, so Famipau, Sys11, Vox Pupillae, and Rudder. So that's all of the sponsors. We do have a social event, a beer event, a community event. You go towards the C building, so the overflow of today. You walk out. There is a little crossing. Be careful that you don't get killed there. And then you can go to the zone, it's called. Like I said, you need a wristband to get free beer. You will get for a limited time free beer. There will be food. And you can stay there as long as you want, but we will close the tab at some point, and then you can keep on drinking on your own expenses. And that's it for us. Enjoy. Adam should be our first speaker.
Yeah.
What do you want me to plug into? It just went somewhere obvious.
Fell on the floor.
Do you have power? I mean, I'm going to be tapping on it. It's probably fine.
Yeah, here we have power.
It's fine. I got it. Sure. I can already tell this is going to be a whole thing. Yeah, that's better. Can you hear me? Yes. Sweet. Okay, let me fiddle with displays. How's everybody doing? Everybody's good? It's been so long. It's so nice to see everybody. I woke up this morning. I was in fucking Europe. That's pretty cool. I like Europe. Multitasking. Everybody's like, dude, you suck. What a room full of people that have to do this in front of, right?
Sure you're in IT?
No, I'm a fucking executive. Yeah, I'm a CEO, man. What the fuck do you think I am?
You have people for you.
Yeah, I got my bitches or whatever. Sorry, was that inappropriate? I think it is. Okay, wait. Don't mirror it. Yeah. Okay. Fuck yeah. Okay, so then this goes that way.
You're scary.
You said I'm scary? I'm not scary. Okay. Whew. Wow. Okay. Great. Hi. Oh yeah, you're gonna. Oh, look at that. You're gonna make it
We
go
have
away.
got some stuff here for the broadcast.
So I have to
on
stay
the
close.
internet.
Yeah. So
Well, if you don't go over there, then
don't go over there. Got it.
does this suit you, sir?
I'm good if I'm this way. Yeah.
Is this okay?
Yeah, it's great for me if it's good for you. Okay. Hi. My talk is called "What If Infrastructure as Code Never Existed." I'm Adam Jacob. I'm not going to spend a bunch of time on my biography, but once upon a time I wrote a thing called Chef. That's probably why you remember me. Some of you I remember. Hi. I haven't been in a room like this in, well, I don't know, longer than 3 years, because before that I had quit and fucked off and played Dungeons and Dragons. So, Paul Stack, raise your hand, Paul. This is Paul. Paul came up with this talk title. They were like, you should give a talk at Config Management Camp, and I was like, yeah, I should. You're right. But then that meant I had to come up with a talk that fit the incredible talk title, right? Because it is really it's a really great talk title, right? And so to figure out the answer to what do you do when someone hands you that incredible talk title, I want to tell you a story. So my first job in technology was at an ISP in the back of a dentist's office. So to go to work, my mom would drive me to work. I was 15. She would drive me to work. She would drop me off at the dentist's office. She would walk past people getting root canals and cleanings or whatever, and you would go past them into this back room, and there were 2 telco racks in the back room, and we'd put modems in them and some servers running BSDI. Who ran BSDI? Anybody remember BSDI? What's up? Fucking love you guys. Okay, guys. Trying not to say guys. I've been replacing it with all y'all motherfuckers. So every time I say that, you're gonna hear me then say all y'all motherfuckers. I also swear more the more comfortable I get. So every time you laugh when I swear more. So anyway, thank you. Okay, so they would drive me. My mom would drive me to work, and it was in the back of this dentist's office, right? My job was tech support, but then I'd been running bulletin boards since I was 8, and so I knew how everything worked. And so then there was a systems administrator who was in community college. He was 21, and he was covered in black, and he had piercings, and he loved Skinny Puppy. Do you remember Skinny Puppy? He had a really hot girlfriend, and I thought that was cool. And so then I became the junior systems administrator, and I'm now 45. So that means that I've been working in technology for 30 years, which makes me feel old. But it means I saw a lot. I saw Web 1, I saw the internet happen, I saw Web 2. I was definitely in the .bomb era. I built a company called Chef. I was there when Velocity started. I was here when DevOps started. And I saw kind of all of it happen. And so when I was 22, a couple years later, I was working for a different internet company, and I was also recently divorced. So who's been divorced? You been divorced? Getting divorced sucks. It's better than being married to the wrong person, so do that. Like, if you need one, get a divorce. It's better. But, so that was weird, right? Was that weird? Maybe not, because some of you are Dutch, and you're probably like, yeah, get a divorce. Okay, so, but I had also just discovered alcohol. How many people remember discovering alcohol? Yeah. And my new girlfriend loved alcohol. And so she was like, she was one of those people that she was like, let's get ripped. And I was like, okay, let's get ripped. So I was, at this moment, very passed out and really drunk and like happy with my lot in life. But then this thing goes off. How many people carried one of these? Yes. So the pager goes off like 4 times, right? Because I definitely didn't wake up the first time. And then eventually the second time you're like, they'll page someone else, right? And then like the third or the fourth time you're like, oh, I better answer the pager. So I like roll myself out of bed and I call him back on the landline because cell phones were expensive, right? And I call my boss back. And an important note here is that my boss was a retired Marine Corps colonel. Not this Marine Corps colonel. Does anybody know who this is? Who is it? John Boyd, that's right. Right? I really wanted someone to know who it was. It's important that you know, right? It's the OODA loop guy, right? Thank you. Yeah. So, and he's in a panic. And so I call him and he's like, Adam, why didn't you answer my page? And I'm like, well, And he's like, the site's down, you gotta come, we gotta fix it right now. And I'm like, no can do, Pikachu, I am super drunk, right? I'm not like a little drunk man, I am ripped drunk. And he goes like complete full drill sergeant. He's like, soldier, you will get out of bed and you will get in the shower and I will be at your house in 10 minutes. We're gonna fix the servers. And I'm like, what? I'm drunk. He's like, you're not drunk. Sober up. Bring coffee. And so he's like, get in the shower. And so I like get in the shower and I'm like, my boss, So he like whips over to my apartment in one of these guys, right? Pulls up at like 100 miles an hour, pops out of the car. He's got a cup of coffee and that like Marine Corps pep in his step. You know what I'm talking about? That like, right? And piles me into his car. I barely can walk. The world's spinning around. I'm drinking the coffee. He's like going 100 miles an hour. It's real dark. And he hauls ass to the data center. So we get to the data center, we grab a crash cart, we plug it into the servers, and he proceeds to just give me a full-on pep talk. He's like, soldier, we're gonna fix the servers. We're gonna bring the site back up. We're gonna make some money, And I'm like, okay, I'm gonna do it. He's like, log in. I'm like, logging in, And he just like marches me through it. And then he's like, and figure out what's wrong. And I'm like, I'm so drunk. He's like, you're not drunk. We're not gonna die here, And I'm like, okay. And then I fix the servers, And I make the site come back up and we start making money again and he's like, great job, soldier, no one died here. Let's get breakfast. And he drives me to breakfast, drives me home, shakes my hand, says I did a good job. And that is pretty much what the last 30 years was like. Kind of for everyone, yeah? It was just this series of Christitunities, right? First we had to get everybody on the internet. Remember getting everybody on the internet? Some of you do, I can tell, you're old. Everybody else is like, no, right? Because we were already on the internet. And then we had to put content on the internet, because all these people showed up, and they didn't want to just like, whatever, read my GeoCities page. And so then we had to build applications on the internet, because it was like, hey, remember when it was cool? We could put a map on the internet. Remember that? That was cool. And then we had social media. We were like, what if all our friends were on the internet, right? And then we could show them pictures of food. And then we did. And then digital transformation. Suddenly all the companies on the planet were like, what if we were social media companies? And then that'd be cool. We could just run like Facebook and Google. And we were like, great, we'll do that for you now. And so we've just been doing that over and over and over again for 30 years. And essentially each one of those bullet points had some version of that Marine Corps colonel right behind us being like, figure it out. Please, God, fuck. Figure it out, right? It was a very creative time. Not just for me, but I think for everybody. Problem after problem, solution after solution, like musicians, kind of swept up in a cultural movement. I think we just made it all up as we went along. And when we started, there weren't any rules that made sense. I remember picking up the few books that you could find on systems administration early in my career, and they were just loaded with lies. You know, they were like, you know what a good idea is? To plug a printer in to your server and print out syslog. That way you have a hard copy in case you get hacked. How many of you did that? I did. For like a minute, and I was like, no! Okay, we came in, we were so fucking proud, and we came in that morning, and it was just like the room was full of paper, and we were like, oh no, what have we done? And it wasn't just those, like every single thing we did, rule after rule after rule, we basically just made them up. And now, though, we're 30 years in to sort of making up those rules, and I gotta tell you, y'all basically accept most of them as if they were laws of nature. You just do. You're like, well, of course we do it that way. It's the only possible way it could have worked. And I assure you, they are not. At best, they're like guiding principles. Maybe creative criteria, like the box in which you could create. This is Rick Rubin, and Rick Rubin had this to say about rules. He said, rules direct us to average behaviors. If we're aiming to create works that are exceptional, most rules don't apply. Average is nothing to aspire to. And that is why Paul Stack wrote an incredible talk title. Because it's an invitation to break the rules. It's an invitation to explore and to create. And as a movement, we're kind of stuck in a rut. We're a little playing our own greatest hits. That's one of the reasons I left Chef, is I found myself in a room and I was basically explaining the same thing I'd been explaining for a decade, and it was gonna work and they were happy, but I was like, oh. Like there's no juice, no dopamine for that moment. It was just I was playing myself on TV. And I think as a movement, we're basically just doing small variations on the theme for the same essential outcomes. No, not really that much better, not really that much worse, just a little different. Average. It's kind of fucking boring. And we desperately need to start breaking some rules again. And so that's what we're gonna do. We're gonna just spend the rest of our time together breaking some rules. You wanna break some rules? Yeah. Yeah, let's break some rules. I got a list of rules right here. And what we're gonna do is you're gonna shout out to me which rule you'd like me to break. And then I'm gonna break it. And then when we get to the end of that rule, we'll come back to this slide and we'll do it again. Yeah? And we're not gonna be able to break all the rules, I expect, before time expires. But, you know, a couple. So I know that you're European and you don't like to talk, although that guy, what's up, shout out to my homie, who was willing to like get it done. So let's go, let's pick. Which rule would you like me to break?
Single source of truth.
Oh, did you say configuration is code? That was amazing. That was very thoughtful of you. So here's the thing. We have to break this one first, because if we don't, I think it's nearly impossible to imagine breaking the others, right? All the other rules just don't even fucking make sense, because everything we do sort of stems from this one historical decision. So let's talk about where that rule comes from. This is sendmail CF. This was the original configuration syntax for sendmail. I can hear by the grumbles that I'm not alone in having written a sendmail CF file. The first sendmail CF file was written 41 years ago. So depending on who you are, you want a nap. Raise your hand if you wrote one by hand. Sendmail CF. God, I love this fucking room. You're just so much my people. See, I told you I'd get comfortable and swear more. How do I not love all y'all motherfuckers? Okay, so it was a nightmare, is the TLDR. If you didn't write one by hand, you don't need to know. This is the most straightforward syntax I could find. I didn't show you rewriting rules, which were basically line noise. There were huge books written out. It was awful. It was terrifying. So 31 years ago, they switched to this. This is a sendmail.mc file. They used M4, which is a macro preprocessing language, to basically just generate that sendmail.cf file on your behalf. This was 31 years ago. So for me, there were some distributions that had sendmail.mc, but most didn't. So when I first started running ISPs, we wrote CF files by hand. Still, we had a couple of years to go before the sendmail.mc thing really landed for everybody. But suddenly things were so much easier. They were so much more dynamic. And for me, this was the first time I remember writing code for configuration. The idea that what I was going to do was write code. I was going to write a program which generated the configuration file, which then was the thing that I wanted to run. I'm sure that somebody did it before, but this is the first time I can remember doing it. Has anybody ever used Helm? Helm is sendmail.mc for your YAML. Yeah? And you chuckle, but you know it's true. Okay, so look, this is a snippet of Terraform. There's a direct line from sendmailmc to Terraform, right? Like, what is it we're doing? Well, it's really complicated to write all the AWS API calls that do all the things that make that EC2 instance happen in the world. So what do? We wrote a little language, little macro preprocessor, if you will, and it took in our context, and then it did some stuff and moved on. We changed the syntax, we gained some power, we changed the domain, but essentially, everything we've done this whole time works roughly this way, right? Some human being writes some code, they ship it to an interpreter reads it in, does some junk, then does some stuff to the world, right? It either, in the case of Terraform, it does some stuff to AWS, right? Same with Pulumi, same with CDK. I'm doing a lot of hand waving on the stuff in the middle, yeah? But roughly, that's what they're doing. And they all kind of store some intermediate state somehow, right? Because we read the code in, we do some stuff, then we remember what we did so we can come back to it later, yeah? So what's good about that? Well, it's flexible. It's certainly maybe less verbose, you know, if you think about the delta between writing it all by hand versus writing it in some kind of code, it's probably better. Sometimes we can refactor it, sometimes we can't, right? I don't know if you ever tried to refactor your Terraform. Anybody tried to refactor some Terraform? Yeah, did you like it? That's a no, in case people were wondering. They didn't enjoy it, it wasn't fun. I didn't like it either. That's not a drag on Terraform. I didn't like refactoring Puppet either, that's why I wrote Chef. Sorry. Shots fired! Okay. Okay, so look, it also good about this, it can abstract whatever it is you're doing, right? If you know what to do, you can write a little interpreter that makes it say, do it now, right? And then do it. What sucks about it is it's static. You write it, and then it's written, and it sits there, and there's not a whole lot you can do with it except run it. It's unidirectional, so if you remember, all the arrows went in one way. You wrote code, went to the interpreter went to the world did things. But it just moves, that's the flow, right? You write code, pass it to the thing does stuff, done. It's also abstract, which is a good thing and a bad thing. So when what we're doing is modeling configuration, you know, sendmailmc was great until you didn't have a macro for the thing you needed to do. And then you were like, oh no, now I gotta go write a macro that does the complicated thing I was trying to avoid. And you actually needed to know more about how the system works, not less, because now I needed to know two systems, the macro layer and the underlying one. No behavior. So when we write code, the code is kind of the behavior, but I can't ask it to do things. I can't go to my code and be like, hey code, change yourself. You know, not really. Kind of, I can go to an IDE, I can hit the refactoring button or whatever, but mostly I can't attach behavior to it. And it doesn't really understand relationships. The only relationships code understands are code relationships. It understands this function called another one, or maybe this file has a relationship to another file, but that's pretty much what you got. So what would be better than code? What about infrastructure as model? So what if instead of thinking about it as code, what if instead we said that they were actors? And I mean actors kind of in the Erlang Elixir style, right? So we basically, like a running process that sits in the world, has its own state, remembers who it is, takes methods for mutation, right? So we can pass messages to it, and then it changes. We can also attach behaviors to those actors. So we can both say, hey, actor, configure yourself, right? Or set this property or do this thing. We could also say, start yourself or stop yourself, right? Or whatever you wanted to do, right? Update your list of tags, right? We can put whatever we want against those behaviors. We can also have relationships because we can express them between actors. We can say this actor requires another actor, right? Or we can ask an actor to pass a message to another actor whenever their properties change, right? Actors. So that would change the world like this. So now a person can interact with a representation of something, right? So this could be code, that could be a user interface, could be whatever you want it to be. But what they're really doing is making a call to some persistent runtime somewhere. And what that runtime does is synchronize your inputs to the model over a message, right? So we say, hey model, configure yourself this way, not that way, right? And then the model could be persistent, right? right? It's essentially in memory, right? And if you're going to quibble with me because you're going to be like, well, it can't always be in memory, Adam. And you're right, like we persist them to databases or whatever, but it's a thing we know how to do. And the model can be aware of their relationships. So we can think about things like saying, you know, this AWS instance that we want to run is also an instance of CoreOS, and those could be two different actors that are modeled differently, right? And then the model could be responsible for synchronizing itself with the world. So instead of saying that there's an interpreter that does it, the model could be responsible for managing its own behavior. So how would the world be better if we did it this way? So one, we could have lots of different representations for that configuration. So instead of saying we write code only, now code could be one of many possible representations, and we could build those representations any way we wanted to from the model. They're aware of the relationships. So much of what we do is actually describe the relationships between things, right? When I described that there's an EC2 instance running CoreOS, all of you knew what I meant. And those are relationships. They're two separate things, but we know how they relate. We know that I have a server that runs an operating system, which then gets configured. We can encapsulate runtime behavior in a way that you really can't right now in the code. So if you think about, I wrote some code, I wrote my Terraform declaration, my Pulumi declaration, it does what it does. I can't really like ask it to do something other than what I declared. I can't reuse that information. Now you can, because it's a running API. I could query it if I wanted to. No more state management. Who loves state management? Raise your hand. Not a single hand. That guy. One guy. Two guys. Two people. All right, all y'all motherfuckers. No, you don't. You're full of lies. You also get bidirectional data flow, right? So instead of having data only flow from one part of the system to another, because the actor handles all the transitions, I can drive that actor from anywhere, right? So if I want to drive it from the real world, I can. And ultimately, it's easier to model, because what we're modeling is the world, right? So instead of saying we're modeling the abstraction, so we're not saying in order for this programming language to function, what we're going to do is map a domain to the programming language. We can say, nope, we're just going to roll up the behavior of the real world and model that. And that actually is significantly easier to model because you don't have to think about the abstractions. Okay, let's break more rules, yeah? What do you want me to break? Source control. Okay, are you just going to go in order? It'd be crazy. I wrote this delightfully nonlinear talk, and everybody's going to be like, well, I was thinking we could read the grid. Anyway, it's unfair because I railroaded you. Okay. RCS was the first version control system I used. That was 41 years ago was when RCS was created. RCS, who used RCS? Again, because you're my people, like half the room. SCCS, what's up? Okay. Look, you mostly checked out individual files. It was like a mutex over an individual file. CVS was the networked version of RCS, and it also would let you commit multiple files in a single commit. That was kind of amazing. And so the rule was we used RCS for server config and CVS for application code, and all was good. If you're not old, you probably mostly have just used Git. Maybe someone made you use Subversion at some point in your life. And you were like, why don't we just use this? It seems easier. I don't know. We went, because, I don't know, Linux. So in many ways, the way we do it now is kind of a step backward in terms of user experience, I think. But it is distributed, except we centralized it again. Anyway, enough. You don't need to hear it. But basically, source control has remained in this unbroken line. Kind of works like this. We write some code, we check it in somewhere, that gets pushed to a repository, then somebody else comes along, they check the repository out, and they do some stuff with it. It's kind of the TLDR, source control. What's good about source control? I can save copies, I can revert things, I have a history, I can get a diff. So because what we're source controlling is text, I can show you what changed between the text. I can share my work with other people. Sometimes I can work in parallel. That's pretty cool. You can have pretty complicated capabilities for managing conflict. So everybody who's ever done a rebase or any of those sorts of operations, like that's a pretty complex operation, and it was harder in the olden days, just so we're clear. So like it is pretty great to have newer tools. But there's some things that suck about source control too. First one is it's only good for text. So if you got something that's not text, well, good luck. There's no context about the impact of what a change has done. There's only the delta of text. So because what we're doing is storing text, we can't really say, if you change this line of text, the following things will happen. Or you changed it for these reasons. We just kind of overload all of that context into the commit message. It's pretty difficult to put policy in source code. Who's done GitOps? been rocking your GitOps, and you put some policy in the repo, but like it's not the best, right? And like it's not very granular. You can't really, it's pretty hard to be like, well, only you on this. So then we like split the repositories up. So we start using repositories and the creation of them as a splitter for policy, which kind of sucks. It's a real pain to automate. Shout out again to my GitOps friends. God bless and keep you each and everyone for going through that. And also, right? Can we just have a moment? That's awful. Okay, so, and rebasing, who loves a rebase? No one does, but I'm glad that we have to do it. So what could be better than source control? So what if we had model-aware change sets? So if you take my configuration as code example where the world was the model, now we could say that the model needs to understand the idea that it could have more than one possible hypothetical configuration, right? So we could have one model that is the current model of what I expect to see in the real world, because in the real world, things tend to only exist one-to-one. You know, all the chairs that are in here are similar chairs, but each chair is a unique and individual chair. And so the model could be aware of a change, just like it was in CVS, where we're like, hey, there's a change set, and then every model we could hypothetically apply some change to their configuration. And then we could embed policy at the model level instead of at the source level, yeah? So we could say, hey, Paul Stack is allowed to change this model but not that model, or he's allowed to set this value but not that value, or call this runtime behavior but not that one, right? Because we've moved it out of source control and into some place that's both within our control and also that makes sense sort of logically in your brain. We could also automatically rebase the model. So when the world changes, what we're saying is, hey, when I take a change set and merge it, what we're really doing is just saying the state we wanted the world to be in has altered. And so every open change set could then reflect the delta between what you said you wanted in that hypothetical reality and the delta to actual reality. So it could work more like this. So a person comes in, they create a change set, and then they ask the world, they say, hey, Docker image, you should be configured this way. So I have a Docker image, its name is Whiskers. It's got a relationship to a CoreOS config that wants to run that container, which then is going to run on an AWS instance. And then it's also going to run in a Kubernetes deployment, which I think I put on twice now that I'm looking at this slide with fresh, non-airplane eyes. And one thing you can see is that when you change one part of the model, it might cascade into other parts, right? Because it's aware of the context. So because we can map the relationships, we can actually tell you, hey, this one small change in the Docker image cascades to these other places. That's pretty opaque in your source code, right? In your source code, you're like, if I reuse that variable, there's no way to tell that that one line you changed actually had this cascading impact. And suddenly we can see that that impact actually happened sort of all over across the whole system. And then when we have lots of these change sets open, it becomes a question of perspective. So instead of thinking about the world and change sets as a thing that happens in text, we can think about them as an overlay to the world. So there's the actual reality we want, and then each change set is a hypothetical reality we're asking the system to create on our behalf. So the benefits of doing it this way: easy to collaborate. We can give you contextual diffs, right? I can tell you not just you change this, I can say this is what will happen because you propose this thing. Automatic rebasing, policy's easier to add, and it's really lightweight compared to creating a branch. More rules for the rule gods.
Testing.
You can't be the guy. He works for me, he can't say testing, and we're going in order. So what do you want? Testing, okay. Testing it is. I'm fucking stoked about testing. Let's talk about testing. This is Joseph Jurin. He wrote Jurin's quality handbook in 1951. He was obsessed with quality both generally and specifically. And he did it across a bunch of different stakeholders. So it wasn't just about software testing, it was about quality in general. So a lot of management theory, a lot of ideas about sort of how you put that stuff in the world. If you haven't read some of it, you should. It's pretty good. And he defines quality in two ways. So one was quality means that the features of a product that actually do what it's supposed to do. So does it meet the customer need? The second one is it free from deficiencies? Which I think is a pretty solid definition of quality. This is a unit test for Pulumi. It's using Jest, and it's pretty typical of testing infrastructure as code. I'm going to pick on it for just a hot second, but I'm not picking on Pulumi. Like, it doesn't look a whole lot better if you write Test Kitchen, HashiCorp Sentinel, or whatever. But essentially what you're doing here, one thing to notice is it's pretty obsessed with how Pulumi works more than what it is we're trying to test. So the top part of it is basically saying, hey, wait for Pulumi to run. When I get these variables that have been exported, then apply those variables to the function underneath it. And then I can write the code that says, hey, do I have a tag that's name is name? Yeah? So what's good about this is it can catch regressions, right? If you built some infrastructure and it didn't have a name tag, this will stop it. It can be flexible across different layers, and it can enforce some of that policy that we lost in source control again. What sucks about it? Well, the feedback loops are real slow, right? So when you run the tests, it takes a while. The more of them you have, the better you feel, but the longer it takes. How many people here love mocks and stubs? Again, there's like one motherfucker in the back. What's up? Loves a mock and stub? Yeah, but most of us don't. And really, the big thing here is that they're not super well fit for purpose. So testing code, in many ways, makes a ton of sense. But what we're all here for is Configuration Management Camp. We're infrastructure people. What we're testing is this reflection of the real world, and we're hoping that the real world then does what we say it will do. But it's not quite right. There's an impedance mismatch between the tools we think about with testing and for source code and what we're trying to test in reality. So what could be better? Well, what if we built tests into the model? So rather than thinking about them separately, what we do is attach testing to lifecycle events in the model. So our little model could say, hey, you know, one thing that happens is someone sets a property. And when people set a property, I want to validate that that property is true or false. And so we could just attach a function to that event. So the model, we could tell the model, hey model, whenever this property changes, run this function, right? And then it would run the function and it returns true or false and maybe a little description that's like, hey, you got to put the name tag on the thing, right? We could also qualify the whole model. So instead of just thinking about it as a single field, we could say, hey, every time any field changes, then let's look at the object as a whole and make sure that it makes sense. Because sometimes every field individually makes sense, but in combination they don't. Or we maybe are more concerned with the real world. So we're like, hey, every time that the real world changes its state, which happens outside our control all the time, let's run the model again and confirm that what we expect is what's there, and then make recommendations, right? And then we could make those things reactive to their inputs. So rather than running them when you run tests, instead you could run them like all the time as we're making changes in real time. So here's an example. This is a simplified qualification from System Initiative. So this checks that a Docker image actually exists in a registry. So whenever you actually decide you want to use a Docker image, this little snippet of code runs every time the image you want to run changes, and it just runs Scopio and says, is there an image here or not, right? So if you fat finger the Docker image name, you don't have to wait till you run it to learn that you were wrong. It just tells you immediately, yo, I can't see this thing, maybe something's wrong. So one thing to notice is how much simpler this is, right? So it just sort of gets you straight to the point. If it wasn't for that little exec command there, right, it's pretty obsessed only with what it needs to be obsessed with. That's because the model takes care of all of that scaffolding around the edges. So all of that part that's like obsessed with how the program works, we've removed because we can just put it into the actor because it's fit for purpose. So the upside of thinking this way, we get immediate feedback. They trigger only when we need it to. They're easier to write because the harness is kind of defined, and you never need to mock or stub anything because we can make a distinction between when are we working in hypothetical reality and when are we working in real reality. More rules. Declarative? I heard declarative. What's up? All right, let's do declarative. This is Mark Burgess. Mark Burgess is the most handsome man in configuration management. I would also like us to just give a round of applause to Mark Burgess because we're still just living on Mark Burgess's good. I love Mark so much. He's such a good person, and he's done so much for all of us. But the first time I heard somebody say that configuration should be declarative was Mark 25 years ago, and that was CF Engine 2. Kubernetes, I think, is the current poster child for being declarative, right? We like write our YAML, we hand it to the interpreter chunks over it, right? And it reconciles. I'm just gonna bring this diagram back up till you're sick of it in your back teeth. This is Kubernetes too, right? So what's the interpreter in the middle? It's the Kubernetes, right? So I wrote my YAML, I threw it at my Kubernetes, and my Kubernetes did the thing, and then it synchronizes with the outside world and it controls state. State goes in etcd, yeah, but it's like, and on we go, right? What's different is how much or how often we reconcile, but the gist basically is the same. So what's good about declaring what we want? Well, you know, you can just say what you want. So that's pretty good, right? Like instead of saying how to get it and how to all the pieces that need to go into building it, you can just say, give me a chair, you know, and then chairs appear. It can be a lot less verbose because the steps to build a chair are long. Anybody ever built a chair from like IKEA? And you're like, why are there so many steps to building a chair, right? So that's cool. It's a little easier to deal with failure because the failure can happen in the interpreter. So the interpreter can sort of figure out, you know, how many people just like, when your Puppet run didn't work before there was module ordering, you just ran it again and we're like, it's probably cool, right? Yeah, everybody did, because that's why I wrote Chef. Okay, so I don't know why this has turned into that. I swear to God it wasn't when I rehearsed it, but it's something about being in this room is really bringing back old rivalries in a way that's freaking me out. And I didn't see coming, and I'm kind of sorry about it, but also it's fun. I don't know. Okay, but it can be catered to the domain. You know, it can be really focused on the vocabulary, the specifics of what we're doing. What sucks about it is generally there's only one state at a time. So if you think about the things you're declaring, you can really only declare that it is in one thing. So like, you know, I can say that I want this package installed, but I can't really say I want this package installed, then do something else, then uninstall it, right? Unless you were using Chef, and then you could. But generally you need to know. There's a problem I call the 200% knowledge problem. So this is the problem with community modules. Every community modules project has devolved into this same pit, which is, wouldn't it be great if we didn't have to rewrite Apache 2 configuration 100 times? And so we go and we try to build the perfect abstraction from whatever the language is for Apache 2 so that nobody has to write it again. Only now the problem is you need 200% of the knowledge. I need all the knowledge about Apache 2 to know exactly what it is I want to say, plus I need to understand all the weird shit you did to make the abstraction work so that it was simpler to use, easier to use, right? This is the 200% knowledge problem. It's not better, it's worse, right? It's better to just do the thing you need. They're hard to extend. Typically you extend declarative systems in a language other than the language you declared them in, right? So you gotta swap languages, you're creating modules, you're creating extensions, the conceptual mapping gets pretty brutal pretty fast. They suck at modeling workflow. Because they are declarative. So moving through multiple declarative states is kind of a problem. The other is they kind of take a while to run because they sort of take as long as they take. Like however that loop is, it just sort of has to do what it has to do. Okay, what's better? Infrastructure is modeled, unshockingly. So if instead what we do is we think about this declarative world as a digital twin, and we say what I actually want to have is a digital version of the universe. That's the hypothetical one. And then the model, and then the real world is a resource that I'm related to, and I'm twinning them together. So think of it like a heart-lung machine, right? When we want to model heart-lung machines, we don't do it on a heart-lung machine with a patient, right? We have a software model of the heart-lung machine that tells us patient lives, patient dies. And they'll tell you what the values are, and it'll be like, okay, make sure they don't die. It can be one-to-one to the domain. In fact, it must be one-to-one to the domain, because otherwise we get back to the 200% knowledge problem, right? So whatever it is that you're modeling, your model needs to be a reflection of that thing. So you don't have to do that mapping in your brain. Our ability to like set properties and behavior goes up because now we can describe more about the domain itself. Instead of just saying, here's the declaration and that obviously implies intent, right? We can instead say, nope, like just tell me what the knobs are and then tell me what the behavior is you'd like to see. So it changes the world to kind of look like this. So imagine you have like a person who decides they want to change a model. So they could set a property on their model, and they can do that to their heart's content because it's not hurting anything in the real world. And then they could decide they want to call a behavior. They could say, create that model in the real world. At which point a resource gets instantiated, which has its own properties, which maybe are probably a one-to-one set of the other model's properties. Maybe they have some extra things that can't be changed, some of the read-only, right? But that ability to create the behavior now means that if those values change from the outside world, we could change the properties in the model. So we could go back the other way, and we could say, hey, someone logged into the AWS console, and they changed a property, and now that property flows back into our model because the actor could take it, right? It doesn't have to patch your source code and commit it to Git. So properties can sync both ways. So the other good thing about this is that behavior becomes really easy to collaborate, to put together into a workflow. So all of those multi-step processes you do, where you're like, hey, I wrote some code, I checked it into Git, I ran it, then I waited. then I wrote this change in Git, then I committed it, then I waited, right? All those things can become really easy to express because now it's just call this behavior, wait till it's done, then call these. So expressing them in workflows becomes really straightforward. So the benefit here is we gain more control, we gain lots more power. We eliminate the 200% problem because the model is the model. Its job is to model the world directly. We get to reuse configuration in behaviors. So all of that configuration that can help us make decisions about what to do is still available to us because we can query the model to do it. We can pick and choose which behavior to run. So sometimes the right thing to do might be change the world to match the model. But sometimes the right thing to do might be to change the model to match the world, right? And we can pick and choose. Also, it's faster. It's faster to write, it's faster to execute because it only requires really knowledge about the domain. How am I doing for time?
10 minutes.
10 minutes. Okay. I might have time for one more and then I gotta end.
Single source of truth.
Single source of truth. Okay. First time I heard the word single source of truth was Novell Identity Manager. If people remember Novell Identity Manager, it was a meta directory. I'd love to tell a funny story about Bobo T. Clown and the security guys freaking out, but call me later. I'm around, I'll tell you a story. But the way you think about this is code. You likely believe that the source of truth for your infrastructure is the code that defines it. Your KTML, your Terraform, your Pulumi, your whatevers. Here's the diagram, you've seen it so many times. See where we had to break the rules? Okay, so what's good about it? It does make it easy to change things because I have a single source of truth, so I know where to go. I can just go to that thing and change it. It's easy to reason about it. Data kind of flows only in one pattern. What sucks about it is conflict resolution. So if things go wrong or there are multiple things that need to change from multiple sources, which one's right, which one's wrong, you say that there's a single source of truth, but you can't resolve issues at the source. But fundamentally the problem is it's a fucking lie. Yeah? It's just a lie because the truth is not your source code, especially if you're doing infrastructure as code. It's clearly the infrastructure. Like obviously it's the infrastructure, right? Does anybody disagree with me? Don't disagree with me. We don't have enough time. But if you do, come find me and I'll be like, what are you talking about? It's clearly the infrastructure, right? So the real problem with this is really straightforward. It's just a fucking lie. So how do we make it less of a lie? Digital twins. Oh my God. Adam's got a thing. Okay, so look, we take this theoretical model that lives in our heads, the thing that you put in code right now, but instead we say that theoretical model is in fact theoretical. It exists hypothetically only in our brains. And then the real world is the real world. They're both true depending on the context. So in a world where what I'm doing is saying, I would like to see a world like this, my hypothetical model is the reality that I want to live in. In the real world, there's only one real world, and that's the one that's running. And in that world, it may or may not be what I desire. But that's true for the real world, and we should separate them. So it works more like this. When you're dealing in hypotheticals, the model's the truth. When you're dealing in the world, the resource is the truth. So you can update either side. Functions can compare the two. So we can say, hey, write a function that when something changes, will then compare the hypothetical with the reality, and then make a remediation proposal, right? It could say, hey, these things don't match this way. But we can go the other way too. We can say the world doesn't match the model. My proposed remediation is change your model to match the world. Benefits, it doesn't lie. There's a clear demarcation between when are we doing something in our heads and want to know if what we propose in our heads would work in the world, and is there something working in the world? It's bidirectional. So it can move from the world to our model, it can move from the model to the world. Try doing that in your source code, you can't. How about state? It's gone, right? All of that like state management stuff that we've decided we have to do somewhere, pretty much you can just eliminate because it lives in the model differently. It becomes really safe to change the real world directly. So if the way you know how to fix something is to log into the AWS console and click a button, log into the AWS console, click a button. And then the only bad thing that's gonna happen to you is that the real world will change, we'll track it, we will show you it happened, and then we'll be like, yo, do you want to update your model to match the thing? And you'll be like, yes, because that fixed production. And then you move along. But you don't have to worry about whether something else is going to come along and like overwrite your vision of the universe, because we've broken the link between saying that the source code is true and reality is false, because it was always what? A lie. Yes, that wasn't loud enough. Try again. A lie. Yeah, stop lying. Okay. Okay, I have to wrap it up. If you haven't guessed yet, these are all rules that System Initiative breaks, roughly in the way that I have described them. This is the first time I've ever talked about System Initiative in public. You've been able to find me, but you're literally the first humans who've ever heard it, and it's such a fucking relief to talk about it. It's also going to be open source, and that's the first time we've said that in public. So we're going to open source it. We're not going to open source some of it. We're going to open source all of it.
Nice.
And we would love to have some of y'all give it a whirl before we actually make it public to the entire world. So if you want to see what it looks like, do you want to see what it looks like?
Yeah.
Okay. So here's an example of composing a model with relationships. So each of those components in the diagram is an actor, like I described. So they're a literal process that's running somewhere. And what you're doing when you're creating those relationships between them is you're configuring them. So you're actually saying like, hey, this Docker image informs both the butane configuration that's going to run on CoreOS, but it also informs the ingress rule that opens the firewall because the Docker image exposes a port, and we want that port to be exposed. And so that configuration, we don't have to write by hand, it's inferred through the relationships. The source code that you see over there is generated and is fully dynamic. So it basically takes all of those property inputs and then generates the output. So all that like podman goo that's in the user data there to launch the container, that all got written automatically by a function that was attached to that particular thing that says, hey, when we write that butane configuration and we expose it, that configuration then gets packed into user data. This is a fuller composition view, so zooming out a little bit, you can see change sets kind of in the upper left over there. So what we're doing right now is proposing a model of the world. And you can see that we have a failing qualification. So basically that EC2 instance has got a little warning knob there. And what it's telling us is that the EC2 configuration isn't quite right because the key pair that we need doesn't exist yet. And so it's a warning, not an error, because there is a key pair attached to it, and our assumption is that we're going to create the key pair when the time comes, and therefore it's probably right. But since you can pick and choose when you apply different things to reality, it might also be wrong. Stuff that I'm not showing you here, there's a little tab up there with the little beaker guy, and if you click it, it pops up an editor, and what you can do is edit all of the code that runs the system. So all of those models are expressed as code, and you can just write JavaScript functions till you fall over. Okay, well, that's what System Initiative looks like, and if you want to try it, you can in a couple of weeks go to the website and sign up for it. Paul Stack and I have a lot of stickers. We're never going to make those stickers again. So if you want them, there's a cute cat. It's got wings, same as whiskers. And you can have them. We'll be around to chat more about what's happening, but I want to leave you with this because I didn't want to turn it into a product pitch. Look, everyone who's in this room, and why it was important to me to come to this room, is because this is where the people who are actually the best at this in the world tend to gather. And your knowledge of the way we do it and of the rules as we understand them is invaluable knowledge. You learned those rules and we came up with them because that was real hard-fought truth. But it's also a bit of a curse. As code, as an idea, isn't really pushing us forward anymore. In fact, it's kind of holding us back. And I hope that you're inspired to create something new, something unorthodox, something beautiful. And I can't wait to explore what's possible when we all decide to break the rules together again. Because it was so fun when we broke them the last time. So thank you. See you later.
Thank you.
Thanks, man.
Hello. Can you compress again, please? So there are people sitting on the stairs. Please try to compress and give them a seat.
Oh, amazing! Hi.
There is still room in the overflow room, which we are live streaming to. And after the break, we're actually going to split into multiple streams. But okay, louder, James. Well, unless we want to run really behind on schedule, let's get started and give a warm applause for Lee.
Thank you, everybody. Hopefully everybody can hear me. My voice is usually pretty loud, so I really usually struggle with microphones, so please bear with me if you get a bunch of feedback.
Hi. We are also on the internet. I don't know if you're going to walk around with those. Otherwise, I have to wire you if you're going to walk around.
I'm not going to walk around. I'm going to stay here.
Okay, then.
Is this...
Yeah, this is
Got it, okay.
used for that. Okay.
From here is good?
Yeah.
Okay. Sorry for the delay. We're just making sure everybody on the internet can hear. So when they said, when the schedule came out and I realized I was going to follow Adam Jacob and the talk title was going to be What If Infrastructure as Code Never Existed, my response was, well, it fucking does, so choose one. And then they asked me, well, Adam might not make it in time, so do you want to go first? And I was like, I guess so. But after having seen that fantastic talk, I think there's a lot of things that, certainly from what Adam said, there's a lot of serendipity between what if infrastructure as code never existed and how you might go about choosing one. Because there's so many things in the decision-making process that I think most people in this room have probably experienced. Adam doesn't need to introduce himself, I probably do. My name is Lee Briggs. I have been in this community for a very, very long time. I personally have been to this conference at least 6 times, and it has been a huge force multiplier for my career in general. I currently work at Pulumi. I'll talk a little bit more about that in a minute. But before I did what I currently do, I was an infrastructure engineer like many of you. And so I have used almost every configuration management tool that is available to talk about at this conference, and almost every infrastructure as code tool. I am on Twitter on Elon Musk's personal playground at Briggsell, and I do actually write on my blog fairly regularly at this point, so just to personally pitch that, I would love people to go and read what I've written. I do like to have a little bit of an agenda so that everybody knows what I'm going to cover today. So if you read this, you can get up and leave. I won't be offended. But we're going to first of all define a few things, because in the process of putting together this talk, what I realized is that there isn't really a well-defined definition of infrastructure as code and configuration management. You may have an internal idea of what you think that is. I certainly have an internal idea of what I think that is, but there isn't anything that's really been written down. And if there was ever a place where we could leave and have that defined, this is definitely it. As Adam already alluded to, this is, in my opinion, where a lot of these theories and results have actually come from. If this is your first time at this conference, or you've been here many, many times, you'll come to realize in the next couple of days that the people that are in this room have defined most of the way that we manage infrastructure at large scale over the last 10 to 15 years. I'm then going to, after we've defined some of that stuff, I'm going to move on to a different way of looking at infrastructure as code. And then finally, I'm going to give you some personal opinions, because I've never had this many people listen to me talk before, so I'm just going to get on a soapbox for 5 minutes. I do have to make a disclaimer. I am probably the worst person in this room. I actually sell open source software for a living, which probably makes me the worst person at some level. This is not a product pitch. I do work at Pulumi. I am going to talk about Pulumi. My job here is not to sell product. If you do feel compelled to buy Pulumi at the end of this, that was an accident. I did not mean to do that. So let's define infrastructure as code. And you'll notice I'm starting right out of the gate with some quotation marks around the word code. You know, I do have strong opinions, and there are people in this room that know me and realize I have strong opinions, but they are strong opinions loosely held. I am never ever going to say that my opinion is correct, but I do feel compelled to share them. And I do feel like what we currently have as infrastructure as code probably isn't a great definition. But when I started in infrastructure, this is what it looked like. And I'm sure there's many people in this room, after seeing how many people raised their hand saying they'd written a sendmail.cf, it probably looked like something like this, so it was probably a BBS or something along those lines. Yeah, still looks the same. Yeah, I mean, that's my actual home rack, so like, yeah. But, yeah. Nowadays, infrastructure can look like this, and if you're unlucky enough to use Azure as your cloud provider, you'll see this every single day, I'm sure. And what really has happened in the last 5 years, and maybe even 10 years if you want to get technical, is that infrastructure has evolved from managing things at different layers. We've gone from managing APIs at the operating system level on a very large scale, certainly in this room, to managing APIs at a very, very large scale. And a lot of the stuff that Adam just talked about why we ended up here, was a result of that kind of sea change from configuration at the operating system level into basically managing the results of an API call, which is what the cloud providers give us. So what I did is had an attempt at putting together what I believe is the difference between configuration management and infrastructure as code. My personal belief at this stage is that infrastructure as code is a superset of configuration management. And the reason that we ended up with these kind of things that Adam said are all fucking stupid, because of that kind of gradual drift from the things that we learned in configuration management into API management or into API configuration management. If you really wanted to get technical, you could call it API configuration management, but infrastructure as code has got more snappy, a more snappy phrase than API configuration management. Now, you'll notice in the infrastructure as code section here, I've said that the infrastructure as code tools that we have defined are have to be in this particular way. And there's some terms here that I think are really important, and I'm going to go into a little bit more detail about them, mainly because I've got to give this talk to people who aren't as expert as here, but there may be people in the room that don't understand what a DAG is and what declarative actually means. And declarative is not just shouting at your cloud provider and getting some infrastructure, although having looked at what Adam just showed us, we may get there one day. It would be really nice if you could just say to AWS, could you please give me a bunch of infrastructure? And they went, sure, here it is. That didn't go too badly. One of the things I like to say about cloud providers is they're very, very good at making the wrong thing easy and the right thing hard. And that's really where infrastructure as code has ended up springing up, is because the default setting for all of this stuff is really broken, and you can't actually use it in its current form. So, from a fundamental level, my perspective is that an infrastructure as code tool must be declarative and must build a graph of resources that are managed by that infrastructure. And This is a really, really controversial topic. You might not find it hard to believe, because declarative and imperative at the infrastructure as code level isn't a well-defined thing. It's not something that we have just kind of decided. And if you go into Twitter right now and do a search for imperative and declarative, you will see lots and lots of people arguing about this still. We haven't actually come to a definition of what imperative is in infrastructure as code or what declarative is. So again, I've made an attempt at trying to define that. And you'll notice that there's some really important things in here around who makes the decision. If you are an Ansible user, you'll be very familiar with how Ansible works, in the sense that it is a series of steps of dependencies that happen in the actual control flow. You get to decide as the operator what order those steps happen in, when they happen, and who is the decision maker. So essentially what you're doing there is you're building a graph of resources that's in an Ansible manifest, but you are the person that makes the decision. In my opinion, a declarative infrastructure as code tool takes that decision away from you. It no longer allows you to decide what order things happen in. You have to build, you simply express the way you want your infrastructure to look, and the graph is built for you. And you can see this with Terraform, you can see this Pulumi, you can see this with CloudFormation, by defining a resource in your infrastructure as code definition, and then you say that the output of one of those resources is the input to another resource, and the graph itself is built for you. This is really easy to see, in my opinion, but it's still not well defined. This is really easy to see if you try to do the same thing in Python using Pulumi or the AWS SDK with Boto. With Boto, you have to do a try and a catch, make sure the thing actually happened correctly, take the result of that API call, pass it to something else, and then build the graph yourself. These are imperative operations. With Pulumi, you just say, I want an S3 bucket, and it will give you an S3 bucket. With CloudFormation or Terraform, or I'm sure any other declarative infrastructure as code tool, you say, I want this thing, and if you can't get that thing, the engine that actually builds that declarative graph figures it out for you. These are really, really important definitions, because we're still arguing about them. And so I'm taking the opportunity to say, this is my perspective. So if you aren't familiar with what a DAG is, or a directed acyclic graph, this is generally what it looks like. And just to make it a little easier to understand, I've actually changed the nodes into AWS resources. If you're not familiar with AWS, take your cloud provider and replace the things that are in these nodes with whatever you manage in your cloud provider. But the most important thing is that the dependencies between these resources are figured out by the tool itself. And what's really interesting about a DAG is it's really, really easy to express with a configuration language. This is why we ended up with a bunch of YAML everywhere, and I know Chris's favorite term is YAML engineer, but this is why we've ended up with these YAML documents or JSON documents everywhere, because if you want to express a bunch of resources in a graph, and you have the power of a graph of a declarative engine at your disposal, you don't really need to do much else except just describe what you want the state of the world to look like. And that's really nice, because it means you don't have to write as much code, and you don't have to do a bunch of error checking and deal with a 500 from an API and a whole bunch of other painful things. And for a lot of system-based people, that is a really, really nice world to live in. The problem is that YAML is garbage. That's the problem. Like, they're all garbage. Everything's garbage. In order for you to do anything, and I can see everybody around the room going, oh, I can see where this is going. But the reality of it is, when I say it's garbage, it's really, really good at describing the state of the world. But what it's really not good at is describing different graphs for different situations. What do I mean by that? Well, raise your hand if your development environment looks exactly like your production environment. There's a lot of people lying to themselves in this room. Okay, raise your hand if your staging environment looks exactly like your production environment. More people lying to themselves. The reality of it is, we have to deal with very, very complex infrastructure. And we have to deal with different cloud provider regions, and we have to deal with different different users having to do different things. There is an idea that you should be able to stand up your entire production stack in about 10 minutes. And what this means is that you have to describe the state of a graph, but you have to manipulate what that graph looks like depending on the situation that you're actually doing. And so this is a really, really stupid example of like, well, I've decided in development that I only want to have one subnet because, you know, YOLO. And if I want to use the same code in production and development, I have to start manipulating what that graph looks like. And I have to start manipulating which resources get included in that graph. It's still declarative, but I as the operator have to make a decision about what gets included. Not how the graph is built, not how the resource dependencies are managed, but what is included. And this is how we ended up with domain-specific languages in infrastructure as code. You could argue, if you really wanted to, that this is how we ended up with the Puppet DSL as well. One of my favorite things that I think has been built in by this community, and I don't know if Ari's here, I haven't seen him, is the Hira implementation in Puppet. That was a really, really nice way of saying, in your staging environment, have these configuration, in your production environment, have this, in US West 2, have that, in US East 1, have that. And so what we realized is after layering all these configuration languages into our infrastructure as code, what we actually now needed to do is start manipulating it. And Adam mentioned Helm. Helm is just another way of manipulating a resource graph. But except we've just added Go templates on top of it, as if that was the answer to all the problems. And so then we came up with the HashiCorp configuration language, and I did a talk 3 years ago about JSONet, which I regret a lot. And then Microsoft, in its infinite wisdom, went, I know, we need more DSLs, let's do another one, and they came up with Bicep. And then somebody, I don't know who, decided that we were going to have colons at the end of every line and came up with DAO. And so all of these DSLs, the entire point is for you to manipulate that graph, for you to be able to decide what you include and what you don't include when you build your resource graph. I'm going to take a quick drink because I'm ranting here.
It's a good rant, though.
Thank you. So the user experience really here for a lot of this stuff is where we start to where we start to pivot the way that we look at these things. Because essentially, when you decide to choose an infrastructure as code tool, what you really want to do is figure out how you want to build a resource graph and what things you want to include into it. Now, if you go and Google Terraform versus ARM versus Pulumi, this is the answer you get. And it will tell you about what rollback changes there are and which languages you can use and, you know, the deployment history. None of that generally matters from the get-go when you're choosing an infrastructure code tool. I have looked at a billion of these, and that's probably not an over-exaggeration because part of my job is to tell you why you should buy Pulumi. I've looked at so many of these, and not a single one of them has helped me make a decision about which infrastructure as code tool I want to use. You could argue that these tables are actually against you making a strong decision because what they really do is confuse you. I don't even know what a hosted JSON URI is. Like, in the context of ARM, it's not helpful to me, and it certainly isn't helpful to anybody in this room when a developer comes to them and goes, the project manager said we have to have this code in production tomorrow, so what should we use to do it? Which has definitely happened to almost everyone in this room because it happened to me all the time. And you can't look at this table and go, we'll use ARM, that will help me do this tomorrow. That's really going to help me. So what I would like to do here is help you decide which infrastructure as code tool through two different lenses. Both of them are in relation to this graph that I've talked about already. And the two experiences that I think are super important when it comes to infrastructure as code and configuration management as well are, what is the authoring experience and what is the execution experience? And so what you can boil those down to is, what is the experience of the person who is going to express this graph, and then how are we going to get that graph off my laptop into production? And to drill down into that a little bit more, what does that look like? Not just for you, but for the people that you're supporting who are inevitably going to start deploying infrastructure. I'm sure there's people in this room that believe that their production environment belongs solely to them and developers are never going to go anywhere near it. I have news for you folks, that's going to change. Like, that world that we had 10 years ago where you had to open a ticket to get some servers, where we've left that well behind. And letting developers provision infrastructure is just the way the industry's going, and I know it makes us feel all a little bit uncomfortable, but that's the reality of it. So what authoring experience do you want those people to have? Do you want them, which language do you want them to use in order to express this graph? How do you want them to be able to do those abstractions that Adam said were terrible? What cloud provider do you want to be able to express? Do you want to just be in a single cloud provider's ecosystem, or do you want to use Cloudflare for your CDN and Datadog for your metrics? And then once you've expressed what this beautiful infrastructure is going to look like, how do you get it into the cloud provider itself? Do you want it to be opinionated? Do you want to have to deal with authentication? Do you want it to just happen? Like, what is the different things? So let's choose an adventure. So what I'm going to do here is I'm going to go through most of the options and give a pretty objective opinion on what the options are there. So here are the current authoring experiences that are now superseded by a product announcement that was just made right before I did this talk. So the DSL-based authoring experience is probably one that most people are familiar with. Who here has used a DSL? Raise your hand. Almost the entire room, not quite an entire room. The thing about a DSL is it's single use, and the clue is in the name. It's domain specific. It's there for you to do this one job. I spent 10 years learning the Puppet DSL, and I haven't written Puppet for 5 years now. So, you know, you could argue that I learned a lot about how Puppet works, and I learned a lot about how DSLs work, and it made me a better software engineer, but ultimately, I haven't written Puppet for 5 years. It's just not happened. So, that domain specific language knowledge that I learned is just for that one purpose of configuring operating systems. The expressiveness is actually a language feature. And one thing that I thought was really interesting in the HCL and Puppet DSLs were how they started out telling us that there was supposed to be limited expressibility, and then they grew in expressibility over time as it became almost a fully fledged language. I think I remember the time when Puppet became Turing complete, and this was kind of a big deal, and then we were like, well, there's a bunch of Turing complete languages in Ruby already, why are we doing this? But that's generally what tends to happen with DSLs, and you can see this with other DSLs. ARM is another one that is a really kind of new on the block DSL, but the expressibility is increasing every release. HCL has gone through many different changes in its expressibility. When I started writing Terraform, the idea of doing an if statement was unheard of, and then they went, well, just do count equals 0, and that's the same, right? Like, you know, that's totally okay. What's really important about this is that these DSLs are generally simpler. Their learning curve is generally lower, and the abstraction mechanism is specific to that implementation. These organizations that build these DSLs generally own all of the model around them. So, for example, if you are writing HCL for Terraform, you would use the language server implementation in VS Code or whatever IDE you choose. I'm going to come back to that in a few moments. You would generally use the language server implementation that is owned by that organization. So these are the kind of like features and caveats of DSLs, and I'm sure you're getting the idea. I'm no fan of DSLs at this point. I have used DSLs for a very long time. I'm kind of over them, but they have a place in the world. They do have a place because there is a path between, you know, simple configuration. This is what I want the graph to look like, and I want to make it slightly more complex, but not really fully expressive. So these are the DSL tools that you can choose from right now. Previously, this was a single slide. On the infrastructure as code side, I haven't included what I think are configuration management tools in this, but generally these are the two infrastructure as code tools that have a DSL as an authoring mechanism. And then we have the configuration language-based authoring mechanism, which, you know, if you are doing Kubernetes stuff and using Helm, you'll be pretty familiar with this, right? Like, you write it in YAML, and if you want to have any expressibility at all, you layer on a templating system like Ginger 2 or Go templates or Mustache or something along those lines, and then you use a rendering system to actually generate those different configurations per environment. They are really simple, very hard to get wrong, but you don't get any help from a configuration language. I mean, we all know, I'm sure we're all familiar with the Norway problem in YAML at this point. Like, this is a feature at this point, right? Like the whole point of it is, once you get to a certain point, you probably want to be graduating away from configuration language based, configuration language based authoring mechanisms. These are all of the tools that support a configuration language based authoring mechanism that I am aware of right now. So ARM default is JSON or YAML templates. If you really wanted to, I don't think I've ever seen this in the wild, but you can hand author JSON for Terraform if you really wanted to, or you can use a generator to do that. You can use CloudFormation, you can use Crossplane. Pulumi has a YAML implementation, which I fought very hard against, just for the record. And lots and lots of different tools here support this configuration language-based authoring mechanism. And then finally, there is the programming language-based authoring mechanism. Now, another hot take here. This is the way the industry is going. If you look at this and you go, no, this is a terrible idea, I would suggest having a rethink about this. Because, as we have already said, resource graphs are complicated. They're really hard to express easily. And as a result, almost every infrastructure as code tool that is taken seriously has some mechanism for you to be able to express that resource graph using a programming language. And Adam just showed us the new kid on the block at this point, System Initiative, is going to have a JavaScript code thing behind the scenes, because this is really what we've ended up with. Infrastructure is so complex that the only real way to express it at this stage is to use a programming language with full flexibility. That is just my opinion. You don't have to agree with it, but that's just where I think we're going. This expressiveness and the fact that you can use these language-based abstractions to your advantage are seen as a feature. But a common thing that I hear is, well, I've seen developers write infrastructure and it's so complicated and they have no idea what they're doing and all that kind of stuff. All that's totally valid, but at the end of the day, the industry itself is going in a direction, gradually, slowly but surely. They also give you the benefits of an IDE at your disposal. I recently turned on GitHub Copilot, which I know is probably going to make people wince because of the license implications for that, but man, is it great not having to write any code. Just type a bunch of things and it completes it for you. It's awesome. But of course, the complexity is built into the language as well. The learning curve is steeper. It's harder to understand. You need to understand the entire ecosystem. For somebody just starting out and you've never written a Python implementation before, and then they're like, so you need a virtual environment, but there's 20 different ways to create one. And then you need a package manager, but there's 15 correct ones. This is really daunting to a lot of people. And it's really difficult. And I think something that I would challenge a lot of the people in this room to think about is, how do we make these things easier? What is the way that we can do something to make this slightly easier? And then the final thing, which I think is really important, is the fact that type systems make everything easier. Type systems make it easier for you to express infrastructure. And as a result, almost every infrastructure as code programming language-based tool comes with type systems by default. These are the tools that you can currently use. Azure hasn't figured it out yet. They will eventually. They will allow you to express ARM templates with a programming language, I'm sure. Even Terraform, who invented an entire DSL, went, okay, we need a programming language-based mechanism to express infrastructure. We're going to create the CDK. AWS CDK, if you ever, if you get a couple drinks down me, I'll tell you the story about how that came about. I'm not going to do it on a live recorded stream. Paul is laughing at the front here. And then obviously Pulumi, which is, my employer. I will keep reminding you of that. So here's a nice, everybody loves a picture, right? So here is a Venn diagram of the state of the world when it comes to the ability for you to express a resource graph with all of these different options. I am going to have one quick note, and I'm sure somebody's going to feel a bit singled out here, but when I mentioned that programming language-based experiences are the way we're going, everybody who I talk to who says that's not the way we're going is still using bog standard VI to throw JavaScript at a .text file. We are in a point where if you use the correct editing environment, the work will get done for you. If you are still using VI, at least add a language server. Add some stuff to make your life a little bit easier. Even if you want to stay with the DSL, even if you want to stick with a configuration language, There are things out there to make your life easier. And if you are finding any of the stuff that I talked about, if you've given it a try before and gone, oh, that's way too hard, ask yourself if you're using bog standard VR. At least use Vim. Like, upgrade a little bit. Because there's implementations in these editors that make your life easier. And they make things easier. And I came from an environment in which the last time I wrote code was VB.NET in like 2013, and I was like, never doing this again. It sucks. And now I do this all day, every day. So the execution experiences. Almost everybody here has probably done a command line execution experience, whether it's with Ansible or with any other infrastructure code tool or Chef directly from your box when it Chef Knife. But most of the kind of way that we've used infrastructure as code so far has been via CLI-driven experience. And these are great because you get control over which credentials have the... You get control over what credentials you provide to the tool. It makes you feel safe. It means that you're not just sending things off into the distance and you don't have to worry about where things are going. You generally would group it with a CI/CD tool, and they're very opinionated. They are basically telling you that this is the workflow that you need to follow in order to be successful with this infrastructure as code tool. They're also way faster. If you look at, when I'm going to talk about the server-side execution experiences, because you're talking directly to that API, you don't have to deal with the underlying abstraction that the cloud provider is going to build for you, whether that's ARM or CloudFormation or something along those lines. So you can run multiple of these. I mean, I'm sure everybody in this room can pipe Terraform to Xargs and get about 16 different implementations going. It's probably not a good idea, but it's definitely possible. So as a result of that, you get control over how you run things. You get to make those decisions. These are the two main command line driven tools at this point in time. Pulumi has a command line driven implementation. Terraform has a command line driven implementation. Then there's the server-side execution experience. So these are really, really simple, and these are the default out-of-the-box way of doing things for most cloud providers. So if you download the ARM CLI right now, or sorry, the Azure CLI or the AWS CLI, it will drive you towards the server-side execution experience, generally when you get started. And the reason for that is it's really, really simple. You don't have to think too much about it. You don't have to install many dependencies. You just write your resource graph, and you send it off to the cloud provider. Now, most people in this room are probably wondering, well, hold on a minute, like, does CloudFormation have a resource graph? It absolutely does. Does ARM have a resource graph? It absolutely does. But you don't have to think about how that's managed at all. In a server-side execution experience, you give all of that over to the cloud provider, and they figure the rest of it out for you. The downside for that is it's really, really slow. I worked with a customer who did a migration from CloudFormation to Pulumi, and they improved their deployment speeds by 10 times. And it was so great, we did a case study. But the whole point of it is these things are generally extremely slow, and that is something that you just have to deal with. If you go into if you go into Twitter right now and you search for CloudFormation slow, you can go nuts. It's a great read. You know, everyone's like, why the hell is CloudFormation so slow? AWS is the world leader in cloud provider, and they make you wait 20 minutes to make an S3 bucket. Why is that the way it should be? In their infinite wisdom, that's what they've decided. So these are the two server-side execution tools that you have at your disposal right now. They are cloud provider specific. So if you want to get outside of if you're happy using Azure for all of your resource definitions, or if you're happy using AWS for all your resource definitions, a server-side execution model is generally fine. And I know there's going to be somebody going, well, CloudFormation has custom resources, so you can actually manage Cloudflare via CloudFormation if you really wanted to. I've never seen anybody do it, so it doesn't count. And then there's this kind of like subset of the server-side execution experience that is this Kubernetes-based experience. Who here has tried to use crossplane? Few smatterings of people. One of the things about using crossplane is you need a whole Kubernetes cluster before you can even get started. And of course, they have a they have a managed service that you can pay for, but all of these things are actually handed over to a Kubernetes cluster. So the server-side experience is just done by a Kubernetes cluster with a reconciliation loop instead. And if that isn't the most complex way to do infrastructure, you clearly haven't ever managed a Kubernetes cluster, because, like, you know, it's very much the draw the owl thing, like get a Kubernetes cluster and then do the rest of the fucking owl. Like that's generally what it means when you're doing a Kubernetes-based experience. If you're all in on Kubernetes and you have clusters everywhere and this is the way that you already are, this is probably going to work for you and it's probably going to be a path that you will enjoy. But there's a whole bunch of stuff here that you have to do. These are the two Kubernetes-based execution tools right now. If this is the kind of way that you want to go, these are the two options for you. And as always, I have a Venn diagram that allows you to make that decision. And then finally, there is this custom execution experience. So a custom execution experience is where you think a little bit differently about the way you might do things. And Pulumi allows you to do this with Automation API. It certainly seems like the execution experience you're going to get from System Initiative is going to be well outside of what we would consider all the other execution experiences that we've talked about. But these custom execution experiences are just a thought exercise for you. Like, if you really wanted to redefine how you were going to do infrastructure as code execution in your environment, what would you like to do? I personally like the idea of building Heroku-like tools that you can embed in a Go binary or embedding things in a web server. But the reason you might do this, how many people have had to kick a CI/CD system when the infrastructure as code tool didn't work the first time? Almost everybody. I'm not even going to ask for a show of hands because I know everybody's had to do it. So these are the kind of things where you can think about where are the pain points in your execution experience? Where are the difficult parts of your execution experience that you might want to abstract away? With a custom execution experience, you can actually embed your infrastructure as code tool into whatever execution experience you like. So that's the boring part, right? Let's do some hot takes. Opinions ahead. Again, if you want to argue with me about this afterwards, I'm only here till lunchtime, so go nuts. You know, we can talk about it until lunchtime, and then I'm going to leave. So you know, I'll just leave you all to argue amongst yourselves. This is my personal opinion of what it is like to be a DevOps engineer in a really, really difficult organization. You either do it all yourself, or you clean up after everyone else around you, and like. That's generally what happens in my experience in most organizations. I'm lucky enough to talk to lots of organizations in my current role, and a lot of them have the same problem. Like, there's one person who's like, I'm the only person who knows how to do it, so you're gonna have to wait. And then somebody's going, well, we need to get this new product out tomorrow. Like, well, tough shit, I got other things to do. So this is something that I think a lot of people in this room will have grappled with at some point in their career. How do you get away from that? How do you get to the point where you don't feel like you're going to get paged when you're on vacation or you're working an 80-hour week? Well, yeah, it starts with you. That's the real key here. You as an individual have to start thinking about things a little bit differently. And the reality of the world that we are moving towards with six-figure cloud provider spending bills, which I know makes a lot of us uncomfortable, but the reality is people are going to be allowed to provision infrastructure. Not just you. There's going to be other people in your organization that are going to have to provision infrastructure. I worked at a place for 6 years in which the test team would spin up an entire monolithic stack from a web page. And we did everything we could to stop them doing that. Everything we could. Like, the AWS bill is getting out of control. Can you stop doing this? But that's my job. Like, I have to test it, and if I don't have an instantiation of the infrastructure, I can't test it. So what we did instead is we let them do that, and then we put guardrails around it so that they couldn't screw it up. And we also said, if you don't touch it for a day, we're going to delete it, which upset lots of people, but that's the way it goes. But I've worked in organizations in which the marketing team comes along and goes, we're going to update the website. And you go, okay, when? At lunchtime. And you're like, well, I didn't hear about this. But that's the reality of the world that we live in. Even the marketing team, the sales team, everybody needs to provision infrastructure now. And you can say to them, no, that's not the way it's going to go. But the reality is they're probably going to do it without you or with or without you. And you probably need to help them do that in an effective way. So how do you make the choice? Well, I have some personal mantras. If it ain't broke, don't fix it. So if what you have already works, don't mess around with it. Like, for now, at the very least, don't screw around with it if you think it's working. But there's a really important caveat to that. That doesn't mean if you think it's working. It means if everybody who has to touch the system thinks it's working. Everybody in your organization has to be on board. And the reason that I put this in here is because I spent, as you've already said, as I've already heard, I spent a long, long time telling people no until I started telling people yes, and things started moving faster. And I was telling people no because I thought that we had it all figured out. And the reality was I was slowing the entire business down. That follows on to a second mantra of mine, which is productivity will always beat correctness. And what I mean by that is shipping things now and cleaning it up later is probably what the business wants in most circumstances. They don't want to hear you go, well, I don't know if we've got the right layer 2 subnet there, so like, can we have 2 days to think about what subnetting we're going to do? They don't care. They really don't care if you're going to use a /20 or a /22. What they care about is getting results and getting delivery. And then a final personal mantra is this whole idea of like simplicity being more is actually not true. Your least technical customers should be able to choose whatever infrastructure as code solution you choose. If they have a need to deliver infrastructure as part of their job role, whether it's testing teams, whether it's the CEO who's still doing pull requests for some reason, they should all be able to use the implementation that you choose. And it's great to think to yourself, well, I have got job security because I'm the only person that knows how this works. But I've seen people get laid off and then companies just go, we'll figure it out. So from a personal less is more idea, less is actually less. Make it as simple as you can for as many people as you can, and you will have much lower blood pressure. So this is a reasonable summary of some of that stuff. I promise you I am going to help you choose these things in a few moments, but you know. So this is some personal mantras. Summarize, productivity, don't mess around with stuff that you don't have to mess around with. Solutions should be available for the lowest common denominator. Finally, I'm going to actually skip that one. You don't need to hear more of me ranting. So when you make a decision, here's the 3 things that I think you should think about when you decide which infrastructure as code tool you should use. What is going to provide the most business value for your organization? Is it the current thing you're using? How are you measuring that business value? How are you deciding what that business value looks like? My opinion is that productivity is probably the #1 marker in that decision-making process. Security and cost are important, but they are less important than productivity, and you should figure out how to make things cheap and safe around productivity. This will get you many promotions. You will get many pay rises by following that single opinion of mine there, I promise you. And then secondly, what authoring experience is going to give you the most productivity across your organization? If it's a configuration language, choose a configuration language-based tool. If it's a DSL, it's not a DSL. Like I'm telling you now, it's not a DSL. What execution experience is going to make the most sense for your organization? What is the way that you want people to operate? And I'll leave you with this kind of piece of information. We have this little platform as a service type thing going on right now. Throwing YAML at a CI/CD pipeline is not a platform. It is a Rube Goldberg machine that you are going to have to fix. So when you think about that execution experience, think about what you want people to experience when they've expressed their infrastructure. So I put together a flowchart. I couldn't make it so that you could see the whole thing. So if you want to look at it a little bit closer, I also do have a flowchart that is way less professional than that. If you really want to see it, then hit me up on Twitter and I can send you that version. But this is basically a summarized version of all of the things that I've had to say. Some final thoughts before I give you all time to take a break, because I know you've been listening to my ranting for 45 minutes now. But please remember that the infrastructure as code solutions that have been out and around for a very, very long time are innovating as we speak. Almost every infrastructure as code tool is adding another authoring experience. Think about what it looks like at your current organization. Are you giving people other authoring experiences? If not, why not? Is it because you want to keep control of the castle? Or is it because you don't want developers screwing up your production environment? Like, those are the things that you need to think about because they are slowing your organization down. There is a sea change happening at the authoring layer, and it's happening around you as we're having, in the last 2 years. Try new things. One of the things that Chris said at the very start of this was, one of the great things about this conference is that we all just talk to each other about the way we solve things. Give every single thing at this conference a try, whether it's management config, whether it's Foreman, whether it's Pulumi, whether it's system initiative. It's worth kicking the tires. You will definitely learn some stuff. But the thing that we really should remember is that in the time that this conference has been running, we've gone from configuration management to infrastructure as code to whatever the next step is. And then finally, and I hope this has come across in this so far, but the one skill that you really need to learn that will kind of help you with all of these decisions is empathy is the one that is going to really change your career trajectory. Being able to figure out not what you want, but what everybody in your organization wants is going to be the thing that really is going to make your life easier, make your organization's life easier, and it's going to make things easier for everyone around you. Thank you very much for listening to me. I really appreciate it.
All right, we have a 15-minute break. After the session,
1 minute, no break.
maybe don't.
So before you run away, the sponsors have the voucher, have wristbands for the free drinks this evening, so go visit them. There's tea, there's coffee, and there might be some croissants.
After the break, we're in 2 rooms. So we're in the C1, one side, just 5 minutes walking that way, and we're in here.
Yeah, take your time. So let's start. So I'm Thierry. I'm from Belgium. Land of chocolate, waffles, and beer. And the non-enviable first place of longest periods without a government. But that worked very well because we have lots of governments, so we are quite resilient. Right, this is my hometown. If you haven't seen it, go watch it. At night, it's super beautiful. This is on. Okay, I'll start by doing what I do best. It's being vulnerable. Otherwise, the alternative is being an imposter. So, I'm quite shy and quite introverted. Well, all the good things for public speaking, isn't it? Right. Well, to be honest, public speaking is my worst nightmare, so I'm shaking here. Then you can wonder, well, why are you doing this? Well, what can I say? I actually love having spoken. It's like really energizing. So, that said, now I can start. So, I'm going to first introduce you to two teams, two quite different teams I've worked with in a not so recent past. So, somewhere in 2012, that's quite a long time ago, I had the opportunity to start a technical coaching mission with the sole purpose to upscale the software engineering skills of a quite novice team. So really novice from an engineering perspective, not really from a working experience perspective, because well, they had a working experience ranging from somewhere 5 years till 20 years. And well, they just didn't have the luxury to work with people that showed them different ways of working or to attend conferences like this one. So luckily I wasn't alone coaching this team. We were the two of us, which is quite reassuring if you have to introduce lots of change in front of people with lots of working experience. Now when we started, we discovered a situation we weren't quite expecting to still discover in 2012. So no one, except for one person, was using any version control system. Yeah, right. So code was shared using shared drives, obviously. So the first thing we did was actually introducing a version control system. But because the team was novice, didn't have experience using version control systems, I thought Git would be a bridge too far. It's just too many concepts to learn. Like this whole idea of having a remote repository, a local repository. When you commit, it's not in a remote repository. Well, whoa, far too complicated. So I suggested we'll go for subversion. It's fairly simple. We only have 3 concepts to master. We check out code, we modify it, we check it in. Simple. And at the time, it was said that, well, branching is rather difficult with subversion. Easier than with CVS. Anyone use CVS? Yeah. But more difficult than with Git. So I also suggested, well, look, we won't use any branches at all. And well, to be honest, at the time, I didn't understood much about branching strategies, and it all seemed far too complex and far too complicated for my simple mind. Now, so everyone was going to commit into trunk, and that worked pretty well, because it was the second thing we introduced right from the start, and that was the practice of continuous integration, and team commitment had to be covered by an automated test, and preferably a Now, at the time, this way of working was a valid branching strategy, and that it actually had a name. It took me several years to find out this was called trunk-based development. Now, was trunk never broken? Well, it happened a bit more often than actually good. Remember, it's a novice team, but it wasn't really a problem. Continuous integration in place. that allowed us to uncover the problems quite early, fix them while they were still small and easily to fix. Now, a year or two, now mature enough, has enough confidence in using systems, it's time to migrate to Git. And the main driver was, well, first of all, there is to manage Git repos, but more important, we wanted a pull request model for code reviews, and so we wanted to create branches. Where we have a core team that maintains a system and accepts outside contributions doesn't necessarily work very well for a co-located team inside. So, like with all powerful tools, there are many ways you can use them, not all of them are good. And the fact proponents of distributed version control systems use feature branching to sell distributed version control systems, together with all the tooling that exists around distributed version control systems, while makes everyone blind for all the problems. And they just didn't question it. It was and they just didn't question it. It was like the most normal thing to do. Now, after that mission, somewhere in 2016, I had the opportunity to collaborate with a totally different organization. Quite agile, working with highly skilled engineers, where everyone was working almost full-time in pair. But they decided as an organization to adopt Git flow as a branching strategy. Oh my. So when I arrived, branches were living from somewhere 5 days to 30 days. And so people were spending much non-valuable time in rebasing mainline into their branch, fixing merge conflicts, doing rework. So when I saw this, I was like, and with my experience working with this novice team, I suggested, well, shouldn't we try out an experiment with string-based development? And at the time, a new project was going to start where only 2 team members would work on. So wouldn't be very riskful. Well, trying to convince people of the benefits of string-based development is really not an overnight task. It's quite painful and it requires quite a lot of energy. Especially when you suggest that in front of experienced, skilled engineers. So every time I have the same reaction. So people stare at me like I'm an idiot. What are you saying? The whole industry is using some sort of branching strategy. It's one of the most accepted practices. And you are just suggesting that everyone is going to commit directly into mainline? It's gonna be a mess. We will have merge conflicts all over the place. So, although string-based development is implied by continuous integration, although string-based development is reported since 2015 by the State of DevOps report as predicting higher IT delivery performance, and although string-based development is practiced by organizations like Facebook, like Microsoft, Netflix, and Google at an extremely large scale. So at Google in 2016, we were speaking about 25,000 engineers working on a single trunk with 16,000 changes per day. It is still one of the most controversial practices in the IT industry, and still nowadays. And so I failed. I miserably failed in trying to get this organization to run an experiment with string-based development. And I failed because I lacked the right arguments, because I only had this one experience with this one novice team. Although in my past career, I used quite some branching strategies, but I never really paid attention to the problems that arise from using branches. So I took the opportunity to observe what happens, and this resulted in this presentation. Now, before we move on, I want to introduce some definitions, or reiterate some definitions. And I'm sure, well, you know these things, you know these practices, but as it often happens in our industry, people like to redefine practices so they match their way of working, and so people can tell we practice those practices. So first of all, what is mainline? So mainline is the line of development that acts as the reference from where builds are created and that feed into your deployment pipeline. So for Git, this is mainline. For Mercurial, this is the default branch. And for Subversion and CVS, this is string. What is feature branching? Well, feature branching is a practice where people do not merge their code back into mainline until the feature they are working on is done. But not yet done. So done means it is dev complete, but there is still a lot of work to be done before that feature gets into production. So first of all, a new build has to be created, automated tests has to be executed, then manual testing needs to happen. Eventually, load testing, performance testing, and security testing needs to happen, and then we can deploy into production. And then we have to run the smoke tests, and then we can release to the end users. When we've done all of this, the feature is done. So with feature branching, the implementation of a feature starts by the creation of a branch. The feature grows on the branch. When the feature is done, it goes through a gating process called a code review. When it goes successfully through the gating process, it gets merged back into mainline, and it gets into, and then it follows its train. So when we speak about feature branching, we really mean long-running branches, branches that live longer than a day. What is continuous integration? Well, it's a practice where everyone in the team integrates their work frequently into mainline, at least once a day, leading to multiple integrations per day for the whole team. And every integration is validated by an automated build. So it's a practice that ensures always working software on mainline. And that gives us feedback within minutes on whether a change broke the application or not. So, and this involves that everyone in the team commits at least once a day into mainline. Every commit triggers an automated build and execution of the automated tests, and whenever the build fails, it gets fixed within 10 minutes. Now, the easiest way to fix a broken build is just to revert the last failing commit and go back to the last known good state. Now, for continuous integration, we don't need much tooling. James Shaw wrote a quite funny article about this. It's called Continuous Integration on $1 a Day, and the only thing you need is a version control system, an automated build, a crappy build computer, a silly toy, and team commitment to never break the build. That's it. And lastly, what is the goal of an organization? Well, the goal of any organization is to actually make money. And to achieve that, we need to sustainably minimize the lead time to create positive business impact. And lead time is the clock wall time between we as a team has an idea. That idea is implemented, deployed into production, and released to the end user. And positive business impact is anything that either generates money, this is turnover, saves money, this is cost reductions, or protects money, and this is being ahead of our competition. Now, we want to reduce this lead time because we want to accelerate feedback. We want to know as fast as possible if the thing we have just designed, implemented, and released to the users is actually being used by the user and how it is being used by the user. And based on that information, we can take new decisions and run new experiments to find new unmet needs of our customers and find new ways to delight our customers, which is a huge competitive advantage. Now, before I could ever suggest string-based development again to people, I had to understand why teams are using feature branches. Which problems are they trying to solve with feature branches? And so I asked around. I asked proponents of feature branching for their reasons, and they shared several with me, and I'm going to share 4 of them with you. So the first one was, well, it allows us to work in isolation, and therefore we are more productive. And I have to admit, the first time I heard this, I was like, yes, of course, makes total sense. But then I started to think over this, and I was like, yeah, whoa, wait a minute. This looks like a local optimization. we are optimizing for individual developer productivity. But designing IT systems is rarely an individual activity. So most of the time it is a team activity. So the team goes only as fast as the slowest merge. As long as we haven't merged back, well, we simply do not know how much work is left to do because of potential merge conflicts and potential rework that will happen at merge time. And so integrating changes becomes very time consuming and very unpredictable. And as a result, our IT delivery process becomes unpredictable, which will increase our lead time and our time to market. Remember, the goal of our organization is to sustainably reduce the lead time to create positive business impact, so to make money and to generate feedback. And here we're doing the exact opposite. So instead of optimizing for developer productivity, well, we should optimize for team productivity and adopt a team-oriented branching strategy like tree-based development. The second reason I received was, well, if a refactoring goes nowhere, we can just delete it. And again, when I heard this, I was like, yeah, makes sense. And then I started thinking about it, and I was like, yeah, but wait. What I think they are trying to say here is, well, we have this problem, we don't know the solution right away, so we're just trying something by committing code into a branch, hoping somewhere we will get to a solution, and if we don't, well, no problem, we just delete the branch. Now, to be honest, I still have to see the first team that is willing to delete a 1 week or more than 1 week work. Just saying. So, if we don't know the solution right away, why don't we spike out some ideas? And this is the purpose of a spike. It's to write throwaway code to test out an idea. And the output of a spike is not production code, it's actually knowledge. We are creating knowledge. And so after a couple of hours, well, we should know if an idea worked out or not. If it didn't work out, no problem, just throw away the code and start over again and try another idea. If it did work out, well, great. We found a solution to our problem. Again, we're going to throw away our code and start over again. But this time we are going to implement a solution in small incremental steps using the knowledge we've just created during that spike. The third reason I received was, well, it allows us to control the quality of what goes into production. Because, well, only features that went successfully through a gating process called the code review are merged back into mainline and deployed into production. Now, isn't controlling the quality of features the exact purpose of having continuous integration and continuous delivery in place? So the objective of continuous integration, and by extension continuous delivery, is to eliminate bad release candidates as soon as possible. And only changes that went successfully through all stages of the deployment pipeline and that have been thoroughly tested get deployed into production. So in my humble opinion, this is the most effective way to control quality and not a manual gating process like a code review. And lastly, it allows us to control which feature goes into production and which not. Or more precisely, it allows us to prevent that unfinished functionality goes into production, because unfinished functionality is sitting on the branch. As long as the branch is not merged back, it doesn't get into production. Now, what we are actually doing here is using our version control system to turn features off and on using via manual merging. And this is nothing else than a poor man's modular architecture. So instead of using our version control system as a manual toggling mechanism, well, we should design our systems in such a way that we can turn features off and on during deploy time or runtime. Right. Now, why are feature branches a problem? Well, first of all, it delays feedback. As long as we haven't merged back into mainline, we simply do not know if our changes broke the application or not. It's only the minute that we merged back into mainline that continuous integration process is triggered. Now, this delay in feedback increases with the duration of our branch and with the number of parallel branches that exist. So if our branch lives for a couple of hours, feedback is delayed for a couple of hours. If the branch lives for a couple of days, feedback is delayed for a couple of days. Remember, continuous integration is this practice that ensures always working software on mainline and that gives us feedback within minutes on whether a change broke the application or not. Now, lots of teams like to redefine continuous integration by saying, well, look, we have GitLab CI running against all of our branches, you know. Well, having an automated build running against all of our branches is actually a really, really good thing, but it's not continuous integration. We are not integrating. The only feedback that we receive is that the code that exists inside the isolated branch still compiles and that we haven't introduced any regressions against the tests that exist inside the branch. We do not know how this code integrates with all the other code that exists on all the other parallel branches. So from this moment on, CI doesn't stand for continuous integration, but stands for continuous isolation. We are not integrating outside changes, and the rest of the team simply do not know how our changes will affect their work. If we are developing multiple features at the same time in parallel, each on their branch, integrating these features together becomes exponentially harder with the number of features that are being developed in parallel and the number of changes that are required to implement the features. Now, one way to solve this integration problem is to adopt something that Martin Fowler calls promiscuous integration. Now be aware, Martin doesn't advise promiscuous integration, he just named the pattern. Or shall we say an anti-pattern. So in order to use a change from another branch, we are going to cherry pick commits from one branch into our branch. And so what we are essentially doing here is communicating changes between branches. Now the biggest concern Martin has against promiscuous integration is, well, apart from the fact that we are introducing quite some process complexity, is that we lose track on who has what on which branch. Now compare this complexity with the simplicity of having everyone in the team committing directly into mainline multiple times a day, and as such communicating changes with the whole team, and as such creating a shared understanding and a collective ownership of the code base, which will inevitably have a positive impact on code quality and on throughput. As long as we haven't merged back into mainline, the rest of the team simply do not know in which direction we are taking the code in order to implement the feature we are working on. Now, this is okay as long as everyone in the team is working on different code base areas. But the minute that two team members are working on the same code base area, well, they are each blind on how their work will affect the other person. On the other hand, if we are committing frequently into mainline while we are communicating with the rest of the team, the direction we take with the code to implement our feature. So for instance, we could introduce a conditional indicating to the rest of the team where the new code starts and have this conditional turned off by default. From this moment on, while the rest of the team sees our changes, sees how these changes will affect their work, and they can adapt immediately. Now we can argue that introducing a conditional introduces complexity in the code base because we are introducing branching logic, and yes, you are right, it does. On the other hand, not introducing the conditional but using a feature branch doesn't remove the conditional. The conditional is still there, but it's absolutely not obvious and absolutely not visible because the conditional from this moment on is our version control branch. And from this moment on, the rest of the team, well, doesn't see our changes. Our changes are invisible for the rest of the team. So now remember, a version control system is not only there to version source code. It's first and foremost a communication tool to communicate changes with the rest of the team and to create a shared understanding and a collective ownership of the code base, which will lead to better quality and higher throughput. Because we are hiding work for the rest of the team, it discourages the adoption of refactoring. Now, as long as we are adding new code to the code base, integrating these changes is fairly straightforward. But the minute we start refactoring, we are introducing new concepts, new abstractions, and well, version control systems are simply unaware of semantic changes, and this makes merging quite complicated and time consuming. So if we have two team members working in parallel, each on their feature, and one person refactors and merges first, and the second person has a significant amount of changes on his branch, merging back will be rather painful for that second person, and it might introduce some tension in the team. Now, the longer the branch lives, the more refactoring we perform on the branch, while the harder it becomes to merge back because of all the merge conflicts and all the rework we will have. And so integrating changes becomes time consuming, which will slow down the team. And it is this slowdown of the team that discourages the adoption of refactoring. But we all know that if we don't refactor, well, we are not paying back technical debt. And if we are not paying back technical debt, well, adding new functionality to the code base becomes more difficult and harder and more time consuming. And again, the team is going to slow down. And so we end up in this vicious circle where the team slows down over time, eventually comes to a halt, and nobody really understanding how and why this happened. Now, when using branches, we are in fact introducing batch work. So the longer the branch lives, the more changes are accumulated on the branch, the bigger the batch size is, where the batch size is the number of commits that exist since the creation of the branch. Now, the bigger the batch size, the more work in progress we have. And work in progress is just inventory. And inventory is money stuck into the system. It is stuck into the system because our organization invested quite a lot of money to create all the code that exists on all of the parallel branches. But it didn't generate any value. As long as we haven't merged back into mainline and deployed into production, well, we don't get feedback. It's only the minute that we merge back and deploy and release to our users that we see how this code behaves in production, how it is being used by our users, and that we can start taking new decisions and run new experiments. Now, to reduce this inventory, we know from lean manufacturing we have to reduce work in progress. So this means we have to reduce the lifetime of our branches. So we need to commit more frequently into mainline, integrating our changes more frequently, and so achieving a state of continuous integration and get closer to a single piece flow. And we know also from lean manufacturing that a single piece flow will increase throughput, reduce lead time, and reduce time to market. Because feature branches introduce batch work, it also creates bigger change sets, and bigger change set is just a bigger risk. So if we are committing frequently into mainline, well, the change sets are small, and so our continuous integration process only has to process a small change set. So if the build happens to break, finding the root cause will be fairly easy because the change set is small. And also, probably we've introduced a failing change just 5 minutes ago, and so we still have enough context to fix that build easily, and so we will be able to fix the build within 10 minutes. On the other hand, if we are using feature branches, well, we are committing less frequently into mainline, and so our continuous integration process will have to process a bigger change set. So if the build happens to break, finding the root cause will be far more difficult because the change set is so big. And also, maybe we've introduced the failing change a couple of hours ago, or worse, a couple of days ago. And so we don't have enough context anymore to fix that build quickly and easily. And so we run the risk of having a broken build for a long period of time, and we've just lost the monitoring of the health of our application, and so we've lost the ability to perform on-demand production releases at any given moment in time, which will increase lead time and increase time to market. And lastly, it creates cognitive overload. So to start the implementation of a feature, we need to create a branch and push the branch to a remote repository. To reduce merge complexity, we have to rebase mainline onto the branch frequently. to communicate changes between features, well, we have to cherry pick commits from one branch into another. If we have to switch work between features, which is never a good idea, but well, shit happens, we need to switch between branches. And lastly, when the feature is done, we may not forget to delete the branch, or we run the risk of having a repository full of branches. So in order to implement a feature, well, a team needs to perform lots of operations on a day-to-day basis. And so team members have to remember lots of version control system commands, which creates cognitive overload and might slow down the team. Compare this with the simplicity of having everyone in the team committing directly into mainline multiple times a day, reducing redundant work and simplifying the workflow. The only thing we need to do is pulling the latest changes, add our local changes, commit and push, and we're done. It's fairly simple. As a result, team members only have to remember a small subset of version control commands. Yeah, for a long time I didn't know how to create a branch in Git. How can we avoid this? So, all right, there are lots of problems, but how can we avoid all these problems? Well, by adopting continuous integration as it was meant when introduced by the extreme programming community in the late 90s. Ensuring always working software on mainline, enabling us to perform on-demand production releases at any given moment in time. This is one of the most critical practices to adopt in order to enable the fast flow of work through our value stream and get us closer to a single piece flow. And this implies the practice of trunk-based development. So trunk-based development is what team members or pairs practice in order for a team to achieve continuous integration. It is a version control strategy where everyone in the team commits multiple times a day into mainline. As a result, change sets are very small, merge conflicts are very rare, and the code base is always in a releasable state. So we can always do production releases at any given moment in time. Testing happens on mainline, and ideally releasing happens from mainline. Every release needs some stabilization. Well, we can create a short-lived release branch and then release from the release branch. But fixes happen on trunk and are cherry-picked into the release branch. So when releasing, we can just delete the release branch without merging back into mainline. Now, trunk-based development is really not a recent new hype, as I sometimes read on Twitter. So trunk-based development is actually there since a very long time. It's there since the early 80s, when RCS was introduced as one of the first version control systems. It had support for branches, but teams were very cautious, and so they stuck to trunk. All right, but how can we achieve continuous integration? How do we make sure it doesn't become a mess when everyone in the team is starting to commit directly into mainline multiple times a day? Something most teams are most afraid of. Well, we have several practices at our disposal. Actually, there are 14 practices that make continuous integration. I'm going to share 4 of them with you, because 14 makes a talk on its own. And I actually have a talk that talks about that. And the first practice is, in my humble opinion, the most important one to adopt, but it seems, from what I see, it's also the hardest one to adopt. It's working in small increments. Breaking large changes in a series of small incremental changes, ensuring our system is always working. Steve Freeman and Ed Price make this analogy with surgery in their book Growing Object-Oriented Software Guided by Tests, where they say surgeons prefer keyhole surgery because it is less invasive and it is cheaper, while for the same reasons we like to work in small incremental steps because it's less invasive. We are not ripping apart our systems, And therefore it is cheaper because our systems are always working and we can perform on-demand production releases at any given moment in time. But this means several things. First of all, it means we only commit on green. And this is where test-driven development supports continuous integration. So we start by writing a small failing test. We add just enough production code until the test passes to green, and we commit and we push. And then we start refactoring. If the test is red, we revert. If it is green, we commit and we push again. And so test-driven development will create this commit cadence that we need in order to reach continuous integration. Second, we absolutely need a decoupled code base. When the code base is too coupled, it is really, really hard to work in small increments because any change will ripple through all layers of the application, ripping apart the application, making sure the application is not working for a long period of time, and as such disabling us to perform on-demand production releases. And this is why adopting architectures like hexagonal architecture, also known as ports and adapters, and principles like the single responsibility principle or dependency injection are so helpful. So this architecture and these principles will not only improve our code base quality, but it will also help in increasing our IT delivery throughput and reducing lead time and time to market. And lastly, we absolutely need lots and lots and lots and lots of very, very, very fast tests. We need lots of tests to gain enough confidence we are not introducing any regressions when committing frequently into mainline, and they need to be fast in order for us to be able to commit frequently because we need to execute those tests each time we want to commit. When tests are too slow, two things can happen. Either teams do not execute them, and then they run the risk of introducing regressions when committing into mainline or having a broken build. Or they tend to run them less frequently, and then they start batching up work, and we know from batching up work that this will reduce our feedback, and it will have a negative impact on quality and on throughput. The second practice is the easiest one to adopt. If you have unfinished functionality, just hide it. It's perfectly acceptable to have unfinished functionality sitting in production, even behind a publicly accessible URL, as long as it is not discoverable by the end user and it doesn't introduce any security concerns. So for instance, if we are adding a new screen to a user interface, as long as the screen is not finished, well, just don't add a menu entry in our navigation menu. Only add this at the end when the screen is finished. Same is true with adding new API endpoints. As long as the API endpoint is not ready, do not document it. No one will know it exists. If you have to perform large-scale refactoring, that could take weeks or months, and that could rip apart our application for a long period of time. Let's say we want to upgrade Kubernetes. Yeah, of course, you can upgrade Kubernetes in place, but well, if shit happens, I invite you to roll back, but I don't want to be in the room when you do that. Yeah. Or let's say a more simpler example is like you want to rename the security group, which you can't. You can only delete the security group and recreate it. Duh. And if it's attached to an EC2 instance, well, you can't even delete it. So instead of using the classic approach of branch by version control, where we create a branch, do the modification, and then roll out the thing, well, we should adopt expand contract. So expand contract is a practice that allows us to perform large-scale refactorings in small incremental steps. And while doing this, keeping the whole application and the whole system still working and still being able to perform on-demand production releases and still being able to add new functionality to our systems. From what I see, it seems to be that expand contract is this little gem that few engineers are aware of, although it is a very strong enabler of continuous integration. It's one of the most important practices to adopt in order to work in small incremental steps. How does it work? Okay, so let's say we want to upgrade Kubernetes. Crazy idea. So we start from a situation where we have a cluster with lots of services and lots of DNS records pointing to those services. So the first thing we are going to do is create a second cluster with the new version next to the old cluster with the old version. So we now have two clusters, the old cluster with lots of services and a new cluster with empty. Our system is still working and we can still perform on-demand production releases at any given moment in time. This is called the expand phase. We have expanded the code base and our systems with an additional cluster. Then we start to gradually move services from the old cluster to the new cluster. And each time we move a service, well, we can commit. And each time we can perform production releases at any given moment in time. And lastly, when the old cluster is empty and the new cluster has all the services, well, we can safely remove the old cluster without breaking the system. This is called the contract phase. We are contracting the code base and our system by removing a cluster. Now, evolutionary database changes like renaming columns, moving columns between tables, splitting columns into two columns, renaming tables are also examples of expand contract. Introducing a V2 API alongside a V1 API with different URLs is another example of expand contract. Blue-green deployments is expand contract for deployments. So we start with one version in production, then we add a second version, the blue version, and then we have the old version, which is the green version. We keep blue and green running at the same time until we think that blue is good enough, and then we take away green. Now, I have to admit that this adds quite some complexity to our code bases and to our systems, and that we will have to think harder and that we will move slower. But it has the enormous advantage of never breaking the flow of work through our value stream. We are never blocking the addition of new functionality to our systems while we are doing this refactoring. And as a last resort, we have feature toggles. Feature toggles allows us to decouple code deployment from feature release, which is called dark launching. So we are going to deploy code changes into production days or weeks in advance before releasing to the end user. Now it allows us that we can actually test this code in production while it is invisible for the user and while it doesn't impact the user. And we can even test with production load by having user sessions perform invisible calls to the new feature. It also allows us to perform canary releases where we gradually release to the user base. We start with a small user base, we check if everything works correctly, and then we start by increasing the user base. If it starts to work badly, well, we can roll back at runtime by turning off the feature, which is far less risky than having to redeploy an old version. Now, in my humble opinion, this is the last resort. We should first master working in small incremental steps, hiding functionality, and expand contract before jumping into feature toggles, because, well, feature toggles comes with its fair share of problems. It's very easy to shoot oneself in the foot when managed badly, like what happened with Knight Capital Services. So Knight Capital Group was a financial services company that was the biggest trader in US equities on the NASDAQ and the New York Stock Exchange that managed to lose $460 million in 45 minutes and went bankrupt because they reused a feature toggle between two releases but give it a different meaning, and they did manual deployments on 8 servers and they forgot to deploy on one of 8 servers. Whoops. So there was one server running the old version using the old meaning of the toggle. So like with work in progress, we want to limit the number of active feature toggles. As soon as a toggle is not needed, it is removed from the code base as soon as possible. Otherwise, we run the risk of having a code base with lots of toggles, no one knowing wherefore they are used, no one daring to remove them. Toggles need to be independent from each other. So one feature, one toggle. Don't have a situation that to turn on a feature, we need to turn on toggle X, turn off toggle Y, and turn on toggle Z again. It's an insane situation. It's very difficult to test. It's very difficult to reason about this. No, one feature, one toggle. When we say toggle, we say branching logic. Branching logic needs to be tested, so we need to execute our automated tests against the systems with both the toggle on and off. And lastly, when we say branching logic, we say complexity, maintainability problems. So there are different ways on how to implement toggles. Not all of them are good. Pete Hodgson wrote a good article that describes how to implement toggles in a maintainable way. It's called Feature Toggles, and it's available on Martin Fowler's Bliki. Pete Hodgson also wrote a couple of interesting articles on managing toggles on the block of Split.io. Now, whenever I suggest string-based development, there is always this single question that I always get asked. What about code reviews? How do we do code reviews? Yeah, I know. I see the timer. How do we do code reviews when we don't have a branch? Well, first of all, code reviews are not mandatory. It's an option. It's a decision of your team. Many teams think that because they do code reviews, they are mature because it is a best practice. Well, it is seen as a best practice. Well, if your team is really mature, well, you could expect they will do the right thing, and so we don't need this extra approval step. If we still want to do code reviews, well, the first solution and the most easy one is pair programming or assembler programming, because it gives us code reviews continuously. Code is being reviewed while it is being written before it's committed on mainline. And Dave Farley reported this is good enough as code reviews for highly regulated industries like finance, healthcare, gambling industry. If we don't do pair programming or assembler programming, or we still want a formal code review, well, we have still two post-commit options. And the first one is the most known one and the most used one, is the pull request model. But this time with short-lived branches. Now, honestly, I've never seen this work. Although many people I really respect gave me positive feedback that it does work. Now, my biggest concern is, first of all, the branch lives longer than expected because of the ping pong that happens between reviewer and reviewee. Reviewer not available, reviewee not available. And most importantly, it blocks the flow of work through our value stream. It blocks the delivery of a feature until the feature has been approved. And lastly, we have the non-blocking code review, where commits will be reviewed after the fact on mainline. I had a very good experience working this way with this novice team I've introduced at the start of this presentation. So it might happen, so the biggest advantage is we are never blocking a feature. So features can be deployed whether they have been reviewed or not. And it might happen that the feature is only reviewed when it is in production. Now we can argue that there is a risk of introducing bad code quality in production, and yes, this will happen for sure. And I don't see a problem over there because bad quality is not a bug. And code reviews are not there to catch bugs. For this we have automated tests. But this can only work if we have team commitment that all commits will be reviewed, and that whenever a code review issue is found, it is fixed with highest priority so that it is removed out of production as soon as possible. Now, I'm coming to the end, sorry. What are the benefits of string-based development? Well, if we are committing more frequently into mainline, we are going to create more frequent builds. And if we can create more frequent builds, well, we can deploy more frequently into production. And as a result, well, we are increasing throughput, reducing lead time, and reducing time to market. Now, if we can deploy more frequently into production, well, we can also run more experiments. And so we can find more unmet needs of our customers and find more ways to delight our customers, which will increase customer satisfaction exponentially. If we are building more frequently, we will be able to uncover more problems earlier, allowing us to fix them immediately, and as such, build quality into the product instead of having to test the quality in the product later, which will lead to better stability and better quality. So string-based development predicts better quality, better stability, and higher throughput. And this has been confirmed by the 2016 peer-reviewed academic paper, The Role of Continuous Delivery in IT and Organizational Performance, by Dr. Nicole Volsgren and Jess Humble, and the book Accelerate, by the same authors, and Gene Kim, where they found out that string-based development, together with continuous integration, are statistically significant predictors of adopting continuous delivery. And continuous delivery is a predictor of higher IT delivery performance, and together with the adoption of lean product management and a generative organizational culture, will predict higher organizational performance, like money-wise, generating more revenue, more market share. Now, where's the evilness? You've never mentioned the evilness. Well, the evilness is not so much the problems that are introduced by the use of feature branches, but the evilness hides behind the use of feature branches. What are the real problems, or the real reasons that teams are using feature branches for, which is not necessarily the reasons that proponents of feature branching shared with me at the start of this presentation. Now, in my humble experience, well, the real reasons are there is a lack of incremental software engineering skills in the team, or the code base is just too coupled, preventing the team to adopt incremental software engineering skills, or there is just a lack in automated tests, which prevents the team to gain enough confidence of not introducing regressions when committing frequently into mainline. Or the build is just too slow, preventing the team to commit frequently into mainline, because they have to run that build each time they commit into mainline. So feature branching is more like a symptom treatment and not really a solution to a root cause. And it tends to hide the real problems of teams, whereas if teams adopt string-based development, it will uncover these problems and force these teams to actually do something about it. Does it mean that string-based development is easy? It is not. It is quite hard, quite difficult. It was like, well, for us software engineers, like adopting test-driven development. It was difficult to move on. So it requires a mindset shift. Many engineers think it cannot possibly work in their environment, in their context, so they are very skeptical. And from my experience, it requires a lot of energy to try to get a team to run an experiment with string-based development, especially if you are alone in front of 6 or 10 engineers. But once they try an experiment, once they start trying string-based development, and they start to see the benefits, and they start to see how much simpler the workflow becomes, they cannot imagine another world using branches anymore. Thank you for your time.
You probably save them hours of time if they listen to you.
We had a little bit of a snafu earlier. We had a bit of a snafu earlier, and we didn't get our vendor table out and everything, so we're just going to do a vendor pitch instead. Just so. Anyways, marketing put together like this real nice buzzwordy deck for me, and if you've ever seen me speak before, you know that's not really how I fly usually, but it was real important because, Craig, this is for you. If they don't, they'll be very furious with me if Craig doesn't get a photo of me talking and get that out on the Mastodon and whatnot. So anyways, something that we have learned over the last forever years is that DevOps and config management and like now platform engineering and everything else, it's all about communication, collaboration. Like it's this shared language in which different teams, different people, all the different people on all the different teams, it's just how they communicate to effectively get shit done. So and Puppet's been right there enabling this collaboration right there from the beginning. We've been right here in Ghent for like a decade now. And honestly, we're all super glad to be back here. I'm gonna use Adam's phrase here, seeing all you motherfuckers' faces again. So we've got a new logo, slightly new logo now. You may have heard that particular news. But the interesting part is just that now we fit into a larger portfolio of DevOps tooling, automation tooling, and this lets us focus again on the things that make Puppet great in the first place. So have a great time at the conference. Like I said, we had a little mix up with the swag, so it might be hard to find us. But stop by and say hi. We're around.
Okay. Who does not know what an Ignite is? That makes it easier for me. We're moving 2 Ignites from today to tomorrow. One schedule conflict and somebody who's not feeling too well. Let's hope she's back tomorrow. But apart from that, who wants to go first? Alessandro, or Lander, or Brian, or Nicholas, or Philip?
I lost the battle.
Okay, the Italians won.
Let's cut it for quick.
Are you ready?
Sort of.
Sort of.
So I'm Alessandro Franceschi, and I'm here to talk about TinyPuppet, this tool which can install everything, and I'm going to challenge you on this statement. What is TinyPuppet? It basically is a Puppet module. Every Puppet module, when you talk about Puppet, has some features which you expect from it. Should be well documented, reusable, tested, idempotent, support multiple operating systems, optimized for performance, and maybe even have bold tasks. And typically one module has and manages one application and only that application. Well, TinyPuppet is all these things, but actually it doesn't manage just one application. TinyPuppet is able to manage every application. And we are going to see quickly how. You can install it with Puppet module install example42-tp. And once it is installed, you can use it to install every application as we saw. I'm telling this for years, really. But actually, there is something new this year, which I'm going to present you, is how you can install these many different applications on every different operating system in every way. Using native host packages, using upstream repositories, downloading the release starbolts and binaries and then getting the binary in your file system, compiling from source code via Docker image. All these different installation methods are now possible with TinyPuppet. And you can also configure your applications with TinyPuppet as code, as data, taking care quickly and easily how to configure many applications, different applications with just one module. You can use it also to manage full directories of your applications, also maybe with contents taken from a Git source. Here is an example of data you can use to define 2 directories related to the different applications with the contents you want. And that's not all. Actually, with TinyPuppet, you can do a lot of other things which are all related to it. For example, test. Whatever you install with TinyPuppet can be tested easily with a command line or a bold task in a CI/CD pipeline, on demand, via Mongo, and so on. Whatever you install can be easily automatically tested. You can also troubleshoot it TP log, your application, you see the logs of application. TP info, you see info about the application. TP debug to get deeper in the application, and maybe even get the source code. TP source, your application name, you download the source code of the application, eventually you have it at disposal. And all this is possible as Puppet code via YAML data, via the command line, or via Bolt task. So Tiny Puppet is many different things, can manage every application in these different ways. So for example, if you talk about data, the higher data which we can use to configure different applications in different ways, installing them in different ways and so on. That's it. That's what you need. That's what you can do with Tiny Puppet if you want to use it as data. Of course, you can have multiple options. And you may wonder how you can do this. How is it this possible magic things? Well, it's all about tiny data. Tiny data is the data which defines all the things about our applications, and is used by Tiny Puppet. But Tiny Puppet 4 is going to be released soon with that tiny data format, which is in this shape. Version 4 looks like this. To define everything about an application, I just need to write something like that. And it's quite easy, actually. I can manage and create the support for many different applications in very quick time. So that's my challenge here. Sorry, guys. I challenge you to make me install any application you want on any operating system you want in any way you want with Tiny Puppet. Open a ticket somehow on GitHub, going to come the references, and I will try to manage it with Tiny Puppet as soon as I can. If I fail, I offer you a beer sometime in some space time. If I deliver, please talk, use it. I mean, I did the effort that I tried to use this command to install your application in your operating system. So all this is coming with the Puppet 4, Tiny Puppet 4. All this data about packages and applications can be used for different things, like packaging, for example, images with this application and with your configurations. But this is something which I will tell you about sometime sooner or later. So the whole point is, even if you don't like, if you don't know anything about Puppet, you can use Tiny Puppet as a tool, a command line. So Puppet is the language, you don't care about it. You don't need a Puppet infrastructure. You can use TP, the command, to install from the command line, straight ahead, every application. TP install sysdig, you get a sysdig with the repository upstream, and that's it. TP install CrowdSec, you install a CrowdSec on Debian, Ubuntu, Red Hat, Darwin, and so on. Everything else can be managed as data, so that's the next step, too quick to go. But TP Desktop is another feature of Tiny Puppet which allows you to configure your desktop in simple YAML files. Give it a try because it could be quite useful. So that's it, 5 minutes. It's all his fault because he gave me just 5 minutes to talk about this thing. Feel free to try it, challenge me on Tiny Data. Thank you for listening.
I was about to say Brian has a challenge for you, but Nicolas wants to go first. Did I just drop all the meal vouchers? Are you ready?
Too many people.
Too many people, okay.
It's intimidating.
Good luck.
Thank you. Hi, everyone. I will start with a question. Who has already heard of Rudder here? Okay, solid quarter. So we've made a survey to learn about our users, what they do with Rudder, what they like about it, what they don't like about it, what they would like to be changed. We've made a survey started on the 29th of December. Probably not a good idea, retrospectively. Sorry, I'm French. We sent a link by mail and by social media, and we got not very good results. The mail was only opened by 200 people. Not much impression on Twitter, so we got only 50 people who started to fill the survey, and only 14 who went to the end. The reviews, we cover the demographics and the statistics of the users, what they use with Rudder, and what we learned with this survey. I will complete it with customer from data that I know, data from customers. So most of the users who answered the survey have been using Rudder for a long time, more than 1 year or more than 5 years, using in the team, in the application, in the in the whole team, in the whole IT department, or by themselves. This small company, large company, medium company, the same percentage. Mainly in IT services of software publisher, we know more of people in industry and large companies, so that's a bit surprising for us. It's an operation-based tool, so mainly people from operation or DevOps, but we have a bit of security management, the green arrow. It means that the security teams are catching up with Rudder, and it does match our customers. In Rudder, we measure the compliance of the systems. Most are compliant, except one, which is average compliant, but is using disconnected systems, so systems not online are not compliant. We measure the infrastructure complexity with the number of groups. So in Rudder, you have nodes that you manage. You group them based on their inventory. The more nodes, the more complex is your infrastructure. It's quite medium. And the maturity of configuration. So we can measure it with the techniques. Techniques are like playbook in Ansible. So the more techniques, the more things you manage. We have some who are using a lot of techniques, even with a small number of nodes, like 125 techniques for 500 nodes, which is pretty good. Rudder is mainly used for configuration management, but also for provisioning and deployment. And we see in the results that all but two are using Rudder for either patch management or hardening, which does confirm that moving to security is a good idea. Everybody are using feature for configuration management, so the rules, the directives, that's a good idea. A good point for our tool. Dynamic groups to manage the infrastructure. Everything else is not very used. So why did they choose Rudder? People choose Rudder for compliance, or because they didn't want to learn a new language. Everything can be done in web interface. The agent is light. One was honest because the boss chose the soft. What do they like about Rudder? They like that it's easy, that we have a web interface where you can do everything. They like the community support. They like the Rudder team. It was free text. They choose what they answered. They like the reporting, the building techniques, the stability over time, that it doesn't break when it upgrades. They would like to change the price of the subscription because it's too expensive for small companies, they said. They would like a marketplace to exchange their techniques, make everything config as code, automated upgrade of Rudder, and more examples. They also would like some more broad features, so support for offline systems, exporting CSV, export by CSV for everything, make compliance more explorable, dashboard for guests, etc. So what we learned is the survey was not very interesting for users. They didn't feel it a lot. Probably it was too long. There was no reward. It was sent after Christmas, probably not the best time. They have the same use case as our customer, which is quite good. Rudder is liked for its ease of use and web interface. People love the support for the community, and the customer give us the same feedback. And they like that it's reliable. So we have the same feedback as for users. And which is good, what is good is they want compliance export. We start to have that in the next version of Rudder in March. They would like to explore compliance. We have that in 8, coming in September. Do infra as code, the same in 8.0 in September. And we have a lot of talks about Rudder during this session. If you want to learn more, you can come and attend at any of these talks. Thank you very much.
Brian, you have 5 minutes to talk about nothing. Niks.
Niks? Mag ik terug gaan zitten?
Yeah, okay, fine.
So, hi, I'm Brian. I'm a software engineer at Tweak, and I do teach a university college course. So I thought this would be fine. The only thing I didn't realize was that it's 10 times bigger than, yeah. So I'm a bit stressed, but that's fine. Who here has heard about Nix? Oh, wow. Okay, so I don't need to say anything. Just explain it to each other, please. No, so if you don't know what Nix is quite an overloaded term, in my opinion at least. You're going to hear it being called out as a package manager, as a language, as an operating system, as an entire package set, maybe even one of the best in the world at this moment. And you're going to see this logo everywhere when you Google for Nix. It's a snowflake composed of lambdas, which, if you know something about functional programming, is great because we love lambdas. And this is what I just talked about. It's the fact that, well, Nix is an overloaded term. You have the operating system, and the operating system is not the language, but it's still part of Nix. And language is not part of the package manager, but it's still part of Nix. Package manager is not part of the operating system, it's still part of Nix, but the Nix packages is missing. So what does the package manager side of it look like? Well, not so different actually than most others, except that it can do a few tricks that I'm not showing here, so you come to my other talks later. I don't have Terraform installed. I do an Nix command, I have Terraform installed. The language, it's being described as JSON with functions. At the top, we have JSON. At the bottom, we have Nix. The only difference is, well, the top one doesn't have functions. The bottom one on the second line where I said love Nix, that's a function. It's not just a plain data type. And then the operating system. Well, wouldn't it be great if the things that we learned from the language, from the packages that we built, how about we just build an entire operating system with it? And that's exactly what Nix OS does. So here you can see I just enabled HTTPD. And that's about it. So why do we Nix? Well, I can't answer that for everybody. I do know I can answer that for myself. So I'm a proud, I used to use Arch, by the way, user. I don't anymore, because a little bit about myself and background is I used to be an embedded software engineer. I used to do embedded development. I meant a lot of embedded Linux, a lot of drivers, a lot of custom kernel modules, a lot of kernel patches as well, and a lot of just bare metal real-time, hard real-time stuff. And this was me when I was still handsome. And you can see I used a lot of different tools. I tried out, I jumped between a lot of different tools. I just like playing with it. And the big problem is, well, since I was playing so much and trying so many things out, it would catch fire from time to time. And my problem with Arch, and this is not a hit at the Arch community, not at all, amazing people, it's just the fact that I didn't know how to recover from that. I made mistakes, it would blow up in my face, and things would break. Fast forward a few years, I started using Nix OS. And not much changed, right? Except for the operating system on my machine. Still used many tools, still tried a lot of things, still did custom kernel patches, and well, from time to time, things would still catch fire. Nothing changed in that department. Nix OS doesn't magically solve all your problems. It's not a be-all, end-all solution, definitely not, but it can do some pretty cool things. And one of those things is, well, the fact it knows what it used to be. So instead of browsing the Arch wiki for 3 days in a row and trying to figure out how I could solve this thing, and then eventually ending up on some obscure kernel mailing list, I just do Nix.OS rebuild rollback switch, and I am back to old operations, just the way it was before. I can tinker with my system again, and all that took was a simple reboot, and in grub I get a nice entry from the day before. I can go back and everything works, and I don't have to stop any of my work. So my workflow has tremendously improved. So if you're interested and you want to try this Nix thing out, well, there's a few ways to do it, and yes, the next slide is going to be horrible, and I know some of you will blame me for it. But that is the way that it's advertised on the website. So yes, we do pipe into bash. I am terribly sorry. We are working on a fix for that, but many fixes for it.
Well, Sandra's going to fix that.
Yes, exactly. So yes, I know, don't pipe into bash, but it's something that we do currently to install it. And then you can write your Nix code, run Nix shell, and you get this nice fancy Nix shell. By the way, something you might have noticed. This is the thing at the top, it's just in a .nix file. I can push that into Git, and all my colleagues that have Nix installed just run Nix shell and have the exact same environment as I do, or almost exactly the same. And if you need help, we have an amazing community of contributors. There's a Matrix channel, there's an unofficial Discord channel, there's a forum. Head over there, ask questions, we are more than happy to answer. And if you want more, I myself am giving another talk today as well about a gentle introduction where I get 10 times the time. And also, Ivan is going to give a talk tomorrow about how to generate Docker images with Nix. Thank you for listening.
Lander or Philip? Well, Lander is already standing up. I'm not sure Lander is going to talk about what he did this morning, but he's going to talk about Q.
All right, so I'm Lander. Hi. And the Ignite I'm giving is inspired by two things. One, wanting to try to play around with Q, and being a bit fed up with maintaining Terraform code. Because like, classical way to do it is like, you have a workload for every environment you have or whatever. Then you make some modules, and then you have to add variables and juggle around counts to make it conditional and stuff like that. And it's just a pain in the ass. But Terraform has HCL, but it also can accept JSON, because everything that you can do in HCL, you can represent in JSON. And the nice thing about that is that Q also generates JSON.
Just take it. Take it.
Okay. So what does that mean? Like, if we can somehow link Q and Terraform together, that means we can have all the nice features that Q has, and just use it to make Terraform code, pretty much. So you can add the constraints and like simplify the maintenance, because you can just define your application once, and then for the different environments, just change only what you actually need to change, only the difference. So what do we need? This is how the Terraform JSON sort of looks like. So you have a resource block, and then just add some resource types and give them a name. It's obviously a little simplified, but yeah, that's pretty much the gist of it. And then you define your providers and define the Terraform version and all that kind of stuff. But it's basically just a JSON representation of the HCL code. So let's get started. If you define something like this, some kind of macro where you can then define all the constraints and all the common stuff you want every AWS instance to have, and then you just loop over them and generate the queue for it. So once you've defined this for all the types of resources you want, then you can just instantiate all those, and all the other common stuff will be added to it. So actually, if you look at it, it's syntactically pretty similar to ACL, but yeah, just in a key flavor. So this is all pretty basic stuff. Yeah, and then we do the same for the provider block. Again, obviously simplified, because yeah, you need more than that to configure the provider. Waiting for the next slide. And then the same thing for the Terraform configuration. So what you can then do is have a different subfolder for every environment or every region or cluster or whatever you want, and just only change the actual configuration that differs between those. So, for example, we have a folder US East, and just put in that, and do the same for EU West, whatever. And it's only the actual difference that we need to define again, and all the rest will get merged into the final JSON blob. So how do we generate that JSON? Well, we can define a command in Q. It's pretty simple. It just takes all the resources and all the providers and stuff like that, dumps them into a JSON file, and writes that to disk. So this will apply the exact same instance set on every region, but of course you can do whatever you want because it's Q. And you can also like add the actual execution of Terraform into the Q command. But there's some quirks about the Terraform CLI that doesn't make that easy. And like, spoiler, you should probably just run it from CI job anyway. So yeah, you can also like turn it upside down and instead of defining the what's it called, the actual environments in the subfolders, you can also do that for instances, the other way around. But it's just whatever you can imagine, because everything you can do in Terraform can be represented in JSON, and everything you can do in JSON, well, everything you can do in JSON, you can do in Q. So, yeah, that's pretty much it. And if you want to learn more, you should probably just ask Marcel or go through the tutorials on the website. Thanks.
Is it web scale?
Is it web scale?
So, is it web scale? Who remembers that video? We are old, right? Maybe you don't really remember anymore, but this came out more than 12 years ago, so we are definitely old. For those who are not as old, this is the link to the original video, and it's basically somebody using MySQL and being very convinced that MySQL is the right choice, and this is unironic. And the other one is a MongoDB fan and always responds to everything with, but is it web scale? Which was the slogan that MongoDB had been using back there. And I was thinking back, like, where did this, is it web scale coming from? And it looks like it came back from when Twitter and Facebook were starting to become big and everybody thought they had to scale like Google. And back then, web scale was a thing. And since we seem to be going back in time, where Twitter is going closer to this again, I thought, why not try to bring back web scale as a term and look like how it's going? If this is even web scale or where we are going with that. So, what is web scale today? And I'm slightly cheating here, I'm using this slide twice. Obviously the main thing in web scale is that it scales, but people try to put all kinds of other terms into web scale. It's like all the things or attributes that you would want to have in your system, you back then at least said like this is what is web scale and what you want to have in there. So if it should be available and reliable and it should fail over transparently and it's performant and inexpensive, all of those are part of that web scale experience that people wanted to have. And MongoDB, always being better at marketing than engineering, picked up that slogan and then ran with is it web scale. And that worked pretty well for them for some degree until people got kind of annoyed with that is it web scale, and somebody made this website which is still up with, which is MongoDB web scale, and the answer is no. And they also say it's a stupid term. And I'm like, I'm not sure if web scale itself is a stupid term or if it just has been abused so much. But what can we make of this? And people were turning that into memes. And my interpretation, by the way, is that the person in the orange shirt is amused and just laughing at the irony of MongoDB being web scale and not the bliss of MongoDB. But that might depend on your point of view. But MongoDB, again, being better at marketing than anything else, actually turned this into a thing. Like only a few years ago, they turned this into a shirt, and you can see in the sleeve up there, this is an official MongoDB shirt. So you could get that from them, and they are still running with that to some degree. But you can still beat it. For example, DevNull, it's schemaless, it scales, it's highly available, it's web scaler. So maybe we should start using web scaler as a term. But on a more, well, unironic way of use, like, did anybody in the last year, let's say, use web scale unironically? Okay, I'm not disappointed. I kind of like this is what is expected, I guess, because it just like faded out of everybody's existence. But what is the new term that we're using for web scale instead today? What is everybody using nowadays for, what has replaced web scale as a term? DevOps. Yeah, my take is this one, that everybody does cloud native microservice architectures. Because for me, that as a term, it's even worse, but this is what we're all talking about. Who has used this in the last year? Yeah, that's way more. So this is really a thing, and you can also see it in the web trends, that microservice and cloud native, those are the terms that you have to use, so web scale is maybe out of the window. So I'm not sure this is an improvement, because for me, it's kind of like some of the similar gist. And the question is, should we return to web scale? Because as a term, I think it's actually kind of nicer. Anybody feel strongly about returning to web scale? No. Yeah, so I tried to look that up, and the first hit that I got yesterday on Twitter was this one, and then it was officially dead for me. Because we really cannot use web scale unironically anymore. This is what you get, it's dead. Also, there is a company, webscale.com is a thing, also unironically. So it's really, irony is dead. We can banish the term, never to be used again. And you know, there's only one way to say it, how to never use that term again. It's this way. Say web scale one more time. This is, I'm afraid, where we have ended up with that. But as a conversation starter, it's still great if anybody brings an architecture to you and you ask, but is it web scale? Thanks a lot. And I tried to take a picture with you so I can prove to my colleagues that I've been working today. Thanks a lot. Enjoy. Yep.
I think this is the last one for today. There's 2 that move to tomorrow, and that basically means that we're starting again at 2 o'clock, and now there's time for lunch.
Okay. Welcome everybody. I hope you had a good lunch. It's 2 p.m. We are ready for the next talk. Well, most of us are. I'm not. But here we go. So this is 60 days in a new startup. My 60 days in a new startup. My first 60 days as the first employee in a new startup. And they started December 1st, so 66 days ago. This is gonna be a pretty raw and fresh retelling of that story. If you'd rather hear a polished talk about like how digital doubles fix all your problems, you need to talk to a salesperson, not me, right? Like I'm an engineer. Over the last 25 years, I did Linux sysadmin stuff. I did app programming as a contractor at my own product company. That's a story for another day. I did a couple of years at Puppet as a programmer and tech lead for open source content, modules, cloud, developer experience, code infrastructure. That was like in the era between 250 and 500 employees. After that, I went for a year into a cloud-native startup for package hosting with 15 to 30 employees. And now, like 2 months ago, I'm with Overmind with like 4 folks. I want to start with like why do you do that? Like why do you go to a startup? What are the things that I looked at when I made the decision, and why does it work for me, and why I'm here today, right? The basic idea was something that resonated with me. I'll talk a little bit about my goals in a second, but the idea is provide deeper visibility in your system structure and help people that are managing infrastructure to understand what the heck is going on in your systems, right? And especially just coming off a year in a cloud-native SaaS provider, yeah, that would have been nice to have. So that was a great thing. Also, Dylan, the founder over here in the front, is somebody I know from a previous project, and he there has worked on things that made sense for customers, and both in the product sense and in the engineering sense, worked on them, and that provided a certain level of trust and confidence that this project is actually going somewhere. Also, and I realized I should have maybe talked to you about that before, but we have secured funding for for 2 years, and so like really, when I was thinking through it, there's very little risk in me for joining here. It's going to be 2 years of salary. I can do some engineering at the end. I'm going to be 2 years an engineer in a startup that did a lot of things, and if it goes wrong, it's his fault, right? It's always the business people's fault. But also, I'm in a phase in my life where I can afford the lock-in and the commercial risk, right? Like I do have some savings. If it goes all south, I'm not going to live on the street tomorrow. Why did I go into that? As I said, the idea for Overmind is build a product that helps people managing systems. And similarly, as an engineering leader, I want to make a difference for the team I'm working with. We all have experienced that manager that shouldn't be a manager. And while the bar is not high, right, I think this is the point that will make the longest difference long term. A friend of me always quotes, if you want to go fast, go alone. If you want to go far, go together. And I think these are words to live by. Also, another thing is, as I said, after 2 years an engineer in a startup, you get to pick and choose where you go next. I'm not going to mince words here. Like I want to be at a good product. I want to be at a good team. but I also want to make a career out of here. It's like a lot of people are dancing around those points as if they're dirty or something like that, but we're all here, I think, to achieve something, right? Like you don't travel across Europe to a conference to do nothing. Also, and that's one of the points where, and my troubles with this talk in general, like a lot of the things I'm going to be talking about, I haven't seen the outcomes yet, right? But this particular one is funny because it's also one of my dreams that I've always been having and where I have no idea whether I actually want it. But I want to become the CTO, the public face of the technical organization, who like both leads and demonstrates the values that I stand for and the values that Overmind provides as a product. And last but not least, I want to be able to retire off Overmind's exit, right? Like, as I said, startups are things that are there to get sold off, and that's a reality of the startup life. And I know people who are very happy just programming Java on the same line of business application for the same insurance for 20 years, and that's just not me. Having gotten that start out of the way, I want to just go through a fairly chronological through what happened in the last 2 months, and like a couple of details have been redacted to protect the innocent. But it's one of the advantages of a small team. Like there's most of what follows is my fault, or Dylan's fault for that matter. Mostly Dylan's fault, but don't tell him. So first week, right? You start up at a new startup, a new job, and I have no fucking idea what I'm doing, right? Like, don't get me wrong. As I said, I do have a lot of experience, but I don't know anything of like the code base. I have some previous relationship with Dylan, but I never worked with him on a team. Like, he's a different person. He just got a bunch of cash in the bank, and he needs to burn it, right? Like, there's a lot of unknowns. The thing that I realized is, like, everybody starts as an intern. On your first day, you don't know how the product works, you don't know how it's deployed, you don't know where the code is, you don't know what happens. You have some experiences that you can fall back, you have learned some things that will do you good. But on the first day, you start as an intern. The difference is how much and how fast you learn. The difference is what are the experiences you can link up to. And even as an intern, like the things that you already know, the things that you've seen at school work and be proposed. And so the first week for me was learning everything from scratch. Who's already here? Where's everything going? The strategy, the tactics. Read all the docs. Read all the design notes. Read the slides and speaker notes of the pitch presentations to get a really a better understanding of what it is actually that we want to achieve, right? And then on the technical side, why are we using Golang? How does it work? What is the ecosystem around that? Where's the code? What is there as on scripting, etc., etc. As part of that, in November, so in the week I started, actually, I moved from the UK to Austria, which I can't recommend as part of starting in a new startup, really, but it is what it happened. So it's very much on my mind that you also need a place to work, right? In our time, a lot of that is like remote office and home office. Even when you start at a regular company, they provide you with a desk and a workstation, etc., etc. One of the things I just want to say for folks, because it both surprised me and not, is like your setup at home should be on the order of an investment of like 6 to 8K, maybe a month's salary or two. And saying that also, most of that should be paid by one of the companies you've been working for. I can't say it any other way. Companies expect us to provide 8 hours of our day, a third of our life. They better provide for the infrastructure to actually make that efficient. And also, compare it to your actual salary and that you're gonna be working for that company for 2, 3, 5 years. Like a month's salary at the start is not gonna make a huge difference in the budget. Diving deeper into like the first week, building up a understanding of the code base, I learn through doing, I learn through experimentation, and I think that's true for a lot of folks. No. I think that's true for a lot of folks in IT and technology. There's just such a rich tradition of experimentation and the ability, especially today more so than ever, now that we don't need physical hardware anymore, to just try out shit and see what sticks, right? So just the high points for me in the first week, get up here already on the first day to merge on just doing a couple of lines of copy pasta in our acquisition pipeline to understand like how does it fit together, what are the APIs, how does it compile, what tools do I need locally, how is it tested, what happens if I screw up, etc. All these things that like give me a more visceral understanding of what needs to be done. Then day 3, I've noted here a minor fix in the front end, nothing big. I'm in the lucky position that I don't need to prove myself, but also I need to understand as an engineer in a team of 3 or 4, I need to be able to touch every piece of the puzzle. And like, you don't want me to touch the front end, but sometimes it's just necessary. The thing, and another note that I have here is like the IEEE. Sorry. What about you all? Shut up. The IEEE mantra of working code and rough consensus, right? Especially at the start when you have you have no experience to go on in this particular project and in this particular context. Just having something that works is so much more valuable because doing the work like has a lot of emphasis on those things. For the rest of the first month, things started to get a little bit more strategic, and like one of the questions is like what are the scaling targets and the scaling bottlenecks? With 4 people, I can't implement everything myself. As a team, we can't implement everything that we want tomorrow, just as a matter of life. How does planning and communication work with the new people that start with me? We need one goal. We need a shared understanding of like the rough path, the constant communication of the process. And 3 engineers in a trench coat don't need Jira to organize ourselves, right? Like, we need a place where we can put our notes. We need to chat about like what are we doing today, and it works, right? Like we're all grown-up folks. We do have some of the experiences from other projects, and yeah, that's how it runs. One example I have from a different project I've worked in another place. I just really like to trot it out because it's so poignant to like the trade-offs that happen in these early stages of projects. Is a pre-seed startup prototype building, and the founder's goal was to have like 100 customers with like a couple of 100 business objects each, maybe in total within like the first year. And it turns out that if you only have 100 business objects for 100 customers, you don't need pagination in your API, and you don't need to spend time on implementing pagination in your API, because you can just return all the data in one API request. It's going to be fine, right? And that's a week of work that you don't have to do. It was a very interesting conversation with that founder, but he did understand that actually he doesn't need to pay for that at the moment. Also, I don't need API stability and I don't need high availability because we have no external consumers of our APIs and we don't have customers on our systems yet, right? Today, in the first month, I need to optimize for different things. On the other hand, I also can't paint myself into a corner. I need to understand where, like a month from now, half a year from now, I want to be. Just because I don't need Jira today to organize my projects, I do need to understand the interdependencies of what people are working on and what are the components and what do I need to chuck out before we can let people run on the system. I don't need the pagination API right now, but I do need to know that my framework supports some kind of pagination so that once we have the 101st customer and that doesn't work anymore, we can invest in building that and don't have to rewrite everything. If I don't need API stability now, I need to have a defined API and a release process because I need to stay in control of the entire system and I need to understand how the components are talking to each other. And I don't need high availability now, but I need to know where my single points of failure are so that when we have customers and when we have people pay for it, knock on wood, I know where to invest to make the system better and to do rollouts that don't disturb traffic, etc., etc. And as the time progresses, the problems just keep coming. I mean, problems. It's just like that's the work that needs to happen. Understanding how do the components get deployed and how are they connected. Dylan had a great Terraform module that did all the deployment. Except that he only ran it from his local machine and destroyed the environment afterward. He was done with it because like that's what he was working on, right? That's great for developing on the system and exactly what he needed at the time. But if we want to get to a point where we can have early access and preview users on it, we need something else, right? And so a lot of that first month was concerned with scaling from that single-person development environment to something that can run forever and have people on it and be something that multiple people can work on at the same time. I spent a significant chunk of week 3 reading up on AWS multi-account practices to avoid getting stuck like I saw at other projects with prod and dog food environments in the same AWS account, which was all kinds of fun, except for when you actually had to touch it, right? I did configure SSO for getting the G Suite users into AWS, which also has some weird things because AWS SSO wants you to re-authenticate every hour by default, and you need to figure out where in the control tower interface you can click around and fix that. Getting remote storage for Terraform state online made it possible to like have multiple people run Terraform, and then shortly thereafter actually configure GitHub Actions. Excuse me. Configure GitHub Actions to be able to run Terraform plan and Terraform apply from a action so that you can just click and say, I want that branch in that environment and have it run, which actually was surprisingly easy to configure with GitHub OIDC support something, and you need to configure the trust so that AWS understands that GitHub is something that is allowed to deploy from that repository, and it's great, right? Will it be how we deploy Overmind in a year or two from now? Yeah, probably not. I don't know. We'll see. But for now, it's absolutely fine. It works great. I don't have to have Terraform on my laptop anymore. I don't have to have the Terraform state on my laptop. Anybody in the team can click on the button and make it happen. And it's 3 lines of documentation with a link to the action that says click there and it will happen, right? And it notifies our chat channel, and we get like the deployment has started, the deployment has succeeded, the deployment has not succeeded, and you can go through to the logs, and it's pretty great. The other big issue was, or the other big task I should say was like getting all the secrets and passwords removed from the code. Again, completely sensible to do when you're just working on your own development environment. Something that needs to change in a true production environment. And again, a lot of reading of docs and understanding that, yeah, the things that I'm building on do have a next day story about the next thing that I'm probably going to need, but that I can't spend the time on currently because I don't need it and I have other things to do to get it doing, right? Yeah. Until like 2 hours ago, I didn't know what I was talking about. So slides. Yeah, I should say that. Before I forget and before I get kicked off the stage. I do have extensive notes to what I'm talking about. I don't have any slides because like I'm an engineer, not a salesperson. And if you want any of the notes or want to follow up on any of the details that I'm talking about of the things that I've been working on, please do find me on LinkedIn. I'm always happy to answer messages or requests or hop on a call to just hang out and chat with anyone. Also, I realized that I'm probably on time soon. Yeah. And I'm only barely through the first month. Yeah, I'll try to make that a little bit faster. One of the things that really helped in like focusing on the important things is always asking, what if we had to run a customer demo tomorrow, right? Like nothing clears the mind as good as imagining what a customer would experience if they click the button today or tomorrow, right? And sure, if you really had to have an investor tomorrow that wanted to see the prototype, there would be some smoke and mirrors, there would be some compromises in what we actually can show. But there's always that one thing that we could cram in today that would make it better, easier, faster, less risky to show off, right? And while I'm working on these backend things, Dylan and our front-end guy are working on the UI and making sure that the data visualization actually works. I did depend about, that's not a story I want to get into, but like having confidence that all your dependencies are up to date and consistent across the repositories, also very nice. As soon as we talk about getting it into a stable runtime system, of course, understanding what's happening there is important. And again, on a development system, just looking into your Docker logs is fine. In AWS, in EKS out there, that doesn't work anymore. So I rolled out Honeycomb Kube agent, just collect all the logs, stuff them in Honeycomb. Yeah, it could be better, could be worse. We now have all the logs there, and I've started to roll out OpenTelemetry to get more detailed information on what's happening. Also, a great forcing function then deploying a library like that to understand how the code is connected, because you really need to connect all your trace context so that OpenTelemetry can show you what you're doing, which forces you to understand in the real world how your code is connected and how your code call hierarchy works, which I found very helpful starting out in like dragging myself through everything that's happening in our data acquisition pipeline and in the processing to understand how it's connected. And then as a maybe biased, but the visualization of how all of that is connected is both helpful for me personally in understanding the code, but also a good indicator that as a company or product idea, we're on the right way, because visualizing the complex structures just makes it so much easier, right? Also, just because we're at Configuration Management Camp, setting up DNS for the different environments, I don't have the time to go into the details, but it's been a journey. And then Christmas and New Year rolled around, and that was a little breather in that roller coaster ride. The final thing, the second month is more of the same but different, like writing a new feature here, adding an API there. The last thing I want to say as I'm running out of time here is VS Dev containers are freaking amazing. You don't have to have your development tools installed on your machine anymore. They just get baked into the Docker container that's running in your IDE. And it's such a contrast to, if you look at the official Go documentation, for example, they are like, yeah, our install process is so easy. Here's a tarball, just proc it into your user local. And that's all great. That's really simple and a lot better than a lot of other installers that I've seen for development environments. Don't get me wrong. But it doesn't help with managing multiple versions. It doesn't help with getting the same version to everyone in the team. It doesn't help with getting that version into the production system. That doesn't help me be able to work on the front end because, surprise, the front end does not use Golang. I know it's difficult to understand for Google engineers, but there are other languages than Go out there. And having a dev container that just gives you the project that you're working on as part of your IDE is just really great. If you haven't seen it, you should really try it out. Yeah, more open telemetry, more refining the VS Code setup. There is a Terraform provider for our authentication service, so I don't need to copy-paste secrets anymore between web interfaces. Life is great, right? Yeah, life is great. I mean, there's more to do, there's always more to fix. But for the next 2 years, so that's going to be my life, and I'm looking forward to it. Thank you all for listening. If you are, as I said, if you have any questions to specifics of what I talked about, hit me up on LinkedIn. If you want to see what we're working on, early access is almost at the door. We already have a wait list. Go to overmind.tech and check it out if you want to understand your infrastructure better. Thanks for listening, and see you around. Enjoy the rest of this show. Merci.
DigitalOcean? Yay, great. Do you know that we have a managed Kubernetes service offering? Well, now you know. As part of my journey as a developer advocate, I'm primarily focused on developer experience in Kubernetes. And right now, I maintain 2 open source projects. One is the Kubernetes Bootstrapper, that's what we're going to see today. And then Mastodon on Kubernetes, that's like a new initiative of running Mastodon on production-grade Kubernetes system. But let's get started, right? And you can find me on socials at Diabe, and the QR code was just there. Oops, brilliant. Let's see. Well, if that doesn't work, then I'll just connect my... Awesome. What could go wrong? Brilliant. Okay, cool. All right, yes. There you go. You can check out the project. So what is production grade, right? It's a loaded term, and for different people, it's production grade is completely different. But from a startup and a SMB point of view, we know the stats. Many startups, like more than 90% of our customers and users, do not have any fancy pipelines going on, and most of them still run stuff on VMs. So for them, getting production grade might just be setting up this on Kubernetes. I really like this infographic that Power Native made, where you need a couple of these facets on your Kubernetes cluster to call it production grade. That includes infrastructure, security, authentication, observability, and continuous deployment, and you have your entire development workflow. But with the plethora of all these open source applications that are available, it makes it really difficult to pick and choose the tech stack for your startup or SMB. And imagine if you do not have the DevOps expertise within many startups. Well, most of them do not have that. There's this notion that every startup is a tech startup and they have all these tech-savvy engineers, but most of the startups are just getting out there, making sure that the product is just available to folks. So how do they get into this production readiness? And that's the whole initiative behind putting together this open source project called the Bootstrapper. It's nothing fancy. It's just combining Terraform and Argo CD and using Argo CD's app of app pattern, which we will see now, to set up a framework which is flexible and then just integrates popular battle-tested open source applications. To speed up the process, right, I just have a bare-bone Kubernetes on DigitalOcean running, and which has Argo installed. But this is going to be like this. So it's a 3-step process. We have our infrastructure that is Kubernetes with Argo installed, and then we're going to deploy the app of apps pattern on using Argo, and then I'm going to set up the production grade observability stack using Robusta. Anyone heard of Robusta? All right, we'll take a look at it. So yeah, let's see what's out here. It's a pretty straightforward Terraform module. You just have a DigitalOcean Kubernetes cluster in this case, but this is vendor agnostic. You can run it on any Kubernetes cluster you want, and we use Helm provider to install Argo, and that's pretty much it. So you have this infrastructure set up, right? And then let's open the terminal. So make sure. All right. So you have Argo installed, and that's pretty much it. Right. So step 1 is done. I did that to speed up the process. And we go into the bootstrapper. And I'll just explain what it is on a high level. The bootstrap app of app pattern is nothing but you install a parent application, and then you configure the parent app to say, hey, these are my child apps, go ahead and install these apps. You can point Argo, you can configure Argo in such a way that it points to a particular repository or a particular Helm chart. You can override it with different Helm values. In this case, we are going to integrate, like install cert manager, traffic, ingress controller. We have Trivy, runtime security operator. So I'm just choosing one open source app from one of those facets you saw earlier, and I've configured it into a Helm configuration, which I'll show you right now, and then we're just going to apply this. We also have a values file here, which you can override. And this is done in a true GitOps fashion, right? Argo CD is basically looking at this Git repository and the remote cluster and just saying, hey, as this repository is going to be the source of truth, so any changes that you make here, you need to push those changes to your repository and make sure you configure Argo such a way. While I'm talking about this, let's just go ahead and also apply, because it might take time and I'm running out of time. So I'm basically just going to apply this, and we'll see what happens. Okay. As and when it's installing, let's, okay. So something's happening, right? So it is installing. So we'll go ahead and log into Argo to see what's going on there. So everybody likes visuals. I'll just copy paste these. I'm just basically exposing the Argo server here. You can also wrap it around a domain and then access it. Argo comes pre-configured with default credentials. You can change it. You can add single sign-on and whatnot. So this is going to be our password. It's one-time generated. I'll change it anyway. All right, you see, there is a Bootstrap parent app which goes ahead and installs the Bootstrap resources, which is nothing but the ingress resources, which I'll show you now. And you have the cert manager installed, your metric server, your traffic load balancer, and your Trivy operator. The list is endless. Tomorrow, if you want your app, which isn't residing in a separate repository, and you just want to, so you can take the Bootstrapper, write a single line of YAML file pointing it to that particular repository, and just apply it, and it's going to pull that particular application, and you can have all your ingress resources configured here, and you can become production ready, like day 2 operations ready. Of course, there are so many aspects of production grade systems, but this is like a very good starting point that you can take and leverage and customize it as you deem fit. So what is happening under the hood, right? We have this Bootstrap YAML. That's pretty much basically saying, this is the repository, the path is the Bootstrap path. In this case, I have the feed demo. It's going to install in this particular namespace. And then if you go into this directory, we've got the list of templates. So here, I have another application called the bots application, which just displays pictures of bots, pretty much. And I'm just saying, hey, if I had the bots app enabled in the YAML file, apply this manifest, Argo, and then I'm just pointing it to that particular repository, head revision, and if I need to override the Helm values with a particular storage class or whatever, in this case, storage class, it just goes ahead and installs it. Similarly, you can also have the Bootstrap resources file, which here you can have your ingress. In this case, there's a ingress for the bots app, which you've not enabled for this demo, but you can write your ingresses here, and then it's going to get configured. Oops, what's happening? Let me go back. Okay, there's some network. Oh, all right, brilliant. Okay. Do I have time? All right. So we are done with step 2, right? So if you see, we've installed Cert Manager, and Let's Encrypt as your certificate issue provider, and we've used Terraform for the infrastructure. All that's remaining now is setting up the observability stack, and we're going to use Robusta for it. Robusta is a Kubernetes monitoring platform which comes pre-baked with Prometheus stack, the kubeprom stack, and also with Grafana dashboards, and it has multi-cluster observability. It's an open source tool. You can check it out. So let's go ahead and install Robusta. I'm not going to install this, but all right. So you need to have a configurations file for Robusta. So let's head into our observability. Oops. Where am I? Bootstrapper. Yeah, I'll remove this, and I'll just do Robusta gen config. So you can have Slack integrations. So imagine something is happening in your remote cluster, you want to be notified, right? Not just notified, but also provide with some solutions, and then immediately click that, and then it'll take you to whichever cluster, whichever pod is failing. So let's have our Slack integration here. Slack, enter Slack. What? Brilliant. All right, this is cool. Let's see. At least I've done it correctly, right? If it says no, okay, awesome. So I do have a Slack channel here, and I have like Robusta configured this for this particular channel. I knew something like this would happen, so I had something configured. Come on. Come on. Let's see. Hopefully this works. God. Still got time, we'll make it. All right. I haven't received it. Well, I didn't receive the email yet, but what I can show you is, I'll go back. And then with just a Helm chart installed here, right, with the generated values, what this basically is doing is you're telling Robusta, hey, this is a particular Slack channel that I want all my notifications in. This is my account. I'm going to just sign in with this account. And I have another example that is already configured, which I'm going to show you now. You just apply this manifest, and then it's going to install the kubeprom stack, all the configurations around it, and you have your observability stack on one place. this is their, right now we have the Mastodon project, right? So we are applied the Bootstrapper project to the Mastodon project as well. So here you can see that you have all the services running in the timeline. Right now there's no data, but then you get a whole platform experience of monitoring and observability using Robusta. So with these 3 steps in place, you are already there. And then with just some fine tuning and then tweaking, you are good to go. Like, it literally took us, 10 minutes? But then, of course, within half a day or something with fine tuning, you'll be able to set up a production grade Kubernetes cluster. If you like this, just share the project, check it out. And we are looking for contributors and volunteers for both the Bootstrapper project and also for the Mastodon on the Kubernetes project. So feel free to check it out, and if there's any questions, I'm happy to answer. Thank you.
Okay. Hi, everybody. I'm here to speak about unknown unknowns and how to know them. I'm Dylan Ratcliffe, the founder and CEO of Overmind. I was also previously a professional services engineer at Puppet for 6 years. But before I get into anything, first I want to start with the story of how a printer made me quit my job. So, while I was a consultant at Puppet, I was working for a week at a company that will remain nameless, but the gig was going really well and I wanted a big win before we left. Now, at the time, every single user had the same root password. Sorry, not every user, every server had the same root password. This was a sort of secret arcane knowledge that got passed down to you on your first day in the operations team, and you were told never to write this password down and don't tell anyone because it hasn't changed in 10 years and it's not going to change for another 10 years. And it wasn't great. So we were planning to deploy TripleSD. That would mean that users would log in with their actual username and password rather than this shared root password that everybody knew. And it would give us nice stuff like a user would lose access when they leave the company and good things like that. So the plan was to deploy this to all of production on a Friday afternoon. Yeah. Now, I know that's a bad idea. And I knew that it was a bad idea at the time. But it was the last day of the project and we wanted to get a win. Plus, we were legitimately confident that it was going to work. We had done all of the testing that we could possibly do. We had gone and got all of the approvals that we needed to get. So it was fine, sort of. So we pressed the button, we deployed the change, and we watched the results come in, and it was coming back green, green, green. We tested, and we could log into the servers using this old root password still, but we could also log in using our actual username and password. And we could disable that old root password later, but nobody was locked out, which was important. And at this point, all we really had to do was wait. The results were still coming in, and we just had to sit there and watch. And we're about T-minus 90 minutes from when we were planning to go to the pub. And at T-minus 45 minutes, the phone rang. And the call said, hey, nobody in the department can save PDFs anymore. The whole department is at a standstill because we can't save PDFs. And I thought, what? How could we have broken the ability to save PDFs? We didn't touch any laptops. We didn't even touch any Windows computers at all. All we did was enable TripleSD on the back-end Linux fleet, which really should have had nothing to do with it. And so I asked, what do you mean? Tell me what you do. And they said, well, I go File, Print, PDF, Printer, Print, and it's not there. And I said, don't you mean File, Print, Save as PDF, Save? And they said, no, File, Print, PDF, Printer, Print. And so it turns out that at this company, if you go File, Print, you get a list of printers, which are all physical printers in the office, and then there's a printer called PDF Printer, and we've broken that, whatever that is. So now we had to work out what it was, and how we'd managed to break it. So the first thing was we'll ask around, and we asked around, and nobody had any idea what this thing was. But the team had a wiki, and in the wiki they had a whole bunch of information about everything they were responsible for and all their processes and how to upgrade it and all that sort of stuff. So we checked the wiki, and there's nothing in there. But they had a CMDB, and they've got all of the information for all their servers in their CMDB. So we checked the CMDB, and there's nothing in there. And so at this point, we're sort of running out of options. And so we decided that we were going to log into this printer and see if it would let us in. And so we did. We SSH to its IP address, and it gave us a login prompt. And so we typed root, and then that root password that everybody knows, and it let us in. And so what followed was a particularly complicated session of infrastructure paleontology, where we were trying to work out how the bones of this thing fit together when it was alive. And much like regular paleontology, it's much more tedious and much less interesting than Indiana Jones makes it look. But eventually, we worked it out. It turns out that about 10 years ago, somebody put a physical server in the data center, and this server's job is to pretend to be a printer, and when somebody prints to it, it saves to a PDF, and then it runs a script which picks up that PDF and moves it to a mount point, and that mount point is a network share which is also available on the laptops, which is mounted to people's home directories on their Windows laptops, which means to the user, They go file, print, PDF printer, print, and a PDF appears on their laptop. But what's actually happening is it's doing this horrible dance all the way around the network and back again. And we'd broken that. And so we had to work out how to fix it. I won't go into that, but it turns out the fix was to change thousands of permissions on the network share, which is obviously a fairly terrifying fix to run. It was a roll forward rather than a roll back. And so we wanted to work out whether this fix would make everything worse. But given that we only learned about this printer an hour ago, there was essentially no chance we could have worked out whether anything else depends on this process. And by this point, everybody else had gone home, so we weren't going to make it any worse, so we just decided to do it. And it worked, and everything was fine. We didn't break anything else. You could save PDFs again, and everything was okay. Not before the entire department, which hadn't been able to get its work done, had already gone home, not having got done any of the work they needed to get done before the weekend. So it wasn't brilliant, but we managed to get to the pub about an hour and a half later than we were supposed to. So when we got to the pub, we sat down and thought about, could this have been avoided, or if not avoided, at least could we have done a bit better job of picking up on it and fixing it? And we decided that certainly we would have never thought to test for this beforehand, because this whole situation is so stupid that surely nobody would ever do something like that. If future Dylan came from the future and said to me, hey Dylan, before you do this production deployment, you should check to see if there's any servers pretending to be printers that receive print jobs and then save it to a PDF and move it onto a thing and run a script and it goes onto a network share and appears on people's laptops, I would have said, no, I'm not checking for that because it's so dumb. And if I check for that, then I have to check for every other possible thing under the sun. I'll never get any work done. So we wouldn't have not done this, but we could have probably done a better job of working out that we'd broken it and fixing it. This is a perfect example of an unknown unknown. It's something that we didn't know that we didn't know. It's so esoteric that it's probably never going to happen to anyone else ever again, I certainly hope. But it's part of a class of esoteric problems that happens actually quite a lot. And each one of those problems is probably never going to happen to anyone ever again, but there's always a problem like this. And I realize that in general, our industry is not particularly good at dealing with these sorts of problems. We don't have great tools for this sort of thing, and I thought that I had a way to fix it. And so I quit my job and I started Overmind. Before we talk anything about the solution, though, we need to get some more background on the problem. So I'm going to speak a little bit about what mental models are. I'm going to go over the Stellar report and what it tells us about the relationship between mental models and outages. Going to talk about the enduring legacy of unknown unknowns and how it can slow companies down to a crawl, and then what we can do about it. So a mental model is what allows us to predict what the outputs of a system will be for a given set of inputs. For example, I have a mental model of how driving a car works. I know that if I press the accelerator, the car will speed up, and if I press the brake, the car will slow down. Now, I didn't build this mental model by taking a car apart and looking at all of the individual pieces and working out how they were going to interact and then making a prediction. I created that mental model through experience, through driving a car. And this is how our mental models of our applications and our systems are built as well, from experience in operating them, not from first principles, at least usually. And just like no amount of driving a car makes you a mechanic, these mental models that are built from experience in operating systems don't prepare us for when things go wrong. So Wood's theorem states that as the complexity of a system increases, the accuracy of any single agent's own model of that system decreases rapidly. Woods himself conducted a workshop, and the report is called the Stellar Report. I thoroughly recommend giving it a read. If you just Google Stellar Report, you'll find it. But what they did was they looked into a number of large outages and the role that mental models played. And they found these 5 things that were common across every single outage. In every single case, each anomaly arose from unanticipated, unappreciated interactions between system components. There was no root cause. Anomalies arose from multiple latent factors which combined to cause a problem. The vulnerabilities themselves were present for weeks or months before they played a part in the evolution of the anomaly. They were activated by specific events, conditions, and situations, and those activators were minor events, near nominal operating conditions, or only slightly off nominal situations. And in all of these cases, it caused what Woods calls fundamental surprise, which is in where the situation that you're presented with refutes your most basic beliefs about how the system works, and it forces you to rebuild your mental model to take these things into account, i.e. it was caused by unknown unknowns. I'm sure a lot of us have been in that situation where you've looked at how a system is behaving and thought, that's not possible, or you've changed something and something's broken over here and you've thought, that's not possible, those things aren't related. Like, it's not possible to break the ability to save PDFs by implementing SSD. Turns out it is. It refuted my most basic assumptions about how the system worked, and I had to start from scratch. And I don't think this is a coincidence that these outages tend to do this, that they tend to be caused by unknown unknowns. I think that outages will always happen at the edge of your mental model with the things that you don't know that you don't know. Because if you knew about them, you wouldn't have got yourself into that situation in the first place. Even if you only know that you don't know something about how a system will behave, you can still prepare for it. That is a known unknown. If I know that I don't know how my application will behave with this new version of a database, I can prepare. I can do testing, I can do research, and I can move it into the known knowns section. So, doesn't this mean, sort of by definition, that it can't be solved because these are things that we don't know that we don't know? And if we can even think of them, then they're not unknown unknowns, they're known unknowns, and we can prepare for them. And it's actually worse than that. So as we improve our mental models of our systems, we end up understanding and preventing all of the simple ways that it can break, which leaves the complex ways. And so by improving our understanding of our systems, we're actually making outages more complex. To be fair to us, we are probably making them less common, but they are becoming more complex. Servers are not running out of disk anymore, they're running out of entropy, which is much more difficult to debug and much more of a pain. And quite possibly something that you didn't know that a server could run out of entropy. I know I didn't know that until it first happened to me. And so this isn't even the worst part. Management have not got wind of this yet. And when they do this. So we know that outages are caused by unknown unknowns. But think about how it must look to management. We followed all the processes and something still went wrong. So how do we fix that? More processes. This leads to a process that basically amounts to getting so many fingerprints on the gun that when it does finally go off, you can't pin it on anyone. It's called risk management theater, and this is how it works. Firstly, a company experiences an outage and then adds more process to try and avoid that outage in the future. That increases the lead time for changes. Now, compared to high-performing companies, low-performing companies that participate heavily in risk management theater have a 440 times longer lead time. That leads to a lower deployment frequency. Lower deployment frequency means that changes have to be 46 times bigger if they are to keep up with their high-performing counterparts. Now, spoiler, they don't keep up with their high-performing counterparts, but the changes are still bigger nonetheless. Larger changes and less practice in doing them means that they're 5 times more likely to fail, and all of the above means that when things do go wrong, they go wrong in a big way, and they take 96 times longer to recover from. And this is the real demon here. It's this feedback cycle that causes companies to grind to a halt. If you imagine I was to go back to that company that I spoke about with the printer thing and do a production deployment, there would be a step in the process where before you touch production, you print a test page on all of the printers, and then you do your production deployment, then you print another test page on all the printers and go and collect them and make sure they all still work. And these are the sort of organizational barnacles that grow and grow and grow. And because this cycle feeds back on itself, it's very easy to get into sort of a tailspin with this and eventually have so much process that you can't do anything. This is the thing that I dislike most. This is the thing that I disliked about being a consultant, is seeing people not be able to achieve what they should be able to, seeing tools not be used in the way they should because companies were too afraid to change stuff because of this. They'd had an outage, implemented more process, et cetera, which had caused a bigger outage, which had caused more process, and the cycle repeats. Has anyone worked somewhere that has been affected by this? Show of hands. Currently. Yeah, I thought so. For those of you that didn't put your hands up, I envy you. Hopefully you never have to deal with it, but you probably will. I'm sorry. And when you do, feel free to show them this slide. The numbers from this slide are from the Puppet State of DevOps report in 2017 because it focused on risk management theater specifically. So, how can we fix it? We've got good tools for using our mental models when smaller problems occur. If we look at observability tools, for example, they let us see our outputs in detail so that we can apply our mental model and infer what must be the internal state of the system for it to produce those outputs. But it doesn't really help us to build a mental model. The Stellar report found that in all instances that they studied, despite companies having good observability tools and other abstractions, the building mental models work was done using exclusively low-level primal tools, namely the command line. And what are we doing when we're using the command line? Normally, we're not looking at outputs because we already have the outputs in our observability tool. We're looking at the inputs, at the configuration. A potentially dubious but nonetheless sort of right-feeling statistic, it's from Gartner, but I don't know how rigorously researched it was, is that 80% of all outages are caused by configuration. And also configuration is where all of the how the application is supposed to work information lives. And that's what helps us to rebuild our mental models, and that's why we go there when things go wrong. Configuration contains things like, what database server is this supposed to point to? What security group is this thing in, and what are its rules? When was the last time it was changed? Who changed it? What was the previous value? If we had tools that monitored our inputs, as well as observability tools that monitored our outputs, we'd be able to do things like immediately look at whether a setting has changed or not. We could find out every setting that has changed in the last hour and work out whether any of them could have caused the weird behavior that we're seeing. We could build mental models on the fly before making a change. If we had to change a security group, we could discover which components use that security group and then which applications those components are a part of, and work out a reasonable blast radius before we actually go ahead and do anything. And so I'm sure that some of you are thinking at this point, I've got good documentation, I've got config management, can't you just read the code if you want to understand the system? And these things can sort of help mitigate the problem, but they're not really solutions. So documentation, for example, is basically the best way that we have of taking our mental model and putting it down on paper so that somebody else can sort of import that mental model into their brain when they need to. However, docs have problems. We know that our docs have problems. Would anyone like to bet that their docs are completely accurate right now? I didn't think so. There's also config management, as I'm sure you all know, which can get you some of the way. If you've got really good coverage of your config management, you can sort of look at the code and work out what the inputs are, but it does have limitations. For example, for the Puppet people in the room, what does this Puppet code tell us about the permissions of our Nginx config file? Anyone?
It doesn't tell you anything because it's hidden behind a separate module somewhere.
It doesn't.
Possibly.
Well, in this case it isn't, but you're correct in saying it doesn't tell you anything. We're not telling Puppet to manage the permissions on our config files, so it doesn't care. But changing the permissions on our Nginx config file could absolutely break Nginx. If we made the permissions such that Nginx couldn't read its own config file, it wouldn't work. Also, Puppet's enforcing every 30 minutes, so you've got, hopefully, so you've got sort of some hope that what is in the code is probably what is on the system, assuming the agent is still running. But if you're using something that doesn't run regularly, if you run it using Ansible and you only run it when you need it, it might be 3 weeks since you last ran Ansible against that thing, so there's a good chance it might have moved. So even though it's in the code, it's not necessarily going to represent the real state of the system. Also, you really don't want to be spending your time tracing down where a variable came from and trying to work out what the value of this variable should be in this data center, in this application, when the whole system is down. You just want to see, show me what the config is right now. The common thing, though, that means that these aren't the solution is that they are an abstraction. And when we're building systems, this is a good thing. Config management is good because it allows us to abstract away infrastructure in the same way that developers can abstract away code. It allows us to sort of compartmentalize our mental models into easier to digest bits. For example, I know I can ask Terraform to create a load balancer and it'll give me a load balancer. Settings go in, load balancer comes out. I don't need to know exactly how it works. And documentation follows this pattern as well. We document the settings that go in and we document the load balancer that will come out and maybe some of the way that it works under the hood, but probably not everything, and certainly not every instance in which it's used. But we have to do this to build systems. We have to put things behind abstractions and say, this generates certificates. I don't care how, I just know that it will give me a certificate if I ask. But when we have to fix systems, we know that the problems tend to occur outside of our mental models, which means they're going to occur in the gaps where the abstractions that we've created meet, because those are the bits that we don't understand well. Those are the bits that are outside our mental models. So we can basically guarantee that that's where the outages are going to occur. As I said, the Stellar report found that even though the companies that were studied had lots of abstractions that they used to interact with their systems on a day-to-day basis, they went straight for primal tools and raw data when things went wrong. And so documentation and config management can help to mitigate these problems, but they're not the solution. When things break, you're going to want the raw data. So what is the solution? This is what I've been trying to work out for the past 12 months. There's a few technologies that you could use today that get you a reasonable amount of the way. The first one is Cloud Query. Has anyone heard of Cloud Query? Quick show of hands. Okay, so it allows you to dump the config of your cloud into a database. Initially Postgres, now it supports a whole bunch of other stuff or files or whatever. And then you can query your cloud or clouds, whatever it is, using SQL. So it's a hell of a lot easier than learning how to do all of the API requests, especially if you already have tools for querying databases. And so if you were to use Cloud Query to dump the state of everything in your AWS into a Postgres database every hour, you would suddenly have a pretty good record of how is everything configured and how has it changed over time. You'd be able to check quite easily whether a setting has changed, what settings have changed, that sort of thing. If you're using Kubernetes, it's probably even easier. You could use kubectl to just dump all of the YAML out of a cluster and stick it in a Git repository every hour and do a commit. This might sound a bit dumb because it's so simple. That would be like 2 or 3 commands to the kubectl thing. But it would solve some real problems. For example, do you know how to get a list of all the places a security group is used in AWS? This is a bit of a trick question because there are entire blog posts dedicated to the topic of how to find where a security group is used. One little trick is you can try to delete the security group in the GUI and it'll tell you. It'll say, no, you can't delete it. Probably it'll say that, otherwise it will delete it. And that will give you an idea of where it's used. I'm not certain whether that actually tells you everything, but it's a start. But if you had everything dumped to text files, it'd be I think we all know how we would search for where that security group is used. We'd just grep, and in 2 or 3 milliseconds, we'd have the answer of how many places is this security group used, everywhere where S-3AB, whatever, appears. Now, it's not everything, but it's a hell of a lot faster than querying the 20 APIs that you have to get that information out of AWS. It's maybe not the most beautiful thing ever, but it's really, really easy. And if it means that you don't miss something when you're updating a security group and it saves you an outage, then that's excellent. And this stuff is really very easy to do. If you're using VMs and you're trying to get config off of machines, it's a little bit harder because you don't hit an API. But if you've got Puppet, Chef, or Ansible, or anything else on the machine that can give you the machine's state in some sort of reasonable manner, you can use that to gather everything about a server, say before and after you run a deployment, and then compare those changes afterwards to make sure that they make sense. This could catch things like a service not coming back up after you've changed the permissions on the Nginx config file, for example. This sort of process of sort of taking a snapshot before and after is something that I learned from a customer when I was consulting, and it's actually a really, really good idea. Using something like whatever it is that you have on, whatever agents you have on your systems to dump out the current state and compare it means that when you make changes like patching, where you're making a change that really shouldn't have any effect, it makes it much easier to gain confidence because you can dump all the state beforehand, dump all the state afterwards, and if only version numbers of packages have changed, then your patching was probably successful. But if version numbers of packages have changed and these 10 services are now not running, maybe it wasn't successful. It gives you something to look into and gives you a way to build confidence. These are all things that are free and really, really quite easy to do. The harder part is helping people to understand the relationships between things, which is really a critical part of a mental model, how things actually relate. And so this is what I've been spending most of my time on. The way that I think we do it, and the way that I've built Overmind to do it, is if I'm debugging, say, a website that isn't working, the first thing I'm probably going to do is use curl and hit that web endpoint, and I'll get some information that sort of looks like this. And there's a few breadcrumbs in here that I can follow to work out more about this application. For example, I could use dig to find some information about the DNS entry. I could parse the certificate and look at what's going on in there. I could look at the certificate that signed that certificate. And with each step, there's sort of more breadcrumbs and more breadcrumbs and more breadcrumbs, and that's what we do. I don't need to tell you this. That's what we do when we're trying to rebuild our mental models and understand what's going on. We're following these breadcrumbs, but we're doing it manually. What I've been trying to build is a system that can follow those breadcrumbs automatically. It can look at a HTTP endpoint, work out what queries it needs to make that are related to that, make those queries and expand and expand and expand. So I'm going to try a live demo here. We'll see how this goes. How do I mirror? All right, we're going to see how this goes. So I'm going to try and demo what it would look like to do the security group change, where I'm trying to work out where a security group is used so that I can confidently make a change to it and hope that it's not going to break everything. I don't have any Wi-Fi here. Or maybe I do. Or maybe I don't. Let's see. Or maybe I don't. Come on, Wi-Fi. All right. Fine. I'll do it this way. This is not the way I wanted to do it, but I can prove that it does actually work if you come and meet me later. But let's imagine that I have to go and find out the details of a security group. Why is that massively zoomed in? Don't know. So I'd go to EC2, I'd look at my security groups, I would type in the name of the security group and get some details. I don't know why that's zooming in like that. From here, we don't get much information in EC2. It tells us about the name, which is not very helpful. This security group has got an outbound rule, and it's got a tag, which sort of talks about a cluster called dog food. So that's giving me a little bit of a hint, but it doesn't give me a whole lot. So if I go over to actions and go delete, it does give me some hints. There's no API for this, by the way. You have to click the delete button. Then it gives me the network interfaces it's related to, so I can click on that, and I get some network interfacey sort of information, which is kind of helpful, but doesn't really tell me much about my my app. And at this point, I'm pretty much at a dead end. I followed all of the things all the breadcrumbs that it gave me. So what I'm going to show is the current version of Overmind, what this looks like. I paste in the same security group, and I get its details. This is making an AWS API call live. There's not a database here. So it goes and gets the details. We can see the description is shared backend security group for load balancer, which is useless as the descriptions go. But if I double click it, it's going to look at everywhere that security group is used from all of the data that it's seen before. One of the places it's used is this load balancer. The load balancer is helpfully called ingress, another really poor name for a component. And the details also don't tell me very much. But I can keep expanding because load balancers have targets. They tell you what their DNS entry is. I can map the targets, which are the IPs, and the DNS entry, which is that one there. Of course, I can do a lookup on the DNS entry, which returns me the IP addresses. This is all the same stuff I'd be doing manually, but just in a graph. We can then look at those IP addresses. They're related to network interfaces, which are related to that same security group which I started with, so we're definitely on the right track. If I expand the IP address, we can find what other things refer to this IP address. Where we find a DNS entry, if we expand the DNS entry, we can work out what things use this DNS entry. It gives us an HTTP endpoint. If we expand that, we just get some certs because the endpoint shows us some certificates. But at this point, we've got actually a reasonable mental model of what this application is. There's an API called api.df.overminddemo.com, which resolves to 3 IP addresses, or uses a DNS entry, which resolves to 3 IPs, which is the same as this load balancer, and that load balancer is used by this security group. The network interfaces are also related, so this is almost certainly what I would break if I was to break that security group. If I wanted to know what happens on the back end, if I look at the ingress load balancer and have a look at the IP addresses that it points to, I could expand that as well and then get the details of the EC2 instance that sits behind those IP addresses. And so this would tell me if I changed that security group, and where would I expect my monitoring to start yelling at me. Hopefully it would start saying that this EC2 instance is no longer getting traffic. Something's wrong, hopefully. But yeah, so at this point we've sort of done reasonably well. We've got pretty much a whole map of the configuration of this application. The important part, though, is that we did it without requiring anyone to put anything in from their mental model. We just started with the name of a security group and double-clicked and double-clicked and double-clicked. All of the links are generated just through following these breadcrumbs, and there's nothing that we've had to pre-configure in here in order to get this to work. And all of our solutions, whether it's this or whether it's something else, when things go wrong in the way that I was talking about, when they really go wrong, our solutions need to not require, this by the way is just what a EC2 instance looks like if you let EKS provision it. It has a lot of IP addresses. But if we're building solutions for this, the solutions need not to require us to have a mental model in order to use them, because we know we won't have one, because we know that the outage will have happened outside of our mental model. It will have caused us fundamental surprise, and we will be in the process of rebuilding and re-understanding how this thing actually works. So that is what the tool looks like now. It's in early access. You can sign up. I really want feedback from people. It's not something that you can pay for. I'm not expecting I'm not expecting to charge anybody for it. It's not for a while, at least. But you guys are great. You're sort of as close to my people as I think I'm going to get, and I would really respect your feedback. So if you wanted to try it out and give me some feedback, I would absolutely love that. But back to what we have learned. So we know that outages always happen outside of our mental model. They happen with the things that we don't know. Therefore, tools that require a mental model in order to use them don't help in these situations. Which means we need to make it easier to build mental models on the fly. If that means dumping your configuration file into a repo that people, all of your config into a repo that people can read and search easily, maybe that's what it means. We need to make it much easier. We need to make it so that when things go wrong, you don't have to have massive amounts of experience in order to navigate the command line, in order to work stuff out. We need to make it accessible for people to build those mental models without all the scars that we have, which we got from building them in the first place. Which means making our inputs more discoverable. So next time that you have an outage like this, think about how you can make your inputs more discoverable, have a read of the Stellar report. I really recommend it. It's excellent. And that is all. Thank you very much.
troll, Ringo.
All right, should we start? Welcome, everyone. So, my name is Ringo. As my colleague Lee Briggs this morning, I work for Pulumi, but yes, I'll show a bit of Pulumi, but it's not going to be a pep talk about Pulumi. I'm going to pick up a bit where Lee left off with the comparison on imperative and declarative tooling and the statements around that he made. Because yes, you still see once in a while a debate on whether imperative or declarative is the way to go. So here is one tweet, here's another, to go on the long-running battle. And yeah, then some people even think, or say, I prefer declarative, or I don't like that imperative thing. And that's not going to be for me help you make a decision. I'm just going to try and show you that to end the debate actually is just the debate in your own mind, and show you that both aspects help you to have their value. And not so long ago in this same room there was a very smart guy who said or tweeted the following: a hot take. Things can be both declarative and imperative. Trying to turn these properties into marketing wedges makes you ignorant, not smart. Thanks, Adam. Now, coming back to these definitions and also what Lee showed this morning. So with an imperative tool, typically you orchestrate the steps, but yeah, to find out what was already there is mainly up to you. With a declarative tool, yeah, you define your end state, and the tool will make sure that it tries to comply with that. Yeah? Now, a tool can be, as Adam mentioned, imperative and declarative at the same time. But what is the overall behavior that your tool manifests? Yeah? Is it really fully imperative, or do you have somewhere an imperative interface, but in the end a fully declarative behavior? Yeah? And this is mainly what I look at when evaluating tools and see what I can get out of it. Yeah? When I did software engineering, because I'm coming from a software engineering background, the only way how I improved my knowledge of databases, for example, is when I started to run the explain functionality or the SQL analyzer on my statements. Because only then, at that moment, I understood more of the inner logic of a database server and how it worked. And this helped me considerably writing faster programs. So with both of these pieces, look at what you can do with the tool in the end. So coming back to the imperative part is, you have a number of subsequent runs of your infrastructure code. And yes, on a first run, typically both an imperative and a declarative tool will create all of your resources. But what happens on subsequent runs? With an imperative tool, because you orchestrated the steps and the actions to do, well, your tool will create them again. Yeah? And if there is any conditional on your provider itself, which prevents you creating the same resource twice, well, that will fail, and then it's up to you to do the error handling, etc., etc. So with a declarative tool, which knows what it already done before, well, it takes it into account and says, yeah, but this and this and this already have done. Yeah? And we're over. With this definitions in mind, actually, let's see Chef as an example where you already mix imperative and declarative constructs. So this was actually a tool I landed upon when, let's say, the war was raging between Chef versus Puppet. Then two of the tools we use today, Helm and, of course, Pulumi, my employer. And then a new kid on the block from Solomon Hykes, his new company and his new product is Dagger, which is actually conceptually, and I'll come to that, also a combination of imperative and declarative, but to orchestrate your CI/CD pipelines. So first off, Chef. Yeah, I just mentioned I'm coming from a software engineering background. So for me, it's actually, yeah, I'd rather use a programming language. So the team for Chef started with Ruby as the base programming language and added a domain-specific language on top of that. Yeah? On top meaning they leveraged the Ruby constructs to make it as simple as possible to have a very shorthand notation to make sure to define your resources, but leveraging what the power of the Ruby programming language already has. In a Chef setup, you had some concepts, and I'm not going to dive too deep into that, but everybody knows about the resources you want to manage. Well, one resource is the minimal thing you could orchestrate with Chef. Then you put resources together in a recipe, and a recipe together in multiple recipes together in a cookbook. So if you take the example of an Apache server that you have to manage, well, the installation of the Apache package on your OS was the minimal resource. Together with the package, probably you need some additional config files, so that could be together in an install recipe. And then you had, next to the install recipe, more configuration recipes, also a delete recipe, etc., together making up the Apache cookbook. If you have a small example here, so coming back to that, the first line of this was already doing something. So in this, you got a package resource, and you gave it the name install Apache. And then you provided an additional block starting at the do on the first line until the end on how you configured that package object, that package resource. And in between, you already see that there's a regular case statement coming from the Ruby functionality. So based on what the platform attribute of our node was, if it was Red Hat CentOS or another derivative, the package name needed to be HTTPD. If it was an Ubuntu or Debian derivative, the package name was Apache 2. So here you already mix up the DSL that Chef made with pure Ruby constructs. So this is a simple example, but when you execute it, it's still declarative. As long as your node doesn't change and you're running that on the same node, the first execution will install that package, but any subsequent runs will already find that the package is installed, and then it will skip this resource declaration. The power comes actually when, you go further. What if we need to install more than one package? For the sake of the demo, I know Adam can correct me, you can have a whole array of packages immediately behind the package name, but just mixing it a bit more with some Ruby code, you just make a list of packages, and for each package in that collection, you again pass it a block, but in this case, it's a block with an argument. So the PKG is substituted each time, each run, let's say, of that loop. The first time with Apache 2, second time with Rails, and then the package block will be evaluated, and the first block, the first evaluation will install the Apache 2 package, the second evaluation of that each argument will install the Rails package. Now, this is an example where the list of packages is hard-coded. Now, doing a step further, and that's for me where the power comes with mixing imperative programming languages and still having declarative tooling, is where you can even say, okay, let me fetch that file of approved packages from an internal server from somewhere. That could come from your auditing or a security department. They review the list and publish that somewhere, and when we have to run it, we download that. And for each package in that, which is listed on a separate line, for example, in that file, we do the same construct. So this is, in short, why actually I liked Ruby, because I could mix in anything which was already available. And I wasn't limited to what the Chef team already constructed for me. Going to the current days, well, people for Kubernetes use Helm. So if you ever touched on Kubernetes, Helm charts, and probably after step 2, after you fiddled first with applying a kubectl apply, and you did some initial testing with pure handwritten YAML files. So Helm is considered a declarative tool. Now, it does have some imperative aspects to it. Yeah. So again, small example. So this is a snippet coming from the Prometheus template. So I only took the first 22 lines, but part of it is already static, part of the Helm file, but it is mixed with some imperative constructs, because on line 1, you can already see an if statement. On the first line, the part behind it is actually the dot operator coming from the Go templates. So with the Go templating engine, you are mixing in your values which come from a separate location, and you mix that in to see, okay, if some service is enabled, well, yeah, then indeed I have to generate the whole file, because this if on line 1, I didn't have the whole file, but it ends at the end of this template file. Next to that in the file, you see on line 7, for example, you see a toYAML, and also at the end of the line an indent. So here you have an additional 2 functions, and looping further, it's in total, even on 22 lines of YAML templating, you see an invocation of 6 imperative constructs. The if, a toYAML, an include, the indent. Then on line 10 you have an indent, and on line 14 you see a templating of even another property, which is even going further. Together with the dot operator, that mixes in quite some logic. But on the other hand, it's only limited to what the Helm authors actually allowed you to. So they started with the Go templating library, and they added the Sprig template library to it, which gives you sort of around 60 possible functions that you can invoke, but there it ends. And here are a few of the categories of functionality where these 60 functions can be categorized in. So this is not extensible without contributing to the project in a whole, and even without having your changes accepted to the project. That's for me quite limited. And on top of that, this is glorified manual code generation or YAML generation. It doesn't really, the fact that I even have to do the indenting and selecting the indenting myself, it's awful. So the previous two, so Chef and Helm, what is common to these tools is that these are all, the tool itself all runs in the same language runtime. So Helm is a compiled binary. It was written in Go. So this is a static binary. All of Chef runs in a Ruby environment. So this is the setup, single process, and done. So coming to Pulumi, there's a bit of a different angle here. Because people know Terraform, and you have Terraform binary, you have the providers. That's already 2 processes. But the language handling of the Terraform DSL also happens in the same Terraform CLI in that binary. Pulumi extracted actually the language processing also as a separate process, and now we have a setup with 3 processes communicating with each other. So all of these 3 types of processes run on your machine when you're running Pulumi. Now, if you run a Pulumi program, you have your language host, which you selected, so either a JS ecosystem, even Go, .NET, the Java ecosystem as well. So this is actually coming back to the directed acyclic grafting, where your language host actually orchestrates how your graph of resources need to become. So the language host in the end doesn't really provision anything. It's still our engine who does it. And that's what in the beginning confuses a lot of people, because they think, oh, I'm writing my infrastructure code in an imperative language. everything will be running exactly and in the same order as I wrote in the code. Well, too bad, no. And that's why I'm gonna show you in a small case actually how and where still the power of our engine comes from, and where you have a lot of flexibility to do that orchestration and creation of your resource graph. So this is a small example, very straightforward if you worked with AWS before. So we create a VPC, we create an internet gateway, route table which is linked to both of them, to both the internet gateway and the VPC, and then separate from it, but also linked to the VPC, is a security group. So first part is if we create a VPC, well, that does actually a register resource request over that gRPC channel to our engine. So in the very first phase, when your application is running, this is just sending instructions to our engine on how you want your resource graph to look. If we create a second resource, and there you see on line 8, there you see that I'm referring to the ID of the VPC, which was created just before that. Now, as I mentioned, the VPC at that moment hasn't been created yet. So that ID thing, what am I passing? So it's not the actual value of the ID. No, you can really look at it as a bucket where our engine will later on put the actual value in. But by passing that bucket from one resource to the other, here you create a link and a vertex in the end in your directed acyclic graph. Because here you see that then my internet gateway depends on my VPC. And that's a good indication for our engine later on to order the creation of the resources. So next up is in the end the route table. Here you see two references to two other resources. On line 15, we refer to the ID of the internet gateway, and on line 18, again, the same VPC ID. So that makes up the following graph by now. So the route table resource points to the two other resources in the graph. Completing that, we have a security group, and that only points to the VPC. So now our program has ended executing, but that doesn't mean that Pulumi has done working. So now actually comes the part where our engine will start using this resource graph and then compare it to the state, similar to how Terraform does it, and uses the providers to do all the proper creation calls. Yeah? And if this is the first run, yep, so then we really are triggered with all the providers are, in this case only one provider, the AWS one, will send the create calls for all of these resources. But in which order? Not in the sequence as the program made, but yeah, if you, based on graph theory, first of all, what needs to be, which actions need to be done, what are the dependencies, and then we, our engine tries to group these. So the VPC is definitely the first one. Then you have two resources only depending on the VPC, so that's the security group and the internet gateway. And as a last resource, actually, we end up with the route table only after the VPC and the internet group, internet gateway rather, has been fully provisioned. So the order is actually out of order as what you expect from the sequence in your application. Given that, yeah, the more complex your resource graph becomes, the more opportunity we have to run the creation of resources concurrently and to limit the time it takes for your infrastructure to come up. So looking at, again, the imperative and declarative thing, actually Pulumi has an imperative language setup which drives a declarative engine, which in the end uses, again, imperative calls to fulfill the desired state, because our Pulumi providers, similar to the Terraform ones, have a CRUD protocol, create, retrieve, update, delete. So this is really an imperative way, but driven by the engine, yeah, it makes sure that it's the engine in the end which is key to the whole Pulumi setup, making it declarative as the outcome of its total behavior. In short, this is what the Pulumi setup. Coming to the next one, the new kid on the block is Dagger. So the problem with, and I've encountered that multiple times, is I hate debugging CI pipelines. Because I always have to do a commit, I have to push it, I have to try it out, rinse and repeat. This is actually one of the premises that Solomon Hykes, the founder of Docker and now Dagger, yeah, which he thinks is, yeah, why can't we have a setup where even with containers, we can test our pipelines and do it locally, yeah, before we push it off to the hosted service, and where the pipelines can then run happily after they're locally debugged. So the high-level setup and the high-level architecture of Dagger is actually quite similar to the Pulumi one, although its purpose is totally different. So with the Dagger SDK, you also write your pipelines in code. If that application runs, it sends instructions to the Dagger engine, which also creates a directed acyclic graph of all the different build actions which depend on the outcome of previous steps. And that's what you model in the end also with the Dagger SDK towards the Dagger engine. Once Dagger is, let's say, fed with all the model that you wanted to have your pipelines to be, well, then it's Dagger engine which uses an OCI container runtime and starts off really executing these. Now, the nice thing about that is that they apply, they use Docker primitives or container primitives and check, are my inputs in my subsequent runs, are they the same as my very first run? Because if I'm feeding the same source files to be compiled a second time, well, I probably know that the outcome of my binary will also be the same. Yeah? So unless there's nothing changed to the inputs, Dagger says, well, skip this step. Hereby also improving a lot on the round trip time of also just testing and building your application. So this is the architecture. How does it look like? Well, they already have an existing TypeScript SDK. This is a very small thing of how you can, let's say, build a Node.js application immediately with 3 different Node.js major versions. So from the Dagger package on line 1, you start with importing a client and the connect functionality. You connect with an asynchronous callback function because, yeah, Node.js asynchronicity is core to a lot of these things there. We have a simple list of major Node.js versions, and then we say, okay, we first mount the host files, except for the Node modules which we use locally, but all the rest of the sources we mount as a volume into a container. But which container? Well, on line 14, you see that we are creating a container, but Node passed in with the Node version. So this is already looping over these 3 different versions and already starting parallel pipelines to build and test in each of these different runtimes. So once we already have then the container started from a standard Node.js version, we execute the client again and we say, with that container, mount our sources as /src, make it also the work directory, and then run npm install. Actually, this should be better. If you already have a locked package file, of course, this should be npm CI, but nevertheless. Then once the dependencies Node.js-wise are installed, from there on, we again run npm test, which is then probably a standard test target in the package JSON as a script, and done. And then we await the runner to complete the build phase if the testing was done And if it's okay, yeah, all the output files are exported again to our host file system, but under Node.js specific output folders. So what you have here is in code, immediately the setup for 3 different versions. And the nice thing is you can test this locally. You have full code completion on all the constructs in, to build up your pipeline. And yeah, I like code. So I fancy this. Now, yeah, I've shown all these examples, but why do we want all these aspects? Why do we want both aspects? Well, for me, the main thing, and definitely if you heard the term platform engineering, is integration. Yeah? I want to integrate, and we're talking about DevOps for years already, and breaking down silos and collaborating with everybody. But yeah, let's collaborate if each of our tools live on an island and we can't integrate. Yeah? And that's what I like actually about the code approach, is that you have a very easy way to integrate with tools that other teams use just by using and reusing the code. You know, it's not only about writing some infrastructure code then and, for example, running Pulumi up. No, it's what can I do with that code that I can even integrate with more ecosystems. Yeah? So, and there's 2 ways, in my opinion, of definitely if you're going back to tools like Terraform, Pulumi, 2 levels where you can integrate. First of all, more and better integration with between ecosystems, and I'll show you an example later on. But also then using and trying to embed these tools even in bigger and bigger automations. Yeah. So the thing is, the first is okay, the ecosystem thing. Yeah, people choose AWS CDK. Now, at first sight, this could look like an AWS CDK program, but actually it's a Pulumi program where we, as is, import AWS CDK constructs. And I'm looking to my far right because part of the work has still been done by Paul Stack. So in here, we only changed one thing. That's actually in the middle. I forgot to add line numbers here. It's actually that we are extending a Pulumi CDK stack. Yeah? So your core AWS CDK has already some standard CDK stack classes. Well, we only replaced one, but for the rest, the last 2 lines, for example, are directly from the AWS CDK libraries, is the EC2 VPC and an ECS cluster construct. But by wrapping it in a Pulumi CDK step, we remap that, and these become Pulumi resources. So this is one thing. Now you have your cluster running. So of course, now you need to install application on your cluster. So next step is, of course, yeah, we can also tap into the Helm charts that people already invested time and money in. So these are not lost. So Pulumi-wise, we also just download the Helm chart. You process it, you pass the values that you want to be passed on to the Helm chart, and we deploy it as Pulumi resources. Now, behind the scenes, what we do actually is a Helm templates equivalent thing, but then we remap these and use our Kubernetes support to deploy that directly as the native Kubernetes resources. The nice thing is also is at the last lines, you see what we try to look up. Somewhere in that Helm chart, there's a service deployed with a certain name. So we do a lookup, and then we take the IP, which is in the end attached to that ingress, and we return that as a Pulumi output so that that can be used later on to connect to it and to do very other stuff, like register a CNAME, for example, etc., etc. So I show these 2 examples separately, but in the end you can even mix all that together with more native Pulumi resources and done. But the nice thing even further is, and that's then the second example of integration, is building even bigger automations out of that. Yeah? What if you don't want to just run Pulumi up, but you want to give your developers a tool which immediately sets up approved infrastructure. So that's where you can either create a new CLI tool which embeds Pulumi, or which adds it to a workflow engine, which runs multiple steps of setting up infrastructure based on a new client signing up automatically on your website. Well, whatever. Yeah? This is all your brain power, your imagination, which is only the limiting factor to what you can do with code. Yeah? And to close up, actually, the how does such an automation API example look like? Well, on the top right, this is actually a normal Pulumi program, but in an async function. Yeah? So and then this function is actually passed on the one from line 15 in the example top right. You pass that on in line 32 in the example left. And then you actually have code which sort of simulates the same steps you would do otherwise manually, running Pulumi up, Pulumi refresh, whatever, setting config, this all in code. So this is now taking Pulumi, adding it to whatever you want to build, and then shipping that to your users, your customers, whatever. Yeah. So coming back and wrapping up to the message I want to bring is, yes, I've shown the bit of Pulumi, but the main thing is, if you're picking on tools, or selecting tools rather, make sure you understand the power, its shortcomings, and see if it still fits the bill. Yeah? What fit the bill 2 weeks ago might no longer be the case today or tomorrow. So make sure that whatever you choose, that you can collaborate, that you can integrate with either the rest of your company, with partners, companies, etc. Yeah? And with that, I'll leave you. Are there any questions? All right, thank you.
Ja, nu opeens wel.
Is goed. Hallo. Doet dit het? Hallo. Hallo, hallo, hallo. Everybody ready? Everybody awake? For some inexplicable reason, Brenno would like to be introduced by somebody, and he asked me to do it. So I'm absolutely convinced you don't know who I am, and I will leave it at that. But I ask for your attention for a very nice talk from Brenno about OpenCAD. Give him a warm applause, okay?
Hi, my name is Brenno de Winter, and I do stuff with computers, and I do that at the Ministry of Health, Welfare, and some other words, something like sport, as the Chief Security and Privacy Operations. But I'm not going to talk about myself. I'm going to talk about my cat, Keiko. My cat, Keiko, has a story to share because we had to stay at home during Corona, during COVID, and there was a lot going on. The government is by law required to undertake action all over Europe, so that's what we did. And then Keiko was watching television, and there was the minister who was talking about introducing some apps in the Netherlands for contact tracing and some apps for the research into, okay, who have you met and where have you been the last couple of days. I thought this was excessively funny because all of a sudden I heard somebody declaring that you can measure up to the centimeter exactly how far you are apart with Bluetooth. So I started to make a little bit of fun on it. And then they decided, okay, there must be something in the market that works. So they asked companies to give examples and show the solutions that they had for contact tracing. So there were 750 companies. Long story short, it was one weekend. After the 1 weekend, not a single company survived. Either it was privacy unfriendly, not sticking to the GDPR, or it was insecure, or the solution presented was basically a mock-up. Basically, there was nothing there. So, they had to do it yourself. I called it a mass of techno-optimism. And then the ministry called me and, hey, Mr. Big Mouth, if you know so well, come help us. So I thought like, okay, working for the government, for dinosaurs. One of the things that you need to have if you want me working for you is that if people start to abuse the data of citizens, they should be thrown in jail. The CIO said, oh, fine, we can make law, that's definitely no problem. So I went like, yeah, but privacy protection and information security should really be at the forefront. Well, fine. And I thought, okay, there's one escape left. We do everything transparent. Fine. So I started working with them, and just as an example, we built in a whole bunch of privacy features, also features that some other countries didn't have, and that worked kind of well. So even at moments when, for instance, Google turned out to have made a mistake, we decided to stop the whole project for 2 days, even risking that the application wouldn't survive that. And ultimately, everybody in the Netherlands was convinced that at least it's privacy friendly, it's secure, and also the software does nothing more than you promised to do. And everybody could have a look, which was kind of funny, because when we published on GitHub the first design, there was one newspaper said like, okay, the app is done, it's already out there, and we had to explain to people that GitHub doesn't work that way, there's a little bit of difference here. So we had a learning curve as well, but we published everything, pen tests, code reviews, and even if we had a version of the software that was released, we had a notary declare that the software we uploaded is the same software as the software that was on GitHub. That was kind of cool. And I also got to order an investigation if we built in backdoors, which apparently we didn't. I told already about that, and then something interesting happened. I was working, I believe, less than a month at the ministry, and one of the websites, in Dutch infectieradar.nl, infectionradar.nl, where you could leave all sorts of medical data, was basically compromised by using URL manipulation. So my first response was go to the CIO and say like, okay, don't you do pen tests in this house? So he came back to me with a document that said, this is the pen test. And the interesting thing was, there wasn't you couldn't see what they tested. You only could see the list of things that were broken. And this is, all of a sudden I realized, okay, this is what we use every day to get some kind of an audit value into technical research. If you want to convince me that everything is okay, you should prove to me each and every test. And at the same time, one of the Dutch cities was hacked big time, and they had a pen test report basically stating that everything was okay. It's actually not a big city, it was a very small city, Hof van Twente. But then still, that's still a big deal, of course, because all the data of all the citizens, all their systems, better few, were basically ransomware. And the only signals the mayor got was everything is okay, don't worry about it, security is totally under control. And then of course it turns out your network isn't segmented, and you all know the lists, I won't bother you with that. But again, the pen test didn't prove what it should prove. So what I basically did was actually very simple, make a procurement document to say like, okay, if you want to have a pen test, I want to see what you test, this is how you do the procedure, and when you find something, because some pen tests go like on a small issue, or which would be a really low CVSS score, they would go like, this is high. And I can't have that. I can't send a document to Parliament whereby somebody says like, I feel it's high. So we introduced CVSS as a measurement tool, and they agree up front what is high, what's not high, and thus be able to do a fair debate in Parliament. Well, that worked kind of well. And then we went on and actually say like, okay, if a pen test does have to have an audit value, it should basically be a test of all the security controls. And let's treat it like that. And that's currently what we're working on. Keep that in mind for 1 second, because this is going to be important in the OpenCAD story. At a certain point, one of the Dutch news media hacked one of the test streets, Corona test streets in Utrecht. And this was a big deal. And at a certain point, the Data Protection Authority said in the media, it's bizarre that the Ministry of Health is not doing pen tests for these companies. So we pay billions to these companies, and then they say like, yeah, it's bizarre that you don't pen test them for free. So Parliament asked us to start pen testing 70 companies with a small team. Bear this in mind. Let's get to the cats. We go back to December 15th, 2020. And vaccines were coming. The Netherlands was a little bit late, but we were like so excited. 2 shots and the whole problem is gone. I just had one question. And by the way, for the ones who do read Dutch, that thing you see on the left-hand side, it actually was it hung in several hospitals. But the question was, how do we register that? And the CIO turned in panic mode, and other people turned in panic mode, because basically no company was delivering a solution for that, so we had to do it ourselves. There was a lot of talking, and ultimately I just phoned hackers and say like, please do help. So a whole bunch of people got in, and I don't know if Mark Jans is in the room. He's helping out as well. He was early there already. But there are a whole bunch of people that came in. And for the Dutch ones, the Dutch-speaking ones among us, for groepsimmuniteit hier likken, that was hanging there the next day. It was cozy. And at the toilets, diefstal is zinloos, automaat wordt dagelijks geleegd. Then one of the managers came in and said to me, well, it may be that the Department of Defense will do the vaccination campaign. So I went like, yeah, so, same software, what's the big deal? Well, in that case, it may be that we have to have a code name for the project. So you've got 2.5 weeks to build a nationwide system. And the only question they have, do you have a code name? When I think of military, I think of cool Ukrainian people that save cats. So, this is my cat, Brani, and I cuddle her and then always say Brani Banani. So the project was called Brani Banani. And there shouldn't be a relation to the Ministry of Health, so we opened a so-called web shop, Brani Banani, the website for all your bananas, and will be opening soon. And behind this is where we built the vaccination campaign and the software that was needed. And every system was named after a cat. Brani Banani, my other cat that you already saw was Keiko, the Zyko, because she can be a real pain. And one other cat, Hero. So this is basically what we built in 2.5 weeks. Worked like a charm. If you think it's too colorful, here's the boring version. Keiko was angry. The other cats thought like, oh, you relax. But then one of the managers came and everything worked. And he said like, well, naming things after cats is stupid. So you have to pick other names. So then we called systems Harry 3, 4, 5, 6, 7, 8, and then his question was, what happened to 1 and 2? Apparently not a Star Wars fan. So we started to look very serious and say like, that's a very sad story. But then the minister said, I'd like the cat names remain. So on behalf of the minister, we name shit after cats. Well, back to back to the whole campaign. Belgium's had containers on the border, so having registration was important to at least be able to prove that you can free travel throughout Europe. So the European Union came with a whole bunch of information they wanted to have, and we as a team thought like, that's not what we're going to do. So what we only did was the first, if you go to the pub, the owner of the pub doesn't need to know that you've been vaccinated. So what we did was basically the first letter of the surname and the forename, and the day or the month of birth. That's specific enough to verify, but you don't leave any details if you have it printed and leave it somewhere. So, then of course, we use a phone. A lot of people can't use a phone, have other issues. So for every exception, we had to make a solution. So the number of projects grew dramatically. And every time the story was, sure, we're going to do that. Brenno, can you keep this safe? Long story short, there were too many projects with also too much information to handle, because it's not only the privacy by design, security by design. We had weekly DDoS attacks. You've got fraud. I didn't know jack shit about fraud. All of a sudden you had to learn about it. And the workload was ever increasing. And at a certain point, when people stress out, get heart failure, get burnout, somebody had a stroke, you start to realize, okay, this is not going to fly for very much longer. And then the interesting thing in security is we love to do things over and over again by hand. It's bizarre, but we do. And we start a tool, and that the tool delivers an answer, we throw away all the data, and we start all over again. So at a certain point in this whole heat, I realized we're not going to survive this. And we need to do something differently. So I called my good friend Jan Klopper, and he always has the story, okay, if you have got a difficult problem, you have to do the difficult part first and then the easy stuff. It's easy to start a company, it's easy to open a bank account, it's easy to get a logo, but it's not easy to fix the problem. And then you start to do with all the basically things you could do the last day and forget about the big issue. So this is what we did, and of course I'm stubborn, I had the photo already, so here's the logo. We built the kwetsbaarheden analyse tool, and it happens to be the Dutch, if you abbreviate it, the Dutch word of cat. But you could also call it the knowledge acquisition tool. And the most complex thing that we make is what we call the octopus. And the octopus is basically the heart of the story. It's a database, a cross-time database. So we have objects and we can see the status of an object throughout time. So you can have shifting time windows, compare statuses to one another and query that. To do that, because normally what we do is you get software in and basically, do it all unstructured. We have to get structure in first. But this is important. Why? We all know the needle of the haystack story. Go through a haystack, find a needle, everybody happy. And then say, find a railway card in the haystack, or find a pair of socks in the haystack. And I have to go through the haystack over and over and over again. So what we do is we first sort the data. Straw with straw, needles with needles, socks with socks, money with money, etc. And now if you say, I seek a needle from the haystack, it's there with the needles. Technically it looks like this, boring, but it works. While we were doing that, there was a scientific paper, and you will get all the slides, but there was a scientific paper written in Poland. We thought like, okay, did they see the code and write a paper, or are they multiple individuals across the world thinking about the same thing? I think the latter. But that's kind of cool. With every step we do one step extra. If you've ever received a pen test and ask sometimes for proof, then somebody will go like, yeah, it was 3 a.m. in the morning, I dropped my coffee on the keyboard, and all of a sudden I was rude. So it's not good. You know, they don't give you all the details. So what we do is with every step, we document everything. And we sign it, we hash it, and then we sign it. Hashing so that you know it hasn't changed. Signing so you can prove that at that moment in time, you had obtained that hash. And we keep everything we can keep related to the research. Yeah, sorry Keiko, how do you get to your data? It's very simple. The first thing we have is what we call REST calls. REST calls are basically plugins. You have a piece of software, doesn't matter what, existing solutions. We started in a container. That container, we maintain everything. What we put in, what we get out, and the network traffic, and the version of the software. And we hash it, and we sign it, and we store this. That's it. And ideally, the software does as little as possible. So Nmap is more than enough for one REST call. We store this in what we call bytes. I'll explain that in a second, but basically it's a document store. And in this document store, as soon as the document appears, we start what we call normalizers or whiskers, and we try and look what data do we understand. Because the data I understand, I can put in the octopus, in the database. And as soon as there is an object in the database, we start business rules. And the business rules are basically simple queries on the database. For instance, okay, there's a host. Is there an IP for version 6 address? If the answer is no, we'll create a new object saying there isn't one IP version 6 address. Because we have got this notification, we start a second query. Are there 2 IP version 6 addresses? Well, if you haven't got 1, you haven't got 2. Now we've got a new finding. The third finding we make is if you haven't got 2 addresses, in the Netherlands we've got this website called Internet.nl, and it's seen as a standard of good behavior on your website. If you don't make 100%, that's a third finding. But if you don't have 100%, it's in the Netherlands technically impossible to have what we call safe email in healthcare. Now, I started off with one query saying I haven't got an IP version 6 address, in general, an informational. But as a ministry, not being able to deliver medical results in what we call a safe way is critical, because, you know, that could be the end of a career of a minister. So now I've gotten from a technical point to a compliance point, all by having one fact. Now, if the REST call that delivered the data finds an IP version 6 address, and the second one, we will automatically detect it and, of course, take down all the notifications. But we have got proof that we discovered it, we saw it, and we saw also that it was fixed. We've got a whole bunch of boofjes that we have made. We put them in a catalog. Yeah, we keep doing this. You know, making software is a lot more fun if you do a little bit like this. You know, you know, it's the funny thing is, because it's an open source project, we had now this one organization who made a REST call about DICOM. I didn't even know what it was, but it turns out that X-ray equipment, certain X-ray equipment in the Netherlands, you can is DICOM, and if you put that on the internet, of course that's a bad idea. Somebody once made a script, forgot all about it a year later because, you know, everybody took their machines offline. And he made a rescue of it. And because of that, we could warn 14 hospitals, hey, watch it. It's a use case I would have never thought of. So we've got this data store, bytes. And the cool thing about bytes is I already told you, okay, it's all the data there, but I can now also do something very interesting. If I want to normalize this data, and I don't understand something, it won't be in the octopus in the object model. But if somebody writes a new normalizer or updates the normalizer and I start to understand something, I can update the data model at a later moment because I didn't throw anything away. And this is kind of interesting. For instance, suppose if you download the website, the front page, and there's nothing special there, and all of a sudden you say, okay, this little line of code means that you've got a crypto miner on your site. I now can discover it, but I can also prove when it was the first time that I saw it. Forensically sound. Saving you a shitload of money. And you know exactly where you have to look. The business rules, they're called bits, are basically simple queries. And you can, we've got, one of the developers made one business rule in 40 seconds recently. It's really simple to do. And the only thing is your imagination is the only limit there. But starting boofjes all the time makes Keiko tired. So what we made, of course, is a scheduler so that we schedule all the boofjes at a certain point so that you do your research on a, for instance, daily basis. Now this is interesting because if I have a new object, for instance, an IP address that I found, the scheduler will say, okay, we need to start the following boofjes or rascals now to add more information to it. So adding simply one IP address might also make a lot of difference there already. So basically you sit down, relax, and this thing is always on. But one of the rascals can be looking at common vulnerability exposures. So for instance, if you've got log4j, it comes in, and since we've got a software bill of materials, and we could exactly say this, and these systems are vulnerable. We had one example of a company that did corona tests. They used WordPress, and at a certain point there was a 9.8 CVSS score in a CVE that came out. And somebody of my blue team came to me and said, like, what should I do with that? So I went like, oh, I'll call the director. And from the moment that, that the CVE was uploaded till the fix was less than 10 minutes. And at that point I realized, oh gosh, this is cool. Well, how can you use it? We've got an interface called Rocky. It's kind of cool. We, of course, do things like aggregation, filtering, blah, 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 all the usual shit. And then we've got something really cool. With all the projects that we did, we realized we had to make a lot of interfaces. So we started a different project called Manon. And Manon is basically a project that if you've got a certain look and feel, you can enforce it everywhere. So basically, that's also now open source to reuse. So if you use cat, it doesn't have to look like cat. I do like if you keep the logo, but you know, you don't have to. Of course, we've got a knowledge base filled with data that helps with making reports, because these reports will then, of course, give all sorts of contextual information, because ultimately somebody in management will need to read it and they don't understand everything. And where does Keiko come in? No, not in the news. Keiko is our reporting tool. Actually, Keiko also has a column now in ICT Magazine in the Netherlands. But Keiko is the reporting tool, which is very complex software, LaTeX and Python. And yeah, it works. Why not? So we launched CAT on October 4th, 2021, which is World Animal Day. We let it run with the companies that we had to watch. And even though they had to deliver a normalized pen test, as I've told you, we found hundreds of advisories. And why? Because we look different at data. We had to send out hundreds of advisories. Some are just informational, true, but some of them were critical as well. With that, we have to have people who are able to do so, so we need a SOC. And then I thought of something else. If I say you can go live with a with errors that have a CVSS score of less than 4.0, or else you're not allowed to put your software live, the logic would be that if you have software running and all of a sudden it appears that you have a problem with a higher score, you've got an incident. So what we did is every CVSS score 4.0 or higher is dealt with by our SOC. And this is a deliberate choice for two reasons. Force the pen testers to write it down as clear as possible, because they're not allowed to talk to the end customer if it's not really needed. And make sure that our documentation is of high standard. The second one is I want somebody to have a look at it. Oh, this product again. Oh, this routine again. So you want to build knowledge on our part. Okay, what is good and what's not working. Since we're talking about a security operations center, it's not open source yet, but we'll open source another project. It's so bizarre. You do everything privacy by design. And then at a certain point, you have a log file, sometimes with all medical data in it, and then there's a security operations center, and they can't touch everything. So I decided that's not going to fly. What we do now is have first a procedure. Think about the use case. Don't look at data. Think about what can go wrong. We also do for risk assessment, we do failure mode effect analysis. So how does failure work? Think about that, and then make your business rules, and basically that is what you put into the system. Every business rule that they make, or every use case that they make, it has to go through the privacy team. Aren't we violating the privacy of the citizens? Then they are going to build it. Then I have it checked if what they made is the same story as what they told us that they were making. So we have got the whole circle around again. And then basically we've built a project called Kelvin. And Kelvin basically is Apache Kafka, and it will give you the log lines of interest plus what could be related. And now I've reduced the vast number of log lines that people could go through to really a small subset of it which is relevant. Making sure that people are not, going through your and mine data when it's not really needed. So that's Kelvin. And of course, when there's a finding, it goes back into CAT. We start to see if we can enrich that data with what is there. In the future, there will be another project, and that is Otis. And Otis will be an app with an X509 certificate where you can sign stuff. For instance, if you've got a manager and he says, like, I accept this risk, sure. Sign it and we'll turn off the alert. But you will get a PDF saying, official declaration that you accepted this risk. And then see how much fun it is. Also, if you've got a pen tester delivering a pen test, they can sign so that you can verify, and the software will verify if it's really an OSCP or an OSCE certified person, or if you have an auditor signing off on the findings. And in the ideal world, CAT will get to the point where you can switch your entire network off, and because of the database and all the signatures and all the hashes, you can still prove that everything is okay. That's what I'm after. Because maybe you have seen documents signed. This is how I bought a house. This is bizarre. And this is what we call legally sound, really. So this is basically OpenCAT.nl, our project. It's international, it's open for everybody to join. Or if you say like, okay, I need help, you know, there's an email address. We love to be in touch, because we really want to make this fly. And maybe there are a couple of questions. I've put some sample questions here, so if you have one, just let me know.
How do you get interested in pictures?
Sorry?
How do you get the pictures?
Oh, it's developers send it in, but also that's kind of funny. Because we're going through the entire Dutch government in the meantime, and like hospitals joining, and people say like, I've got a cat, and can we send a picture in? So that's definitely a yes. The answer to dogs is definitely no. I don't dislike dogs, but just because you can say no. And maybe mice, we will use that in the future as well. Yes. No, but actually the one big thing that I'm after is a general, a simple upload facility. If you want to do compliance, not everything is technical, so you have to have documents as well. So there will be an upload facility where an auditor can sign off, okay, you've got this document, and it's existing, and the procedure is existing. And I've got to tell you one thing. Because we keep a log of everything, when an auditor comes by and says like, okay, you've got this procedure, we can show procedures, but also when it was put to use. So in Dutch we call that opzet, bestaan en werking. Where we can prove the full circle. So yeah, there will be upload facilities, and probably you can upload cats and cat sounds.
I see your project is actually quite new,
Yeah.
relatively new. Can you tell me what's your future roadmap and what your current obstacles are?
The future roadmap for the oncoming time are two big compliance questions. One is ISO type of certification, as 27,000 for instance. And the second one is we've got this new law in the Netherlands that forces people in the healthcare to exchange data. That are tens of thousands of organizations. I don't know where we would find auditors to do so, and I don't know how you can connect or disconnect them. CAT would be an instant validator if you stick to certain rules, so if two parties could interconnect or not. That's one of the things we are looking at. Current obstacles are COVID is nearly over, so there's of course discussion of how to move on. That's not one I'm most worried about. Other obstacle is this will only fly at the end if we've got a lot of business rules and a lot of boefjes. So we need help. And if I may dream, we started off in Dutch, English, and Papiamento because of the Caribbean islands. And now a company is adding a Frisian language to it. So we've got all the legal languages of the Netherlands now. But I would love to see German, French, Italian, etc., because then it will really grow. And I think it's still funny that one day we'll be at a point where you can print the pen test, because you also can put all the results in the next version. What we can do is you can run a tool and then, not use the scheduler, but upload the data that you acquired. And then, of course, generate your pen test and then deliver it to a court in Frisian, because they have to accept that.
Why not claim what is the top level domain .eu?
Sorry?
Do you not claim the top level domain EU? Well, no, I mean opencap.eu.
Oh, this is a very simple one. It's bureaucracy. So there's one department. We are not to register it. We have to go to the Department of General Affairs. They are very cool people, but one of the rules is they don't claim this. Any
Is there an indication about how much data you'll accumulate with?
Yeah, that's. This is a tough question. If you, for instance, at google.com, they've got a lot of subdomains, and that will grow rapidly. But for the companies that we watched, that was definitely in the beginning days 100 gigabytes. So that wasn't actually. Of course, the other data in the data store that can grow big, but we've got automated retention, because you're not allowed to save all data as long as you would probably sometimes like to. So it's hard to say exactly, but a normal VPS suffices for most use cases. But that's something we're still learning. And talking about an obstacle, I think performance in a big environment, of course you can scale all the hell out of it, but do it in a nice way. That's going to be one of those nice obstacles. Because I don't want to only through computing power against it all the time. Any other questions?
Compliance part, the right to be forgotten, how does that factor into this?
Oh, that's simple. If we've got a mechanism of throwing data away. So if there's personal identifiable information, that's for us easy to do. But in general, except from log files with system administrators and of course users, but furthermore we don't process personal identifiable information. That's not our use case. But we use XTDB, and of course somebody could put in a different use case, because it's really simple to change the database with JSON. They're just JSON files. So I could imagine that somebody did such a use case. Yeah, we've got big warnings like, sure, fine that you do that, but do your data protection impact assessment. And we don't go live without a proper DPIA. We just don't do that. Yeah. But this, if you want to do identifiable information, that's going to be a challenge. Because somebody could enter up in the database that maybe shouldn't be there, etc. Any other questions? I was hoping about the French cats, but okay, you don't want it. Am I still on time?